Okay, hi guys, very good morning everyone. Welcome to this next important mega marathon on signal and system. Very good morning everyone and happy Republic Day to all of you. Yes guys, very good morning. The session is live. Quickly update with all your friends that the session is live. Everybody can join because this is going to be very good morning everyone. Welcome to this next important mega marathon. Morning everyone and happy Republic Day to all of you. Yes guys, so audio and everything looks fine. Very good morning everyone. Let's let everybody join quickly. So it's a lovely cool morning here. Okay. So yes guys, let me quickly know in the chat box how many of you are ready for this entire full day non-stop mega marathon on signal and systems. On signals and systems. Come on. Let's see how's the Josh guys. How is the readiness? How's the Josh? Come on everybody. All right. Yes. Come on, everybody be attentive in the comment box. Let this session be a two-way interactive session. Okay. Right. And you must also be ready with your notebook. Okay. So as you can maintain the notes parallelly, of course, I'll share you that PDF. Don't you worry, as always. Okay. Yeah, keep your calculator, the virtual calculator ready, because signal and system is more about how you understand and solve the questions. So there will be lot many questions today, but of course we'll keep revising the theory. We'll keep reviewing the important properties, and we'll solve the important models of questions. Okay. And so as to take up the question, keep everything ready. Your calculator, virtual calculator only, don't use any scientific calculator now. Okay, it's just a killer for you. And you be ready with the virtual calculator, be ready with your notebook, and yeah, be ready with any sort of refreshments you need to have, because it's going to be long marathon. Of course, when required, I shall give you a small break as and when required. Okay, but keep anything that you wanted, water, fruits, anything, just get it be ready for you, right? Just let that be ready for you. Okay, so now let me tell you guys that whether you wanted a quick revision, or yeah, whether you are looking okay, to prepare signal and system, provided you have not prepared it earlier. Okay, so then in either case, this one day marathon is going to be fruitful to you. Okay, all right. Okay, just also let me see the branches. How many of your EC or EE or IN? Okay, just comment in the chat box. Just comment in the chat box EC, EE, IN. Let's see how strong the signals batch is today. Come on, everybody. Okay, come on, everybody. Let us get started. We'll come up. Okay, we'll come up with control systems as well. Don't worry. And as I promised, this time I'm going to come up with the aptitude marathon also on the OM YouTube channel. All right. Let me also update you. Okay, the mega marathons, you anyways know, started 25th of January. Okay, yesterday there was an excellent session taken by Hemant sir. If you by chance missed it, it is available on the OM Institute YouTube channel. So you can still, check the channel and watch it as and when you are free. The digital electronics marathon that was conducted yesterday by Hemant sir. That's why just be subscribed to the channel. That is why, so that you don't miss any of the sessions happening. Okay, all the marathons will be there. And tomorrow there will be an important marathon for electrical engineering aspirants, and that is on electrical machines, to be taken by your favorite Surendra Reddy sir. Okay, Surendra Reddy sir. The next session you are going to see on machines. Okay, the next one is going to be on machines tomorrow. Okay, yeah, network will also come. Just wait, step by step. Okay, I'll tell you the next two. Next is machines, and then thereafter 28th. Okay, you will see the marathon on analog circuits. Okay, by Gautam sir. Okay, analog circuits by Gautam sir, that will be there on 20th. So I shall update you about the marathon. Then Giri sir will be taking power system. Hemant sir will be taking yet another marathon on EMTL, and probably he might take another session on digital as well. Okay, and Shankar sir will be taking the session on power electronics. So all of this is going to come up. I'll again come up next for aptitude marathon as well, right? And probably some session on control system as well. Okay. Okay. Right. Okay. So that's what I told you. Whether you are not prepared or whether you're looking for revision, in either case, this marathon is going to help for you, because I'm just not going to solve the question. I'm going to take up, okay, the theory, and I'm going to take up, okay, the questions relevant to it. Okay. I made a short video yesterday wherein I mentioned that why many students lose marks in signal, because their revision and preparation is unstructured. Okay, they don't really focus, they just, mostly focus on basic topics. Yeah, sometimes basic questions are also important, but you have to see from which area majority of the questions are coming. Okay, so let's have a, before I begin up the session, okay, let's have a slight analysis of the past 5 years. Okay, because 5 years are more of a storyteller, the real storyteller. Okay, the real storyteller, right? Okay. See guys, I've divided the signals course. This is EC and I'll show you EE as well. Don't worry. Okay, I've divided the entire subject into different chapters. Number 1, classification of signal and system, including the basics of signal and system. Okay, wherein for EC there have been total 3 marks as of now from the past 5 years. Okay, LTI systems. Okay, the questions around convolution. Okay, these have been good in number. 3 total 6 questions have been there. Total 9 marks. Okay, and then DTFT and CTFS, very important. Okay, 3 plus 4, 7 questions is there in 5 years. That means more than 1 question on an average per year. Total 11 marks. Okay, sampling theorem, 3 questions, total weightage 5 marks. Okay, Laplace transform. Okay, directly, I mean, some questions are differential equations that you can solve by CF and PI as well. Direct Laplace transform question nil in EC in the past 5 years. Okay, Z transform also has been little less weightage, 4 marks only in the past 5 years. Okay, and DTFT, DTFS and DFT. Okay, this is important one for EC, and this has amounted to 12. Okay, this has amounted to 12 marks, especially DFT being very important for EC. In fact, all 3 important, DFT slightly more important. Okay, so yeah, problem solving, signals is more about problem solving. Don't worry. Okay, see guys, if you have reserved your day and if you have, joined today, just keep the trust throughout the day. Okay, wherever required theory, I will focus on theory. Wherever required more on problem, I will focus on problem. I have been looking into this subject from past several years. Okay, so I know what is really important for you. If I am also giving my day entirely on YouTube, okay, I will also require my students to gain maximum. So don't worry. Okay, just be ready with your assets, be ready with your notebook and virtual calculator. That's it. Okay, and your dedication is what is important. Rest you leave it to me. Wherever what is required, I will handle it accordingly. Don't worry. Okay, let me go to the electrical. Let me go to the electrical analysis for the past 5 years. So if you look into the electrical analysis for the past 5 years, okay, now see, electrical, there has been a significant portion on classification on signal and system. Okay, 12 marks, that is total 8 questions in 5 years. Okay, on an average more than 1. Okay, per year, definitely. Okay, then if you look into convolution, again a good weightage on convolution for electrical engineering as well, 11. Okay, CTFT and CTFS, 11 marks. Okay, again, okay, that means, I'll tell you, these are 2 areas, convolution and CTFS, CTFT, which is important for both EC as well as EE. Both EC as well as EE. Okay, dear, it is important for both of you. Okay. Sampling slightly less important for electrical, just 1 question can be seen from past 5 years. Laplace transform, again just 2 questions, total 3 marks. Z transform, again only 2 questions, direct Z transform 3 marks. DTFS, DTFT, DFT. See, DFT you won't directly find questions in electrical, I would say. Okay, but you can't discard it also. There have been a question related to DFT. Okay, but in fact many electrical students, they think DTFS and DTFT they should leave. It is not their thing. But you see 4 questions, okay, in the last 5 years, and it has been recent trend. I mean, if you go before 2020, you will find hardly any questions in DTFT or DTFS in electrical, but recent years they have been asking. So next year also, next to next year also, it can be expected. Okay, so this is also an area, okay, where electrical students should not miss out. Okay, but yeah, that means convolution and CTFT, CTFS, these are 2 areas important for both EC, EE. Okay, for electrical classification of signal system, more important. See, for EC also it is important, classification of signal system. Only thing is, direct questions they may not be asking, but let me tell you, 2 important classifications if I tell you. Say for example, periodic and aperiodic signal. Okay, right. Periodic and aperiodic signal. That is what is totally required in the Fourier series discussion, CTFS and DTFS, that you should know. Energy and power calculation keep coming throughout the subject. So these are some areas that you should not miss out. Okay, that are not miss out. Raj, the session has already started. You should see this. Okay. So that's what in the beginning I wanted to give you a clear idea that how the things have been going with reference to past 5 years. Okay, so that you know after this today's session also, when you are solving again, when you are practicing, when you are revising, you should be knowing where to target more and more. Okay, where to target more and more. Okay, now time to get started with the first concept of the day, which I am picking up: periodic signals. Okay, based on the importance of the topic, I have designed the sequence of the today's marathon. Okay, I will become up today with the concept of periodic signals first of all. Okay, so see, you all know what periodicity is: repetition. Okay, the value, a signal whose value keeps on repeating after every fixed interval of time. Okay, whose value repeats after every fixed finite interval of time will be known as a periodic signal. Okay, the duration of time after which repetition happens is the time period. Okay, so what is this? This is what is known as the time period. Okay, now what is the minimum value of time for this waveform? It's like a rectified, this, what is this waveform? It's a rectified sine wave in front of you. Okay, and what is the minimum amount of time after which repetition occurs? That is known as the fundamental period. Okay, that is known as the fundamental period. So this one is fundamental period. Okay, so you know, if you call this as fundamental period, be ready. If I ask you the value of the signal repeats after what time? It repeats after minimum one amount of time, but then it repeats after, but then repeat after, not only it repeats at 1 unit of time, the value you can see repeats at 2 units, 3 units, etc. Okay, so in general, if I ask you what is the period of the signal, the period is 1, 2, 3. What is the finite? What is that finite amount of time after which repetition occurs? Is 1, 2, 3, 4, etc. Yes, PDF will be shared to you, don't worry. Okay, PDF, complete PDF will be shared to you. Okay, so that is what. Okay, so if t is the period, then 2t, 3t, nt will all be the period. So the smallest possible value of the period, that will be known as the fundamental period. The smallest possible value of the period, that is fundamental period. That is what I have mentioned here. Okay, and then the reciprocal of fundamental period is the fundamental frequency. Okay, in hertz you write it as 1 by t, or omega. Okay, in angular frequency. Okay, radian per second you write it as 2 pi by t. Okay, now for a signal to be periodic, important thing is it must have the existence from minus infinite to infinite. For a signal to be periodic, it must be periodic. Not only, it's not that it repeats 2 or 3 times, it should repeat continuously from minus infinite to infinite. Okay, now look into this waveform. Okay, some more basic examples of periodic signal. Suppose if I wanted to ask you what is the fundamental period corresponding to this signal. Okay, so what is that fundamental period? You can either mark up center to center. Okay, or you can mark up the beginning to beginning. Okay, so this cycle begins at -1, the next pulse begins at 2. Okay, so what is the difference of time between them? Is 3 units of time. That is the fundamental period. Okay, similarly, the and again, as I told you, it has to be repeated from minus infinite to infinite. Okay, similarly, another periodic square waveform has been shown in front of you. Now let me come to one simple straightforward question in the beginning. Okay, let me come to the simple straightforward question in the beginning. Okay, so rather I will make the question reverse. Okay, let's make it as a MSQ question. Which of the following signal is periodic? Okay, answer it reverse. Which of the following signal is periodic? Okay, let me also see the basic testing. Okay, let me see the basic testing for you. Okay, which of the signal is periodic? I have made it reverse for you. I have made it reverse for you. Okay, now the first two options are sinusoids, and in continuous time domain, sinusoids are always periodic. The difference is discrete time domain, and there have been questions in GATE from discrete time sinusoids directly. I will show you those questions. I will discuss about discrete time sinusoids as well. Okay, which of the following signals is periodic? Reverse question, MSQ. Okay, so option number A and B are definitely periodic. What is the first thing you should know it? In continuous time domain, the signal A sin omega t or A cos omega t or A e power j omega t. Okay, where you know that A e power j omega t can also be written as cos omega t plus j sin omega t. Okay, and all these three are always periodic. All these three are always periodic, having the fundamental period of 2 pi by omega, omega being the fundamental angular frequency. Okay, so A and B are, without anything, you should say it is periodic. Okay, without any doubt, you should say periodic. Okay, now option number C, the signal multiplied by unit step signal. Okay, cos 10 pi t into ut. Cos 10 pi t into ut. Now, we all know what is unit step signal, na? Okay. What is unit step signal? Ut is 1 only for t greater than 0 and it is equal to 0 for t less than 0. See, guys, step signal, ramp signal, I'm not discussing separately, but as and when required, some discussions will keep happening. I will keep adding, okay? But I don't want to make it a separate topic. Okay, because we have lots to cover. We have, Fourier transforms, Fourier series, Z transforms to covered. Okay, so that's why I want, any basic top thing is there. I will keep telling you when required. So unit step, you must be knowing that it takes the value 1 only for t greater than equal to 0. Okay, so that means what about the cost 10 pi t ut? Okay, cos waveform. If I asked you to draw cos waveform, this is what you will draw. But because it is multiplied by ut, it will not exist on the left side. It will not exist on the left side, correct, na? It will not exist on the left side. Okay, it will only start from origin and on the left side it will be 0. Okay, and as I told you, for a signal to be periodic, it must exist from minus infinite to infinite. So this is not purely periodic, rather we give it a name. The signal which is periodic for one side, switched periodic. Okay, it is going to be switched periodic. We name it as switched periodic, but we will not mark it as the answer. I wanted a pure periodic waveform. Now, next one, even part of cos 2 pi t ut. Okay, even part. How do you write down even part of any signal? Okay, how do you write down even part of any signal? Okay, so even part of any signal, xct, is given by the formula xt plus x minus t whole divided by 2. The odd part of any signal is given by the formula xt minus of x minus t whole divided by 2. xt minus x minus t whole divided by 2, correct? Okay, whole divided by 2, correct na? Okay, that is what the definition. So what is this option number D demanding you? The option number D is demanding you, rather I'll solve it here only. What is there? Okay, the even part of this signal. What is the even part of this signal? Okay, suppose this is xt. So xt, that is cos 2 pi t ut plus x minus t. Okay, cos minus 2 pi t u minus t. Just replace t by minus t and whole divided by 2. And whole divided by 2. Okay, now what is there? Okay, 1 by 2 I'll take right side, outside, but cos minus theta is cos theta. Okay, that means cos 2 pi t also outside. What is then left is ut plus u minus t. Now dear, what is ut plus u minus t? What is ut plus u minus t? Okay, what is ut plus u minus t? Okay, any relevant discussion let me do here. Ut, as I told you, is a signal which takes the value 1 for t greater than equal to 0. So when you draw the u minus t, what is the u minus t? Mirror image. Okay, time reversal. Okay, time reversal. If this is ut, something of this kind, what is u minus t? U minus t of this kind, that it takes the value 1 for the left side for negative values of time, correct? So when you add these two, okay, when you superimpose these two waveform, what do you get? You will get a flat one, na? One which is on the left side, one which is on the right side also. So you get a flat one, and ut plus u minus t is equal to how much? Is equal to 1. So what is the signal? Half cos 2 pi t. That's a pure sinusoid left, and hence it is going to be periodic. Hence it is going to be periodic. So D, the correct answer for this question is 3 options correct, that is A, B and D. Okay, the 3 options have been correct here, and that is going to be A, B, D, right? The 3 options which are correct here are going to be A, B and D. Okay, everybody? A, B, D. Chalo, A, B, D, not C. C is not the correct answer. Some of you are telling C. It is going to be A, B, D. Okay, remember, now I'm just adding on to one point. Where is that? Okay, adding from this. Why it's not activated? Just a second. Okay, so guys, I'll add on one homework to you. Okay, think about whether this signal is periodic or not. Even part of sine 2 pi t ut, even part of sine 2 pi t ut. Okay, and second homework for you is odd part of, let us keep it as sine only, odd part of sine 2 pi t ut. Odd part of sine 2 pi t ut. Okay, these are the 2 things I want you to solve. Okay, now there will be few homeworks that I will keep adding, and I will number it as homework number 1, homework number 2, homework number 3, etc. Okay, what you are required to do later on, Not right now, later on when the session is over, by after today evening. Okay, whatever you have solved, please mention your answer in the chat box, in the comment box later, not in the live chat box. After the video is over, in the comment box you can mention your answer. Okay, you can mention your answer. Okay, so homework, you can mention your answer by mentioning the number. I will reply to it. It's homework number 1, homework number 2. I will similarly keep numbering to it. Okay. So, what is the first thing that you have recalled today is in continuous time domain, the sinusoids are always periodic, irrespective of the frequency. It is always periodic. The difference will be in DT domain, that I will tell you. The difference will be in DT domain, that I will tell you. Okay. Acha, what is there? Let me go to that DT domain question. Let me tell you the DT thing first. Forget this. Okay. Let me come to the DT periodic signal as well. Okay. Let me come to DT periodic signal as well. What is there? Okay. A DT periodic signal, of course, a signal, as the values are missing here, I'll write down, say this is 2, 1, 1, this is 2, 1, 1, this is 2, 1, 1, etc. Okay, a signal whose value again repeats after every fixed interval of time. Okay, every fixed interval of time is going to be a periodic signal. Okay, this minimum amount of time, like here 0, 1, 2, and this is equal to how much? This point is 3. This is the fundamental period 3. Then again I'll tell you the same thing. If the period of the signal is n, if the fundamental period is n, then 2n, 3n, all of them can be considered as the period in general. Okay, so this is what is again a basic DT periodic signal. Okay, now let us come to the DT sinusoids. Okay, let us come to the DT sinusoids and answer me this question. Then I'll tell you the relevant theory. This is important for you. Okay, yeah, you can also say maybe the homework I am giving, maybe it was not periodic. Then you can call it as aperiodic. If you don't have any period, okay, you can call it as aperiodic. Okay, if the signal is not periodic. Okay, so we'll figure out. Now sin 2n, you have to search sin 2n. Now see here. Okay, this is a DT sinusoid. Okay, this is a DT sinusoid having how much omega? The omega is 2. Okay, the frequency is 2. Okay, now normally what is the time period you say? 2 pi by omega. Time period you say is 2 pi by omega. That is 2 pi by 2, and that is equal to pi. Okay, so can you say that this signal is periodic with the period pi? Okay, can you say that this signal is periodic with the period pi? No. This is absolutely wrong here. Why? Because what is the thing that you know about discrete time signal? That discrete time signal, the discrete time signal is defined only for, the discrete signal itself is defined only for what? Only for integral values of time. Okay, that is why this time period, okay, the time period n, okay, here, this time period n, okay, must be integer. Okay, the only difference here is the continuous time domain signal can have any sort of time period. Okay, but in discrete time domain, I mean, if I asked you this question, okay, if I asked you the question like this, if the question was, same question was sin 2t, then you will 100% call it as periodic. Just you can close your eyes and say the answer. Continuous time sinusoid means periodic. Okay, means periodic. It is 100% clearly visible. Ramu, I am watching the session parallelly. I am just not only taking, but the screen is also in front of me. The screen and session is totally visible. Okay, now this is periodic. How much is the period? Here you can say the period is 2 pi by 2. That is equal to pi. That is equal to how much? That is equal to pi. The period is equal to pi here. Okay. The period is equal to pi here, right? There it is allowed, but here the period cannot be pi in the discrete time domain. Okay, right. Now next case. Okay, here what is the answer here? Okay, here what is the answer? The signal is aperiodic. The signal is aperiodic here, right? Okay. Now sin 2 pi by 3n. Okay, sin 2 pi by 3n. Okay, so what is the value of, so rather than calling the period as 2 pi by omega, we'll first check the value of 2 pi by omega. What is the 2 pi by omega here? Omega is 2 pi by 3. 2 pi cancel. This is equal to 3, and this is directly integer. Okay, so when 2 pi by omega is an integer, that is not a problem. Then that integral value is your answer. Okay, then the integral value is the answer. Finished. The time period is equal to 3. Okay, right? Now sin 5 pi by 3n, next case, sin 5 pi by 3n. Okay, what is the 2 pi by omega here? 2 pi upon 5 pi by 3. Okay, so what get cancelled here? Pi will still be cancelled. 3 to 6 divided by 5, and this is not integer. So is this signal again aperiodic? Is this signal again aperiodic? Is this signal again aperiodic? Is this a signal again aperiodic? No. The difference is this signal is going to be periodic. But why? But why this is going to be periodic? The time period cannot be a non-integral value. See, listen here. One thing I told you, that if the signal value repeats after n, it also repeats after 2n, 3n, 4n, any integral multiple of n. Any integral multiple of n. Okay, so the signal value can repeat after 6 by 5, but 6 by 5 cannot be the period, then 12 by 5, then 18 by 5, that also not allowed, 24 by 5, not allowed. Okay, 30 by 5, can this be allowed value? Next will be 36 by 5, etc. But look into this 30 by 5, dear. Okay, what is this 30 by 5? This is equal to 6. This is an integer, right? This is an integer. Okay, and that integral answer will be your time period. Okay, yes. Okay, so coming to the final condition here. Here 2 pi by omega is not an integer. Okay, but then you have to check, is it a rational number? What is a rational number? Ratio of two integers. A number which can be expressed as ratio of two integers is a rational number. Okay, in the case number one, okay, 2 pi by omega was equal to pi. 2 pi by omega equal to pi, and pi we must know it is an irrational number. See, sometimes you use pi as 22 by 7. That is just an approximation of pi. That is the closest approximation. Pi is not accurately 22 by 7. You have your scientific calculator, you match the accurate value of pi with 22 by 7, up to 2 to 3 decimal places they match, right? Okay, so 22 by 7 is just the closest approximation. It is not actually equal to the correct value of the period. It is not the correct value of pi. Pi is actually irrational number. Okay, and hence there is no integer with which you can multiply this so that the final period becomes integer. Okay, case number 2, when 2 pi by omega is integer, that is the answer. Case number 3, 2 pi by omega is not integer, but is it still rational? If it is rational, okay, in the form p by q, ratio of two integers, then you can take the qth multiple. Okay, so that q and q cancel, p will be left, and p is also integer. That's the logic. That is what is the true logic. Okay, so that is what is the condition I'm going to write down here. See, okay, in the dt domain, the signal a sin omega n or a cos omega n or the same a e power j omega n also. This will be periodic only if there is a condition 2 pi by omega is a rational number. Okay, right. Then what is the fundamental period? It is given by 2 pi by omega into k. Okay, 2 pi by omega into k. Okay, some kth multiple. Okay, what should be k? K is the smallest integer, so that n is integer. Final answer has to be integer. Final answer should not be the rational ratio. No, it should be an integer answer only. Okay, so 3 cases are there. Okay, case number 1, I repeat, everybody listen to me carefully. Case number 1, if 2 pi by omega not a rational number, story over. Okay, the signal is aperiodic. Case number 2, 2 pi by omega is directly integer, then that is the answer also. The final period is that integral value. Case number 3, 2 pi by omega is not integer but yet a rational number, then the signal can be periodic, but the period will not be 2 pi by omega. The period will be, okay, if I write down the direct period here, what is the period then? 2 pi by omega. What is the 2 pi by omega here? 6 by 5. Okay, into k, some multiple of 6 by 5. Now what is the k value? Simple logic, dear. K will be 5. You should not write down all multiples. That was just for explanation. If you take k equal to 5, what is the value of k? You have to cancel denominator. Okay, so k should be just equal to denominator. You cancel the denominator and you then get n equal to 6 is your answer. Okay, so these are the 3 cases in discrete time domain. Okay, whether 2 pi by omega is irrational, whether it is rational but not integer, and whether it is directly an integer. Okay, hope this is clear. This is sufficient to know about the dt sinusoids. Okay, dt sinusoids. Okay, omega again the frequency, but just whenever I talk about discrete time signal, I've just changed the symbol for omega. Okay, this is the symbol of omega that I will use as the frequency of a discrete time signal. Okay, now the next concept I wanted to talk about, coming back here, is the addition of periodic signal, first in CT domain. Okay, first the result in CT domain. Okay, see, only thing is, guys, we will not spend any time on derivation today. Okay, otherwise we can't complete the subject, the important areas. Okay, and not required also. Exam is just on your head, it's just coming up, so you should know the approach of solving the problem, but yet you should know the background theory. That's what I'm doing. I'll tell the definitions, theory, but not derivations. Okay, now see, suppose there are two signals. Suppose there are the two signals x1t, okay, with the period t1, x2t with the period t2. Both are periodic signals. Both are periodic signals. Okay, the linear combination of them, that is ax1t plus minus bx2t. Okay, ax1t plus minus bx2t. A and b can be any constant numbers. Okay, it can be addition, it can be subtraction, anything. Okay, this will be periodic if the ratio of the time periods is the rational number. Addition of two periodic signals may not be always periodic. It will be periodic if the ratio of the time periods is a rational number. Okay, so t1 by t2 should be m by n, some rational number. Okay, then what is the final time period? The final time period can be obtained by cross multiplication. Okay, nt1 or mt2, any one cross multiplication you can check. Okay, so final time period is equal to nt1 or mt2, both will be equal, or the final time period can be taken as LCM of t1 t2, or if you want in omega domain, okay, omega should be HCF of omega 1 omega 2. Okay, the same test applies to omega if you want to directly check frequency, because omega is what, 2 pi by t, na? 2 pi cancel. Okay, so ratio of time period should be rational number, or the ratio of frequency should be a rational number. The ratio of time periods or ratio of frequency, anything you can check, that should be a rational number. Okay, and the time period is LCM of t1 t2, or frequency is HCF of omega 1 omega 2. In F domain also result applicable. F also can be written as HCF of f1 f2. Okay, right, that is what it is. Now let us apply this on the problem to understand. Choose the periodic signals. Again, this is a MSQ question. Which of the signals are periodic? Okay, there will be several MSQs that we are going to consider today. Okay, answer this one. Choose the periodic signals out of these. Okay, come on. Choose the periodic signals out of these. Everybody. Come on, let's go and check this. Rahul says all are periodic. Some of you are telling ABD. Some of you again telling ABCD. Some telling AC. Some telling AB. Okay, let's see the story. Okay, let's see the story. Now see. Let me start with the third one. Okay, is the ratio of the time period or the ratio of the frequency? See, very simple observation. The frequency here is 6, the frequency here is 6 pi. Oh, sorry, 8 pi. One has pi, one does not have pi. The ratio, how it can be rational? How it can be rational here? If you take omega 1 by omega 2, that is 6 upon 8 pi, and wherever pi is left, it is not rational. It is irrational. It is irrational. So C cannot be your answer. It is not ABCD, first of all. Okay, then coming to the option number A. Okay, omega 1 by omega 2. Okay, is how much? 1 by 2. Is it rational? Ratio of integers is rational. Is the rational number correct? This is rational, so A is the correct answer. Okay, now option number D. Okay, time scaling x1 40. See, let me explain you this way. x1 40. Okay, what is going to be the x1 40? Okay, what is going to be the x1 40? Okay, it's still going to be sinusoid. Now it is going to be 2 cos 40 plus sine, okay, 80. Still that omega 1 by omega 2 will be 4 by 8 rational, same rational number. Okay, so if x1 is periodic, time scaling version of it will also be periodic. Time scaling of it will also be periodic. Let me tell you that if xt is periodic, okay, let me add on one point here. If xt is periodic, okay, or let me complete this question, then I will come to it. Okay, C is not periodic, I told you. Okay, option number B, cos square. Okay, how can you understand cos square? Cos square is nothing but 1 plus cos 2 theta. 1 plus cos 2 theta will become 1 plus cos 60 here, divide by 2, or 1 by 2 plus 1 by 2 cos 60. Okay, now any DC term, any constant term, okay, will not affect the periodicity. Will not affect the periodicity. See, simple reason, simple logic, I'll tell you, not only for cos square, if I go to any waveform, suppose this is the waveform I started. Okay, if I ask you to add some +1, what will happen? All the values, the waveform will still be the periodic. Now, all values will be uplifted. Periodicity is not about the value. The signal can take any bounded value, but periodicity is about whether it is repeated in time or not. Okay, so earlier it was repeating from 0 to a, now it will repeat from some value, suppose a to a plus 1, still periodic, na? So addition of constant or any DC term will not affect the periodicity of the signal. Please mind it, will not affect the periodicity of the signal. The time period will also remain to be same. The time period will also remain to be same. Okay, that means, that's what I'm telling, 1/2 plus 1/2 cos 2t will be periodic. So correct answer is A, B, D, except C. Okay, if xt is periodic, let me write this result, xt plus minus a will be periodic. Time shifting xt plus minus t naught will also be periodic. Multiplying signal by any constant k, amplitude scaling, this will also be periodic. Okay, and then the time scaling case, x of at, all of them will be periodic. Okay, but the difference is, this is periodic, okay, with the same period. The period is not affected. Option, the time scaling, this is again an important result. The signal will be periodic, but with how much period? Okay, the period will be modified. Suppose the new period is t dash and it will be t divided by a, or t divided by modulus of a if a is negative. T divided by, see what happened actually, frequency got multiplied by 4, na? Okay, frequency multiplied by 4, so time period divided by 4 if it was 4t. Okay, generally for xat, time period will be divided by a or modulus of a. Hope that is clear to you. Okay, it will still be periodic. So again, these are some results you should know. What happens on time shifting, okay, what happens on amplitude shifting, what happens on amplitude scaling, and this is time scaling, xat. Okay, the signal will be periodic with the period, okay, t by omega, or if you wanted the frequency, or if you want frequency omega dash, that will be multiplied by a or modulus a. The frequency is mod a omega, like here the frequency become 4t. Okay, when it was 2t, it became 8t. So frequency multiplied by 4, time period divided by 4. Any one result you can note down here. Clear, everybody? Okay, so correct answer for the previous one is ABD. Sorry, where it has gone? ABD. Okay, now my separate question is, okay, what is the final time period? Let me write down one separate question here is, what is the final time period for x1t? Same data, same page. What is the final time period for x1t? As I told you, ratio of two signals is a the addition of two signal is periodic if the ratio of frequency or ratio of time period is rational number. Okay, is rational number. Okay, so what is the final time period? Okay, for the x1t. What is the final time period for x1t? Okay, so see, what is the final frequency? It is periodic, that I clearly mentioned. Okay, it is the HCF of both the frequencies. What are both the frequencies? 1 and 2. HCF, common factor is only 1. The highest common factor will be 1. So final omega is 1. So final time period can be 2 pi by omega, that is equal to 2 pi. Or you can take by a ratio of time period, and then you can take the LCM of time period. Anything is okay. Anything is okay, right? Next question. Consider the signal ft equal to 1 plus 2 cos pi t plus 3 sin 2 pi by 3 plus 4 cos pi by 2t. Okay, where t is in seconds. What is the fundamental time period in seconds? Okay, what is the fundamental time period of this given signal? Is it going to be periodic? Yes, of course. Yes, of course, this is going to be periodic. Let me tell you why. Yes, of course, this is going to be periodic. Let me just tell you why this is going to be periodic. Okay, number one reason is, if you take the ratio, okay, if you take the ratio, what is going to be the ratio? Okay, of frequency only you take. So now every frequency contain pi. Every frequency contain pi. Whenever you take the ratio of any two, the pi will cancel. And if pi cancel, ratio of integer will be left. Ratio of integer is rational. Okay, so just visual observation, yes, it is periodic. That is why the question, NAT question. If they are asking the period, means the signal has to be periodic. Na? It is a NAT question, okay? It is a NAT question, right? Okay. So let us see what is going to be the answer. Let us see what is going to be the answer. Okay. So now here the frequency is in fractional form. Okay. So what is the fundamental time period? Let's take the fundamental time period, nothing as LCM of T1, T2, T3. LCM of T1, T2 or T3. LCM of the T1, T2, T3. Okay. Let us take it this way. LCM of T1, T2, T3. T1, T2, T3. Okay, this is further going to be LCM of how much? How much is T1? T1 is 2 pi by omega, that is 2. How much is T2 here? 2 pi by 2 pi by 3, and that will become 3. So I'll put down 3 here. How much is T3? Okay, the phase does not affect the period, only frequency has to be known. 2 pi upon pi by 2, which becomes 4. Okay, what is the LCM of 2, 3, 4? Is 12. Answer is 12. Many of you have already commented the answer. Answer is 12. Very correct answer. Yes, guys, very correct answer is 12. Okay, next question. Okay, now see, similarly, then I told you about DT sinusoids. If I wanted to discuss about addition of DT periodic signals, if two signals in discrete time domain, okay, x1n, sorry, this is x1n, okay, with period n1, and this has to be x2n with the period n2, okay, the addition of two DT periodic signals will always be periodic. Will always be periodic. Why? Okay, will always be periodic. Why? Because n1 by n2. See, if you are talking about discrete signal, what is the first thing I told you? That the time period must necessarily be integer. So, because any of the time period is integer, when you take the ratio, it has to be integer. Okay, it has to be always rational. It is always rational because n1, n2 are integers only. Any time period in DT domain is integer. So n1 by n2 will always be integer. So what is the final time period? LCM of n1, n2. Okay, or what is the final time period? Okay, again, if you take the, by chance you took the ratio n1 by n2 is some, m by n, or let's not use n here. N is already the discrete time. Suppose it is some ratio as p by q. So what is the final time period? Cross multiplication. Qn1 or Pn2, Qn1 or Pn2, anything is okay. Anything is okay, right? Okay, so answer me this question where I have taken a PYQ, GATE 23 2 marks question. GATE 2023 2 marks question. Come on, answer me. 2 marks question. And as far as I remember, this was GATE 2023 electrical 2 marks question, where GATE 2023 is one of the toughest paper of electrical. Okay, but see, this one is easy only. The DC term will not affect your answer. The constant term will not affect your answer. Correct, na? Come on. Okay, answers are already ready in the comment box. 48. Let's check. Let's check. Okay, let us check this. Okay, so see again, guys, what is going to be, see, again, because it is every signal is discrete signal, you should be careful that time period is not 2 pi by omega always. Okay, time period is not 2 pi by omega. Okay, first you will check 2 pi by omega 1. Okay, what is the value for the first one? 15 pi by 8 is the omega. Pi cancel and answer is 16 by 15. Okay, which is rational but not integer. Okay, time period has to be integer, but it is rational at least. Okay, so what is the time period here? N1. Okay, the time period is 16 by 15 times k. Okay, integral multiple of it. What should be k? Okay, k should be something to cancel denominator, so choose k 15. Okay, the n will be 16. N1. Okay, so N1 is 16. Okay, the first time period is 16. Next one. What is 2 pi by omega 2? 2 pi by omega 2. Omega 2 is pi by 3. Pi cancel, it is 6 and directly integer. Okay, then you don't need any k and all. Then the time period 2 is 6 only. Okay, then the time period 2 is 6. So what is the final time period? LCM of both the time periods can be taken. That is 16 and 6. LCM of both the periods can be taken. Okay, and yes, the correct answer, as you mentioned, the LCM of these two is 48. 48. Okay, already many answers have come up in the chat box. Yes, the 48 is the very correct answer. The 48 is the very correct answer. Okay, next question. Next question. Okay, now there's a good question, GATE 2024 MSQ 2 marks, which is the homework 3 for you. Okay, few things you have to try so that your, practice and your brain is also activated. Everything you cannot just copy, na? Okay, this is the homework number 3, but a good question. This is a good question. This is not on addition of periodic signal. This is a single periodic signal. A cos omega n plus pi by 3. What can be the radian value of frequency omega for which the period is 40? Okay. Remember period. It's not telling fundamental period. Period has to be 40. Check the calculations. This is homework number 3. You have to mention whatever answer you correct, A, B, C or A, B, D, whatever you got correct, you have to mention in the comment box after the video is over. Not right now. Not right now. I will not be able to check also right now. Okay, I'll move to the next question. Okay, where we will also slowly discuss about the energy and power signal calculation. Okay, see, if it is CT domain, let me review the formula. Let me tell you some important points, because there are some bullet points also which is very important to take away from energy and power calculation. So see, first of all, the instantaneous power. Okay, considering xt, suppose a voltage signal V square t, just like you define V square t. Okay, V square t. Okay, V square t by R basically. How is the instantaneous power defined? Is V square by R. All these are normalized calculation assuming unit resistance. Okay, now what is the energy calculation defined as? Energy, power is the rate of change of energy. Energy is the integral of power signal. Integral minus infinite to infinite modulus x square t. This is primarily for complex signal. If it is a real signal, if you simply considered a real signal, okay, then you can take the energy formula as simply energy integral of x square t. Then you don't need to apply that modulus separately. Integral minus infinite to infinite x square t dt. Okay, or this is also equal to area under square of the signal. This is also equal to the area under the square of the signal. The area under the square of the signal. Area under the square of the signal. Okay, then the average power of a signal is defined as the average value of this signal considering some period, considering some interval of time minus t by 2 to t by 2 modulus x square t, or again you can take simply x square t if it is a real signal, divided by the length of the interval. Okay, this is what is the standard formula to calculate average of any continuous quantity. Integral x square t from minus t by 2 to t by 2 divided by the length of the integral, and to generalize the average values for all values of time, we put the condition limit t tending to infinity. You may also find this definition in some books as integral minus t to t divided by 2t. Any of this is okay. Any of this is okay. Any of this is okay. Okay, then for t tending to, okay, whatever length of integration you have taken divided by the length you have to do here. Okay, divided by the length. Yes, Dilleshwar, place this answer in the comment box in the evening after the video is over. Okay, so that it becomes a competition in the comment box and everybody can check the answer. I will also reply with the correct answer there. If it is a discrete time signal, again the power is the square of the signal x square n. The energy of the signal will be summation modulus x n whole square, or again equal to summation of x square n, summation of square of the values of the signal if it is a real signal. Okay, if it is a real signal, summation of square of the signal, and the average power of the signal will again be summation of this x square n. Okay, or summation mod x n whole square. Again for real signal it will be just x square n. Okay, now here I have taken summation minus n to n. So what is the total samples? Here it is a discrete quantity, so it is countable. Okay, from minus n to n, how many samples you have taken? N on the right side, n on the left side, and 0 at origin. So total sample becomes not only 2n, it becomes 2n plus 1 including at origin. Again with the condition, as I told you, limit n tending to infinity. Okay, now some important bullet points I wanted to mention here. Okay, see, this is one more formula that I will come to it. Okay, when we again come back to periodic signal, how do you calculate the average power of the periodic signal, or okay, RMS value of the periodic signal? Okay, RMS value also I will discuss. Okay, if you just want to calculate RMS value, it is nothing but root over the average power. Okay, root over of the average power of the signal. Okay, and for periodic signal, you can simply take the average power as 1 upon t. Okay, integral x square t dt. But what is integral x square t? The integral x square t is the energy formula. The total energy is minus infinite to infinite x square t. Here I have taken the integral for one time period, that is ET. That is energy of the signal in one period. Energy of the signal in one period. Okay, divided by the value of the time period. This is also a quick way to calculate average power of the signal, and RMS value is nothing but the under root of the average power of the signal. under root of the average power of the signal is the RMS value. Okay. Now, before I tell you some bullet points, let me come to a simple calculation here. Suppose you look into the result is already written, but just wanted to show you a calculation. Okay. Consider xt as a right-sided exponential signal, e power minus 80 ut. Consider this as e power minus 80 ut. Okay, e power minus 80 ut. How do you calculate the energy of the signal? See, the energy of the signal, general formula as I told you, it's a real signal. Huh? Okay, integral minus infinite to infinite x square t dt. But xt is only defined for t greater than 0. Okay, so the limit of integral becomes 0 to infinity. What is going to be, now what is xt? E power minus 80. So square of this, what is the square of e power minus 80? It becomes e power minus 280. Okay, this is the calculation, simple integration that you have to complete here. E power minus 280 upon minus 2a, lower limit 0, upper limit infinite. E power minus infinite will be 0, lower limit e power 0 will be 1. So minus 1 by minus 2a. Okay, or simply 1 upon 2a. That is what I have already written here. Okay, provided that the signal is bounded in nature. Now, what is bounded exponential? Okay, this is e power minus 80. That means a must be positive. Okay, if a is negative, what will happen? If a is negative, minus minus will become plus and the signal will be exponential rise on the right. Now, if it is rising to the right, where it is going to go? It is going to go up to infinity. That means there the signal will become unbounded. And if the signal is unbounded, how much will be the area under the square of the signal? Area will be infinite. Energy will also be infinite. Energy will also be infinite. Okay. So, energy is 1 upon 2a provided a must be positive here, or simply remember bounded exponential signal. Bounded exponential signal can be a right-sided signal also, can be a left-sided signal also. It can be a left-sided signal also. See, what is there? Okay, if you take the signal e power 80 u minus t, if you take the signal e power 80 u minus t, okay, e power 80, this is e power 80, exponential increase. But on the left side, okay, on the left side, you cannot take the e power minus 80, because if you take e power minus 80 on the left side, so on the left side, it starts with e power minus of minus infinite, e power plus infinite, that is infinite. That is what is infinite. Clear, everybody? That is what is infinite. Okay, so on the left side, you cannot take e power minus infinite, but you take e power plus 80, it starts from 0 and it is 1. Okay, again, it is bounded exponential. Again, the energy of it, if you by calculate, it will be 1 by 2a. It will be 1 by 2a again, right? It is going to be 1 by 2a again. Okay, so on the left side, you cannot take e power minus infinite, but you take it starts from 0 and it is 1. Okay, again. Okay. Yeah, let's do it. Okay, sorry. Now, there can be one more type of bounded exponential signal. This is unbounded, as I told you, energy infinite. This is also left-sided unbounded. Okay, now two-sided exponential bounded signal. Okay, two-sided bounded exponential signal, which is defined as e power minus a mod t. Okay, what is the signal e power minus a mod t? See, e power minus a mod t, you should always remember several times modulus function will come. What is mod t? Okay, whenever t is greater than 0, modulus of t is t. But whenever you have a negative number, then you write down minus over it. Okay, so that minus minus becomes plus. This is the definition of a modulus x function. Okay, so modulus t we know is t or minus t based on the sign of the t. Okay, so accordingly the signal is broken as e power minus 80 for t greater than 0. For t less than 0, minus t and minus a will become e power plus 80. And with for t less than 0, you multiply by u minus t. Okay, energy of, now you can again calculate by energy formula, or you can say that the energy of this much part is 1 by 2a. Both are separate, non-overlapping part. The energy of this is separately 1 by 2a. So what is 1 by 2a plus 1 by 2a? Will be 1 by a. Okay, the total answer will be 1 by a. Okay, so see, there are some signals like bounded exponential whose energy is finite. But if you took unbounded exponential like this, the energy will be infinite. Okay, based on the value of energy, number 1, I define an energy signal. Okay, the signals having finite energy. Okay, the signals having finite energy. Okay, the signals having finite energy are said to be energy signal. Okay, and for any such signal, I am not deriving it, but for any such signal, again, automatically the average power will turn out to be 0. For any such signal, the average power will turn out to be 0, right? For any such signal, average power will turn out to be 0. Please mark it. Okay, then There are some signals whose energy will be infinite, okay, whose energy will be infinite, but power will be finite. Okay, those signals which have finite and non-zero power, finite non-zero average power are known as power signals. Okay, if energy is infinite, power is finite, that is power signal. Then there comes a third case, okay, where energy and power are both infinite. Okay, where energy is also infinite, okay, the average power of the signal is also infinite. Those will be named as NENP signals. Those will be named as NENP. What is NENP? You can write down: neither energy nor power. Neither energy nor power. They will be known as NENP signals. The signals which are neither energy signal nor power signals, that is NENP signal. Okay, that is going to be the NENP signal, right? Neither energy nor power. Okay, this is what you should know. Okay, so what I have shown you right now, one by one, I'll show you all of these things. All bounded exponential signals are energy signals. Okay, unbounded exponential signals are NENP signals. Unit step is a power signal. Okay, let me show you the unit step signal calculation. Let me show you this unit step signal calculation. Okay, why unit step is a power signal? Okay, so considering xt equal to ut, and we know about ut, unit step takes the value 1 only for t greater than equal to 0. If you started calculating the energy of this signal, energy means what? Energy is minus infinite to infinite x square t dt. Okay, the signal is defined only for 0 to infinity. Okay, and what is the value of the signal? 1. Okay, so 1 square is 1 only. dt integral t limit 0 to infinity, upper minus lower limit, infinity minus 0 will be infinite. Okay, infinite minus 0 will be infinite. Correct, everybody? Okay, then so this is not an energy signal. Then average power of the signal. What is the average power? As I told you, you can write down the average power as limit of t tending to infinity 1 upon t integral minus t by 2 to t by 2 x square t dt. Okay, integral minus t by 2 to t by 2 x square t dt, and this is then equal to limit of t tending to infinity 1 upon t integral. Now see, xt is ut. Okay, xt is the ut which is only defined for t greater than 0. Okay, so again, minus t by 2 to t by 2 not required. The actual integral will be 0 to t by 2. And from 0 to t by 2, what is the signal xt? Any value right side is 1. Okay, so 1 square dt. Okay, then this is equal to limit of t tending to infinity 1 upon t. Again, dt integral is t, lower limit and upper limit 0 to t by 2. When you solve upper minus lower limit, you will get t by 2. T by 2 and t will cancel. Answer is 1 by 2. No need to put any limit, t will be cancelled. Answer is 1 by 2. This signal had finite energy but infinite energy but finite non-zero power. This is a power signal. So that's what unit step is, a power signal. Okay, unit step is a power signal. Okay, similarly, if you check for unit step or unit ramp, they will be NENP signals, neither energy nor power signals. Periodic signals, I will come to this discussion as I told you. Periodic signals are generally power signals. As I told you, when I come to periodic signals, I will take this formula. To average power to be calculated as energy in one period upon time period. RMS value of the periodic signal is root over of the average power, right? Okay, right. Periodic signals are generally power signals. Okay, now the next one, finite duration bounded signals. Okay, and 3 cases of it are important that you should remember, helpful in many questions. Okay, what do I mean by finite duration bounded signals? All finite duration bounded signals are energy signals. Number 1, have a look into this rectangular pulse. Okay, finite in duration. How much is the duration? Minus t by 2 to t by 2 t. This is what is the duration, which is finite. It does not go to infinity. This is the duration. And also the value of the signal is only a. The bounded value means the signal value should not be infinite. Okay, this is what is a rectangular signal. Okay, the energy is simply, I'm not deriving it, you can just note down, amplitude square into duration, a square t, amplitude square into duration. Okay, similarly, another important example. Now see, it is not necessary that the rectangle should be centered at origin. Only important thing is duration. It can be placed anywhere. It can be placed anywhere. That means if I give you something of this kind, if I had given you something of this kind, okay, suppose this is some question. See, directly this much easy will not come, but just one calculation I want to show you. Suppose the signal is a rectangle signal given something of this kind. Okay, so what is important is duration. It can be placed anywhere. Okay, it can be placed anywhere. The answer is amplitude square into duration. How much is the duration? T equal to 1 to 3, duration is 2. So the answer of this signal is 18. Okay, the energy of this signal will be 18. Okay, amplitude square into duration. If it is a triangular signal, all these three cases I'm telling you are very, very important for you. Okay, so energy content of a triangular signal, it will be amplitude square into duration by 3. T is again the duration. Okay, minus T by 2 to T by 2, or it can be placed anywhere. Again, I'm telling you here, again, T is known as the duration of the signal. Amplitude square into duration divided by 3. And then no, this was a triangular function. First I have given a rectangular function, and third important case in finite duration is half wave sinusoid. Okay, just half wave of a sinusoid. Okay, and suppose the duration is T. T is not the time period of sinusoid. It is just some half wave sinusoid taken. The width of this sinus half wave is T. The width or duration of this sinusoid is T. Don't confuse T here as some time period. Okay, here for half wave sinusoid, on calculating, we get the answer as a square into T divided by 2. We get the answer as a square into T divided by 2. A square into T divided by 2. Got it, everybody? That is going to be the answer. A square T divided by 2, right? Okay, now let me start. Okay, yeah, some more points I wanted to add on. So what are the important things I've told you till now? What is the definition of energy signal? What is the definition of power signal? Okay, then what are NENP signals? Then all finite duration bounded signals will always be energy signal. Three cases to be remembered, important: rectangle, triangle, and half wave sinusoid. Bounded exponential signals are energy signals. Unbounded exponential signals, NENP signals. Unit step is a power signal. Impulse and ramp are NENP signals. Okay, periodic signals, I will come to the questions. They will be generally power signals. Okay, then some manipulations. Okay, I mean time shifting, time scaling, time folding, amplitude shifting. What is the effect on the energy or power? Okay, so suppose if there is an energy signal, okay, having energy E, then energy of xt minus A or xt plus A, same. X minus T, same. Okay, so no change in energy by time shifting or time folding. Okay, then AXT, amplitude scaling. See, because energy is integral of x square t, that means energy is proportional to square of the signal. So if you multiply the signal by A, energy is multiplied by A square. Energy is multiplied by A square. Next, energy of XAT, time scaling, will be E by A, because energy is also proportional to width. Okay, and time scaling means you are changing the width. Suppose if I ask you X2T. Okay, X2T is what? Compression. Na? X2T is what? Compression. Compression of the waveform by 2, and if you compress the waveform by 2, its duration will be reduced. Okay, and energy will become E by 2. Okay, so what about X2T? The energy will become E by 2, generally E by A or E by mod A if A is negative. Okay, energy of minus XT will be E only, because minus 1 square, because energy is proportional to square, na, so minus and plus have no role. Minus XT also energy will be E only. Okay, if it is a power signal, okay, if it is a power signal having some power P, average power P, then time shifting, no change in power. Time folding, no change in power. AXT, the power is A square, the power is A square P. Amplitude multiplied by A, power multiplied by A square again. Now this one is important. Power of XAT. Okay, the time scaling does not affect the power. The time scaling does not affect the power. No change, it remains to be P only. Okay, why? Because as I told you, I will take up this formula in upcoming questions, that the power is ET by T for periodic signal. Okay, so if you want to talk about XAT, the energy is scaled. Okay, just now what I told you, if you calculate the energy for XAT, energy is E by A. But then in periodicity, already I told you, time scaling effect on periodicity. The signal remains to be periodic, but the time period becomes T by A. Yes or no? We discussed this point. Okay, time period also becomes T by A. So energy and time period are both scaled. So net average power remains to be same. Net average power remains to be same. Right? Correct. Correct. Yes, correct, Shravan Kumar. Yeah, that is the important observation you have to make here. Okay, so you can expect the questions on these operations as well. Energy and power changes because of these operations. Okay, then some formulas for right-sided E power minus ATUT or E power ATU minus T. The energy is 1 by 2A. For two-sided bounded exponential E power A minus A mod T, energy was written as 1 by A. Okay. Then some finite duration signal. Come on, a question here. Energy of the signal x1t, which is e power minus et ut is E1. Energy for the signal x2t is e power minus of 3t minus 2 ut is E2. If E2 is A E1, what is the value of A? Come on. What is going to be the value of A? Right, everybody, come on, give me that answer. A plus xt, I cannot give you any energy formula. We have to calculate manually. Energy will be affected, but I cannot write down as a formula. I cannot write down that as a formula. It may also be quite possible that the signal does not remain to be an energy signal. That's why I'm not giving anything. Okay, it is definitely that also is possible, Abrar. Right. Yes, guys, let's check this particular question. See, just after the 1 hour, I have observed, just within 1 hour, I have observed a slight dip in the attendance. But don't worry, guys, that is what? Okay. 1 year back, February, March, many students might have started gate preparation. Okay. How many would have been left till now? January, it's January end almost, very few. So this is general nature of the aspirants. Okay. It's always surprising, but that is the reality. And I know it's going to drop. Okay, but as long as a decent attendance is maintained, I am going to continue. I have not put any upper limit on today's session. I have not put any upper limit on today's session. It depends on all you, how much you want to learn. Okay, I'm ready for entire day up to the night as well. Okay, let's see based on your energy. I have not calculated and I've not put any upper limit on today's session. Psychologically, I'm not ready for that. Okay, let's see. You have to be ready. Okay, so see guys, what is the signal x1t? It has the energy E1, e power minus 80 ut. Okay, so what is the energy E1? 1 upon 2a. What is the value of a? Is 1. Okay, so energy E1 is 1 by 2. Okay, but you have to simply manipulate and rearrange the signal x2t first. E power minus 3t into e power minus e power plus 2, that is constant factor, into ut. Okay, how much is the energy for this E2? Okay, if I asked you only this much part, e power minus 80 ut again, what is the energy for e power minus 80 ut? 1 upon 2a, 1 upon 2 into 3. But whenever any signal is multiplied by some amplitude, a energy is multiplied by square of it. Remember that. Okay, so energy E square square. Okay, so this becomes e power 4 is divided by 6. This becomes e power 4 is divided by 6. Right? Okay. So I don't think many many correct answers have come up. Okay, now I will write down what is the value of A in the question is nothing but the ratio of E2 by E1. The ratio of E2 by E1. Okay, E2 energy is e power 4 divided by 6. E1 energy is 1 by 2. Okay, so answer is e power 4 is divided by 3 actually. E power 4 is divided by 3 is the correct answer. Yes, winter child, correct. E power 4 divided by 3. Now I can write down its approximate value. Even energy is 1 by 2. Okay, so approximately I can write down the answer as 18.2, right? With the calculations, if possible, you help me. NAT question, keep giving me the final answer. Okay, approximately 18.2. That's going to be approximately 18.2. Yeah, I will share the PDF in my Telegram. Don't worry. Okay. So this is what is the logic of solving this particular question. Okay, dear. Next question. Okay. Consider the following statement regarding the signal e power minus mod t. Again, a MSQ question, dear. Which of the following statements is or are true? Which of the following statements is or are true? You have to tell me. You have to tell me which of the statements is or are true. Okay, it is an energy signal. Okay, it is an odd signal. It is an even signal. It is neither even nor odd. Okay, see, simple. What is the e power? Just a two-sided bounded exponential signal. I just told you some highlights about this. Okay, no problem. Let me redraw it. E power minus a mod t or e power minus t. E power minus mod t. A equal to 1. Okay, on the right side it is e power minus t, on the left side it is e power plus t. Right and left identical or not? Right and left are identical. That is what is symmetry, even symmetry. when left and right are just mirror image of each other, this is even symmetric, and also it is the energy signal. I already told you. Okay, what is the energy of it? 1 upon a value is 1 upon 1, finite energy. It is a energy signal. A answer. It is a even signal. C answer. A and C, two answers. Very basic question. Okay, two answers are correct. A and C. A and C, two answers are correct here. Right. Consider a signal shown below. Okay, again it is not mentioned. I'll write down again the next question, MSQ only. Consider the signal shown and you have to calculate the energy. Suppose this is the signal yt, you have to first check energy of yt, then energy of 2yt by 3. Some time scaling and amplitude scaling, time shifting operations have been introduced here. Right. Previous one, many of you correct. A and C were the correct answer. Now answer me this one. Okay, now just answer me this one. Okay, what is the energy? First, let's calculate the energy of yt. First, let us calculate the energy of this yt. Now, see here, look into this particular waveform. Okay, easy one only, energy of yt. What is the simple logic is you can break this into 3 non-overlapping waveform. Right? You can break this into 3 non-overlapping shapes. What are the non-overlapping shapes? A triangle, a rectangle, and a triangle. And for rectangle and triangle, you know the energy, na? Problem solved. Okay, let us say this is the energy E1. What is the energy E1? Triangle, amplitude square, amplitude 5, duration 2 into duration divide by 3. Then the rectangle pulse, amplitude square into duration. Amplitude is 5 and duration 0 to 6 is 6. For the next one, suppose the energy is E3. For the next one, energy is E3. Right, and that is again triangle, amplitude square, amplitude is 5, height of the triangle, base is again 2 units, duration is again 2 and divided by 3. Okay, so what is the net answer for the energy of yt signal? I'll add all these parts, that is 5 square, 25 into 2, 50 by 3. Next one is how much? 25 into 6, that is 150, and again 50 is divided by 3. Okay, so correct answer has to be 150 plus 100 divided by 3. Okay, or that is equal to 450 or 550 divided by 3, which is 183.33. Correct. 183.33. So this is wrong and A answer is correct. Okay, but MSQ question, now 2yt by 3 and 3yt by 2 plus 3. Correct. Okay, A is at least correct. A is at least correct. Now dear, if yt has the energy E, which is calculated as 550 by 3. Okay, what about the energy for 2yt by 3? 2yt by 3. 2yt by 3. Let's solve it in single step. Okay. Now 2 means amplitude scaling. In amplitude scaling, energy will be scaled by 2 square. If amplitude multiplied by A, energy multiplied by A square into the energy E. Now, yat. Okay, energy E by A. Energy E by A. What is the A here? 1 by 3. So E by 1 by 3. There are two things. Okay. So the correct answer has to be 2 square, that is 4, and then 3 comes above, into 3 into energy 550 divided by 3. 3 cancel. 4 into this value will be 2200. 2200. Yes, so C answer is correct. Then we have to check D. 3yt by 2 plus 3. 3yt by 2 plus 3. Yt has the energy E. The question is 3 y of t by 2 plus 3. Now, there is a time shifting also. Will the time shifting affect the energy? No. Time shifting doesn't change the energy or power. That's what I told you. Okay. But yes, amplitude scaling. Amplitude multiplied by 3, energy multiplied by 3 square. Time scaling is there. At. Energy E by A. Energy E by half. Okay. So, this time the answer is 3 square. That is 9 into 2 into the energy, which is 550 divided by 3. So, 3 will get cancelled. 6 into 550, 3 and 300. 3300. 3300. Okay. This is the, yeah, the D answer is also correct. So ACD. 3 answers for this question correct. ACD. So like this in today's session, indirectly you are practicing several MSQs as well. Correct? Okay, next question. See, a very simple 2-mark question. A very simple 2-mark question. If the energy of a continuous time signal xt is E and the energy of the signal 2x 2t minus 1 is Ce, what is the value of C? Simple question, dear. If xt has the energy E, okay, then 2x 2t minus 1. 2x 2t minus 1. Again, time shifting doesn't change the energy. Okay, signal multiplied by 2, energy multiplied by 2 square. Okay, 2 square into E, and then time scaling AT, energy divided by A, E by A, so E by 2. Okay, so 1 is 2 square, 1 is divided by 2, 1, 2 cancel, answer is 2E, and they have told that the energy of this signal is suppose CE. What is the value of C? What is the value of C? 2. Finished. 2 marks. See, sometimes, very easy question. It's not always the case, but sometimes it is very easy question. Okay, now next question. Oh, sorry, where it is gone. Energy in the signal shown. Again, now I'll tell you two different things for this question. Okay, number one thing is, okay, this signal can be broken as addition of two signals. It is again like a rectangle and triangle signal, but this time the question is like, okay, the question is like, there is a triangle above a rectangle, isn't it? There is a triangle above the rectangle. Triangle above a rectangle, superimposed. They are not non-overlapping. They are on the same time zone. T equal to 1 to 4, both are overlapping. Now see here. Okay, you can break the signal this way. First, I will draw the waveform and show you. Okay, you can, take a rectangle of amplitude 2, okay, from 0 to 6. From 0 to 6. Over and above this, you have to place a triangle. So if I separate the triangle is from 1 to 4. The triangle is from 1 to 4. Okay, how much is the height of the triangle alone? Okay, the height of the triangle alone is 2 units. 2 to 4, the height of the triangle alone is 2 units. When you add 2 plus 2 will become 4, correct, na? Okay, so the given signal can be broken into two signals, suppose x1 and x2, but they are overlapping in time. Overlapping means t equal to 1 to 4, both are available. Okay, what do I mean by overlapping and non-overlapping? Again, I repeat, like previous question, where I have taken three shapes, triangle, rectangle, triangle, but they are non-overlapping. One signal is 0, minus 2 to 0, then 0 to 6, and then 6 to 8. Non-overlapping means they are placed on different places on time axis. They are defined for different values of time. Okay, but here, okay, they are available, okay, on same value of time. Okay, see, there is one thing that I have taught students earlier also. There is one formula, one more thing I want to tell you for this question now. One more method I want to introduce. Number one method is energy of x1 plus x2 in such case. Okay, they are overlapping. They are overlapping for t equal to 1 to 4, correct? Okay, so then the energy is not directly additive. Okay, if you say energy is E of x1 plus E of x2, wrong. Okay, see, alone both the energies you can calculate, na? A square into duration, amplitude square into duration by 3. Okay, but it is not only E of x1 plus E of x2. If it is overlapping, it is E of x1 plus E of x2 plus twice integral x1t x2t dt. Twice the area under the product of the curve. Twice integral x1t x2t dt. Okay, this is what is method number one. Okay, you can try with this, but now let me tell you something new. I want to tell you something new here. Okay, what is that something new is? Okay, for that something new, okay, for a moment what I will do is, yeah, just I'll replicate this picture first of all. Okay, this overlapping is the problem, na? That asks you to calculate one more integral. Okay, this is 1, this is 4, this is 6, this is 0, this amplitude 2, this amplitude 4. Okay, now dear, listen to me carefully. One more way of handling this question. One more way of handling this question. Okay, how much is this energy that you can calculate? How much is this energy that you can calculate? Okay, see, this midpoint is missing in the diagram. I'll write down that also. This is actually the midpoint, and that is equal to 2.1 and 5. So that is 2.5, correct? 1 to 4, 2.5. That is the midpoint here, right? That is going to be 2.5. Let me check that once. Yeah, okay, correct. Okay, Now see here. Okay, what is the another thing that I wanted to mention here is, keep looking here. Okay, see this energy and this energy you can calculate. Okay, this energy and this energy you can calculate. How much is this energy? Amplitude square into duration, 2 square into 1. How much is this energy? Amplitude square into duration. This duration is 2 units. So this is 8 and this is 4. This is easy. Okay, if I could calculate the energy only for this portion, okay, the other one is symmetric only, na? Other one is symmetric. Okay, so what I mean is, if I shift this here, okay, time shifting doesn't change the energy, na? Time shifting doesn't change the energy. Okay, time shifting doesn't change the energy. Suppose I make it this way. This is 3, this is 0, and this is the midpoint 1.5. This is 2, this is 4. Okay, keep understanding, right? Right, that too, if you only calculate the energy of this portion, the other is symmetric. Okay, that means if I know the energy of this, it will be same only. Okay, why? Because energy is also equal to area under the square of the signal, and both of these portions will have identical area. So you can you can say that it is symmetric about these lines. That is why these two portions on left and right will have identical areas. Time shifting doesn't change the energy. That is the concept I'm using here. Now see here, can you write down the equation of this line? Okay, yes. What is the slope of this line? Height. Okay, so height alone for this line is 2 units. 2 to 4. Height alone for this line is 2 units. This portion I'm telling. Okay, and base is 1.5. 2 upon 1.5, or can be written as 4 by 3. So what is the equation of this portion? I can call this portion as mx plus c. M is 4 by 3 into t plus c. And what is the value of c? 2. The y-intercept. Okay, the y-intercept. Okay, so hence I can find out this energy as integral of x square t, that is integral 0 to 1.5, integral from 0 to 1.5, 4 by 3t plus 2 whole square dt. Here also eventually you have to solve an integral, but I'm just trying to add one more method for you. Okay, so you calculate this energy. Okay, number one thing, let's do this calculation. How much it is? Now 4 by 3 t square, I'll directly integrate. What is the first term? When you take a square, a plus b whole square, na? So 16 by 9 t square integral t cube by 3. Okay, then b square 4 integral 4t. Then 2ab, so when you do 2ab, 2 to 4, 4 to 16, 16 by 3 t and t integral t square by 2. Okay, and then you have to put down the limit 0 to 1.5. Then you have to put down this limit of 0 to 1.5. Okay. Sorry. Okay, then you have to put down this limit 0 to 1.5. Okay, so let me see how much will be the result coming up after putting down the limits. Okay, let me write down the final calculated answer here. Actually, it will be better. Yeah, this alone calculation is turned out to be how much? 14. Okay, calculations you can handle. I've got this answer as 40. Okay, and then what I told you, okay, if this portion has the energy 14, this also will have the energy 14. Okay, so net answer. So I've got this energy. This is 14. This is also 14. Okay, this was 8. This was 4. The net energy of the signal 4 plus 14 plus 14 plus 8. Okay, 28 and 12, 40. That is what you are mentioning in the comment box, I guess, right? 40. 40 is the very correct answer. 40 is the very correct answer for this one. This is the another method number 2 of handling the question. Okay, one more method, method number 1, that you can try on your own. Okay, because E of x1 and E of x2 is easy. Okay, here you have to multiply the signals and calculate the area or calculate the integral of x1, x2 t, or area under the product of the signal. Okay, this is method number 1, which I leave to you. Okay, and the answer is already known to us as 40. Okay, this is the next method. Clear, everybody? Tell me any confusion by chance. If there is any sort of confusion, you can tell me. No problem. Okay, no problem. Next question. Yeah, energy for the following discrete signals. Okay, for the discrete signal. What is the energy formula that you will use for the discrete signal? Okay, it is given by summation of, all of them are real signals, no complex term is given, summation x square n minus infinite to infinite. See, I'll start with the third one being very straightforward here. Third one being very straightforward when the sequence is given to you. Okay, the sequence, whenever the sequence is given, what is the energy? Energy is just summation of square of the signal. Okay, the summation of square, it's just 2 square, then 0 square, then minus 1 square will be 1, then 5 square 25, and then 1 square again 1. What is this? 31. What is that? Simply 31. Okay, simply that is 31. Okay, some sequences were given. Now 1 by 3 power n un, coming to the first part. Okay, coming to the first question. Okay, energy, as I told you, is integral, is summation minus infinite to infinite x square n, because it is a discrete time signal. Okay, summation of square of the signal. So this will become how much? Now because xn has a unit step element, so unit step will be only started from 0, so write down the limit as 0 to infinity, then x square n. Okay, 1 by 3 power n whole square, or when you take the square of 1 by 3, you can write down as 1 by 9 power n rather. 1 by 9 power n, summation is from 0 to infinity. When you open the summation, 1 by n power 0, 1. Then 1 by 9 power 0, then 1 by 9 power 1, 1 by 9 power 2, 1 by 9 power 3, it goes up to infinity. This is a GP with infinite number of terms. This is a GP with infinite number of terms. Okay. Okay, common ratio is less than 1. So A upon 1 minus R. Common ratio magnitude is less than 1. So this is 1 upon 8 by 9, or can be written as 9 upon 8. Okay, so first one is 9 upon 8. Okay, then I'll go to the second one here. What is that second one here? Okay, 2 power n u minus n minus 1. Xn is 2 power n u of minus n minus 1. 2 power n u minus n minus 1. 2 power n u minus n minus 1, correct? Power n u minus n minus 1, correct? So what is this 2 power n u minus n minus 1? Let's check this. Okay, energy. Now what is this u minus n minus 1? This is going to represent a left-sided discrete time signal. Okay, see, u minus n minus 1, any unit step will exist when the bracket, when the argument of time is positive. Okay, minus n minus 1 greater than equal to 0. Okay, greater than equal to 0. Yeah, that's what. If you know basics, then this is going to be enough. Okay, central, correct? Hope you might have felt also. If you just know the and that too, what basics I'm expecting? You just know step, ramp, time shifting, time scaling, only those basics. In fact, the classification also I'm covering, na? Okay, so only some basics, if you know, the session is sufficient for you. So now minus n minus 1 should be greater than equal to 0, means the n must be less than equal to minus 1. Okay, n must be less than equal to minus 1. So I can say that this signal x of n is 2 raised to the power n for n less than equal to minus 1. So when I go to the energy calculation, what is going to be the energy calculation? Energy is going to be summation from minus infinite to minus 1, not minus infinite to infinite. The signal is only defined up to n equal to minus 1. Minus infinite to minus 1, xn whole square. 2 power n whole square, or you can write this as summation minus infinite to minus 1, 2 square can be written as 4, so 4 power n. Okay, I'll start from the upper limit, that is 4 power minus 1, then we have to go towards minus infinity, so 4 power minus 2, 4 power minus 3, or this can be written as 1 by 4 plus 1 by 4 square plus 1 by 4 cube, again a GP with infinite terms. Okay, the first term is 1 by 4. Common ratio is also 1 by 4, which is having magnitude less than 1. So that is why GP converges. 1 by 4 by 3 by 4. Net answer 1 by 3. Second answer 1 by 3. Please check it out. First 9 by 8. Second is 1 by 3. And third answer is directly 31. Simple. Finished. Finished. Okay. Next. Okay, next. Find the power of the following signals. Okay, power of the following signal. Now see, because it is a periodic signal, a periodic rectangular waveform has been shown. So as I told you, how will you calculate the power? Okay, simple. Power will be calculated as energy in one time period divided by time period. Time period is simply marked at t only. This is 0, the center of the next one is t, the center of the previous one is minus t. Okay, the time period is t here. What is the energy in one period? Now in one period you have a rectangular pulse. In one period you have a rectangular pulse. What is the energy of rectangle pulse? Amplitude square into duration. Okay, again you will use the formula a square into duration. What is the amplitude? Is k square into duration minus a2a. The duration of rectangle, not the time period. The duration for which rectangle is defined is 2a minus a2a. Okay, that is why energy in one time period is 2a k square. Energy in one time period here is 2a k square. So I'll write down the answer here. 2a k square is divided by t. The 2a k square is divided by t. Correct. The 2a k square divided by t. Next. Okay, so easy one only. The final power is 2a k square divided by t. Next. Okay, find the power. Now see, by the same method, you must be knowing this also, but by the same method, you can calculate the power of sinusoids as well. Okay, see, let me start, suppose for a sin omega t. Both will have same power only. Okay, both will have same power. A sin omega t or a cos omega t, anything can be there. Okay, so if I start with a sin omega t, both are just 90-degree phase shifted. Okay, so this is the t, this is 0, this is the time period t. Okay, so this becomes the time period t by 2. Okay, time period t by 2. How do you calculate the average power of this again? How do you calculate the average power of this again? Energy in one time period divided by time period. That is the formula I told you for periodic signal. Easy one. Okay, so time period is t only, but what is the energy in one time period? Okay, so see, this is what is one time period, correct? This is the one time period. What is the energy in one time period? So one time period can be broken into two half cycles, correct? Into two half cycles. What is the energy of the first half cycle? What is the energy of the first half wave? Amplitude square, a square into duration. Half wave sinusoid formula, amplitude square into duration. Duration of this cycle is t by 2, divide by 2. Amplitude square, duration by 2. Remember, I've told you that energy formula directly. Plus, another one is negative half cycle, but still, as I told you, minus n plus a square will be same. Okay, so for the negative half wave sinusoid, the amplitude is minus a. The duration is t by 2 to t. The total duration is again t by 2 and whole divide by 2. So how much it is? This is 1 by 4 plus 1 by 4. So 1 by 2. So net energy for one period is a square t by 2. The net energy for one period is a square t by 2. I will write down ET here, a square t by 2. So t and t cancel. What is the net power for the sinusoids? Okay, a square by 2, sorry. Okay, this is something that must be already known to you, a very standard result. So see, I'll tell you one point here. See, if you talk about xt equal to a sine omega t plus phi, even some constant phase. Okay, or whether you take it as a cos omega t plus phi. Okay, for either of them, the power, the average power of the signal is just dependent on the amplitude, not on the frequency, not on the phase. It is a square by 2. Okay, so what is the RMS value of this signal? RMS value is, I told you, root over of the average power. Root over of the average power. So that is why I think you must be knowing what is the RMS value of the sinusoid. When you take the under root of this, it becomes a by root 2. Okay, again standard result, this must be known to you. So RMS value is a by root 2. Okay, now next thing is, let me tell you here is, suppose there are two signals given to you, x1t equal to a sine omega 1t. Okay, what can be next possible question from here? Suppose another signal is a1, this is a1 and this is a2. Another signal is another sinusoid and maybe having some phase difference phi. Okay, a sine omega 1t and a sine omega 2t plus phi. Okay, see, there are two cases. Number one, if omega 1, okay, is not equal to omega 2, different frequency sinusoids, okay, then the power is simply additive in nature. Orthogonality applies here. I'm just telling you the direct result. P1 plus P2. Okay, that means the net average power will be, what is P1? The power of the first signal, amplitude square by 2. Okay, for the next signal, a square by 2, a2 square by 2. Okay, so that is the net power. Okay, for different, if the sinusoids are of different frequency. Okay, but if the sinusoids are of same frequency, if omega 1 equal to omega 2, then the power is not directly additive. Okay, then the power is given by P1 plus P2 plus A1 A2 cos phi. Okay, then the power is given by the formula P1 plus P2. P1 means A1 square by 2, P2 means A2 square by 2 plus A1, A2 cos phi, where phi is the phase difference between the two sinusoids given. It is the phase difference between the two sinusoids given. This must be known to you. Okay, have a look into it. Find the power of this given signal. 5 cos pi t plus sin pi t. 5 cos pi t plus sin pi t, correct? 5 cos pi t plus sin pi t. Okay, what is going to be the power for this signal? Okay, now because these are the sinusoids of the same frequency, omega 1 is equal to omega 2, both have the frequency equal to pi, correct? Okay, so then the other formula will apply. Okay, so what is going to be the net power? Amplitude square, 5 square by 2. Then next amplitude is 1, so 1 square by 2 plus a1 a2 cos phi, 5 into 1 into cos phi. What is the phase difference between them? No, sorry. What is the phase difference between them? One is cos and one is a sine. Okay, one is cos, one is a sine. So phase difference is actually 90 degree. Phase difference is actually 90 degree. Okay, because it is cos and sine. See, don't only look into the bracket term, na? See, cos and sine, the phase difference, they already differ by 90 degree. Okay, so cos 90 will come 0. So again they become orthogonal. Okay, and then it becomes simply, the power becomes additive in nature, and then the net answer is 26 by 2, 13. The net answer is 13. 1, 3, 13. Check it out, it is 13. I'll tell you why. You have some of you getting answer as 18. Why? Because you have taken 5 into 1 into cos 0. You have added 5. It's not cos 0. See, many times you have to be careful. One is cos, one is sine. I have given both the result as sine plus phi. The phase difference between sine and cos is automatically 90 degree. Okay, that visual observation has to be strong. But no problem. These mistakes can be done now. Now is the time where you learn, where you improve. It should not be repeated in the exam. It should not be repeated in the exam. Okay. Right. So that is what it is. All right. Next question. Easy one. Gate 25 1 mark question. Tell the power of the signal. Okay. See, if continuous time periodic signal is given to you, and if t is the period of the signal, if t is the period, what is this integral 1 upon t integral 1 by t mod xt whole square dt? What is this? Okay, 1 upon t and integral 0 to t modulus x square t. Okay, this is the formula for energy. So what is this question? Et by t, that is the average power. The question is nothing but calculate the average power of the given signal. And yes, guys, if you are really learning with motivation, if you are gaining, do not forget to put your attendance. And what is attendance on YouTube? Is a simple like button. Do not forget to like the session. Come on, keep liking, be motivated. Yes, guys, only 119 likes still. Now, come on, press your attendance. Okay, be attentive, press your attendance. Okay, show your motivation, show your love towards the Om Institute YouTube channel. Okay. Let me again tell you as a reminder, tomorrow, electrical machines marathon for electrical aspirants. Day after tomorrow, 28th, analog circuits, both ECD and EE. So many marathons are being placed for you. Just have to be subscribed to the channel so that you don't miss out any of these sessions. Okay. Yeah, next one. What is there in the next one? So what is the average power? Now, okay, what are the frequencies? This is omega 1 equal to 2 pi. This is omega 2. Different frequencies are there, na? Okay, 4 pi. So I'll not write down the frequency. I'll only highlight that all these three frequencies, omega 1 is not equal to omega 2 is not equal to omega 3. Okay, if there are sinusoids of different frequency, power is directly additive in nature. Okay, so what is that average power? For constant. Okay. What is the average power if it is only a constant term? If it is only a constant term. See, if xt is simply a constant term a, what is the average power of it? A for all values of time. Okay. So what is the basic formula for power? I have told you, from which we started. The basic formula for power can be written as limit of t tending to infinity 1 by t integral minus t by 2 to t by 2 x square t means a square here dt. So a square is constant, dt integral t lower limit minus t by 2 upper limit t by 2 and whole divided by t and limit t tending to infinity, but upper minus lower limit will become t by 2 minus of minus t by 2, so t cancel. Okay, answer is simply a square. Okay, for a the power will simply be a square. Okay, so what is the answer now? For 1 it's going to be 1 square. Okay, for now a cos omega t power is a square by 2, 2 square by 2. Next again 2 square by 2. Next again 2 square by 2. So all of these are 2 plus 1. Net answer is 7. Net answer is 7. Yeah, some of you already given the answer as 7. Okay, some of you already given the answer as 7. Okay, now see, this is method number 1. Okay, the average power. Okay, method number 2, which I will not discuss right now, it will take for some time, and that is by the concept of Fourier series. That is by the concept of sinusoids. Okay, because the different frequencies are given are just multiple of the fundamental frequency of the signal. Okay, by the CTFS and Parseval's theorem. CTFS and Parseval's power formula. Okay, I'll tell you the Parseval's power relation, but later on, not required right now. Okay, right now we have solved it simply in the time domain only. Okay, yeah, gate 15 1 mark question. Okay, the waveform of a periodic signal is shown in the figure. Okay, a signal GT is given to you, x of t minus 1 whole divided by 2. What is the average power of GT? What is the average power of GT? A signal GT has been given to you. What is the average power of GT? What is the average power of GT? Come on. What is the average power? Now see here. Okay, first of all, the waveform for xt is given and they are asking the power for GT. Okay, they are asking the power for GT. Let us first calculate the power of xt. Why? Because see, if xt has the average power p, then x of t minus 1 by 2. Let me write this way, t by 2 minus 1 by 2. Okay, that is the signal GT. X of t by 2 minus 1 by 2. Does time shifting change the power? No. Does time scaling change the power? No. Time scaling does not change the power of power signal. If it was an energy signal, it changes the energy. That is what I told you. So it will have the same power p. It will have the same power p. That is why you calculate the power of xt is enough. You don't have to draw a new waveform. You don't have to draw a new waveform. Okay. Now what is the power for this signal? Okay. What is the average power for this signal? Power or average power? Again, we'll use the same method. Energy in one time period divided by the time period. What is the value of the time period? Okay, so see, I'll begin from here, -1 and going up to 2. So the time period is 3. Okay, the first pulse starts from -1, next repetition starts at 2. The gap between them is 3. Okay, so the time period is 3. Okay, what is the ET, energy in one time period? Okay, now what is this? This is a triangular pulse. Okay, triangular pulse, amplitude square into duration by 3, a square t by 3, amplitude 3 and duration 1 units. Okay, amplitude 3, duration 1 unit, divide by 3. Next one, again a triangle. Negative amplitude -3, doesn't matter, -3 square will be same as 3 square. Okay, -3 square into duration. Duration of this one is also 1, divide by 3. Okay, so what is the net answer? 3 square by 3 is 3. Again 3 square by 3 is 3. Divide by 3, so net answer is 2. Whatever is the power of xt, same is the power for gt. The correct answer for the signal is 2 units. That's it. Yeah, some of you already given the answer as 2. The correct answer for this is 2 units. The correct answer of this is 2 units. Okay, everybody? Okay. Right. Now, guys, before I take up the next point, important update for all of you that yes, guys, if you're looking for GATE 2027 preparation in the offline manner, or if your friends or if your juniors, okay, you can suggest to them as well if those who are looking and those who can be available in the Hyderabad, okay, for our offline batch, live in front of the faculty, connected with the faculty and in a competitive atmosphere, sitting amongst hundreds of students, okay, automatically that motivation will boost up because hundreds of aspirants are parallelly preparing for you in front of you physically. Okay, so you can join the offline classes available for both EC and EE. The first batch starts 26th February. No problem. After the GATE exam only we are starting. The first batch 26th February, okay, is going to begin up, okay, at Om Institute, Hyderabad Center. Okay, now let us talk about some basic classifications. Okay, some basic classification. Let me start with linearity and non-linearity. Okay, linearity and non-linearity. Okay, a system which follows superposition is said to be linear. Now, what is superposition? Superposition contains two properties, additivity, okay, and scaling. Additivity and scaling. What is additivity and scaling? See, I'll talk about additivity. Okay, if x1t has the output y1t, okay, if x2t has the output y2t, additivity simply says that for the signal x1t plus x2t, the output will be y1t plus y2t. For the signal x1t plus x2t, the output will be y1t plus y2t. Okay. For x1t plus x2t, output is y1t plus y2t. Please note this. Okay, that means if two inputs are added, the outputs are also added. That is additivity. Scaling. Okay, if xt produces some output yt, scaling says that k into xt. Scaling means amplitude scaling. Okay, scaling here is amplitude scaling. So if you multiply the amplitude of input by k, output amplitude also multiplied by same number k. So for kxt, output is kyt. Okay, that is what is the scaling property. The combination of them is the superposition. That means if there is any signal a1 x1t plus or minus, additivity includes minus as well actually, plus a2 x2t, the output of this signal should be how much? For a1 x1, output is a1 y1. For a2 x2, scaling says that output is a2 y2, and plus minus means plus minus additivity. That is what is superposition. Okay, now I'll tell you one simple thing. I'll tell you one simple thing to think about linearity. Suppose the question is, okay, yt, sorry, where is that question gone? Yt is axt plus b, okay, with some dc term, with some constant, axt plus b. It looks like linear because it's a straight line, but I'll tell you, suppose if the xt is the input, this gives the output yt. What is the yt? axt plus b. That is given in the question. Suppose if the input is 2xt, okay, suppose now if you take the input as 2xt, okay, what is the output? What is the output? It is a times the input. What is the input? I have taken 2xt plus b. That means the output is 2axt plus b. Is the output 2yt? Is the output equal to 2yt? Is the output equal to 2yt? Now what should be 2yt? 2yt means 2axt plus 2b, but it is not plus 2b, so it is not 2yt. Okay, so if the input is multiplied by 2, output is not multiplied by 2. So scaling fails. If anyone fails, okay, you can stop there. No need to prove additivity separately. Okay, it is a non-linear system. It is non-linear. Anyone fails, it is non-linear. Correct. Anyone fails, non-linear. Now, suppose if the question was, if the question was only this much, yt is equal to axt, that's it. If this much was the question, okay, then the output is directly proportional to the input. Okay, now if you had taken input as 2xt or any kxt, what about the output? Output is a times input, a into 2xt, but a into 2 is 2 into a, this is 2axt. Okay, and that is equal to 2yt. So if you take the input 2xt, you get the output 2yt. You can try with any number. Okay, additivity will also apply here. Okay, additivity will also apply. Okay, if you had taken the input xt, which is x1t plus x2t, okay, then the output which is axt, okay, is ax1t plus ax2t. I open the bracket. What is ax1t? It is the output due to x1. Output due to x1 is known as y1. What is ax2t? It is the output due to x2, which is known as y2. So what is the final output? y1 plus y2. Additivity. Okay, so the system which follows both additivity and scaling, that is what is linear system. Okay, so that means, correct. Important point is, what is the type of waveform between input and output? See here. Okay, understand this way. Okay, what is yt? Okay, what is yt? axt. Okay, so understand as y versus x curve, not time. Okay, y versus x curve. How will you draw y versus x curve here? Simple, na? It's going to be a straight line passing through origin. It's a straight line passing through origin, and whenever the IO curve is a straight line passing through origin, like a resistor, a simple resistor, ideal resistor, okay, which is a linear device. Diode is a non-linear device. Whenever you have a straight line, not only straight line, but straight line passing through origin, because y equal to ax plus b, is also a straight line, not passing through origin. Okay, when you have a straight line passing through origin, then only that particular system will represent a linear system. And to have a straight line passing through origin, y must necessarily depend on, okay, what is then required is y depending on, y depends directly on x power 1. y depends on x power 1. Okay, it should not be x squared term, it should not be e power x, it should not be sine x, all of them will become non-linear. Okay, see, the next question was x square only, but if you think about the y versus x curve, okay, y equal to x square, what is the curve? What is the IO curve here? Parabolic curve. Is it a straight line? Not at all. It is a straight line, not at all. Non-linear. Only x power 1 function can be linear, and not even the constant. Okay, not even the constant. Okay. For the offline classes timing, you can contact our number. They will guide you better about the entire model and classroom structure and the timings and the faculty. You can just contact the numbers as I mentioned there. Okay, I think it is hidden there. 95156 94053. 95156 94053. Okay. Yeah. So what is there where we were? Yeah. So because it's a parabola, it cannot be linear, simple. Okay, it cannot be linear. Okay, even plus b also not allowed, as I told you. It has to be only xt, axt, x power 1. Okay, or otherwise if you try scaling, suppose if you take the input 2xt, if you take the input 2xt, you think again this way, what is going to be the output? Output is 3 times square of the input, but what is the input now? 2xt. So 2xt whole square, okay, will become 2 square 4. 4 into 3xt, I'll modify this way. That means what is 3xt is the yt. Okay, the input is 2xt, output is 4yt. If it was linear, output should be 2yt, na? Output should be 2yt, it is non-linear. Okay, then already I told you, sine, okay, non-linear. X cube coming up, non-linear. Okay, right, x cube coming up, non-linear. Product of xt is again x square. This is also non-linear term. See, if any one term is non-linear, plus b also makes the system non-linear. All the terms here are contributing to non-linearity. Okay, non-linearity, right? Okay, log of xt, non-linear. Only x power 1 function. Y depending directly. What is the important point I mentioned? Y depending directly on x power 1. Then only you get a line passing through origin. No plus b, no x inside sinusoid or exponent or log. All of these are non-linear. Simply just have to check and give me the answer. E power xt, non-linear. Cos xt, non-linear. Okay, y square is 3xt. Now see here, it's not x power 1t, it is y square depending on x power 1t. So actually what is yt? Yt is root 3 times root over 3xt, under root xt, non-linear. Under root xt, non-linear. Or y square equal to x. This is again a parabola opening to the right. Not allowed. Only straight line allowed. Y versus x should be straight line. Have you got this point or not? For most of the questions, you know the linearity answer actually. You don't have to worry. Okay. Now, when I talk about basic operation, if there is any time coefficient term in the input-output relation, okay, time coefficient term means if there is any separate time term, or not only time term, any time function, that will not affect the linearity. See, yt is t square xt. I'm not, see, to derive linearity, additivity and scaling is required. But why to derive? We have this, I have told you the simple logic. Na? Any separate time term also does not matter. Does not matter. What you have to only check, tell me. What you have to only check is y depending on x power 1. See here. Okay, y of t is t square. This is a square term, but on time. Okay, y depending on x power 1. Yes, this is linear. Okay. No need to prove everything by additivity and scaling. I'm just telling you the direct conclusion. Okay, y depending on xt. See, if the question was like this, yt equal to t x square t, then there is no role of this term. Because y depending on x square, okay, non-linear. How is the y versus x relation? Any separate term of time will not affect your answer. Please mind it. Next answer, tx squared. Yeah, that's what I have just written. That's what I just actually explained you. Tx squared, non-linear. Okay, then some more conclusions. Let's go through this slide. Okay, any separate time term, okay, will not affect. Okay, time shifting will not affect the linearity. Okay, time scaling will not affect the linearity. Okay, amplitude scaling will not affect the linearity. Okay, time folding does not affect the linearity. Amplitude folding does not affect the linearity. Operations in time argument. Okay, any operations in time argument means, what do I mean here is, with respect to last point, see, we have already known yt. Suppose if I have taken this example, yt equal to 5xt. This is linear, na? Right? Okay. This is linear, na? This is linear. Now see here, y depending on x power 1, linear. But now if I give you the question like this, yt equal to 5x of t square, 5x of t square, max of 0 comma xt was a gate PYQ non-linear, floor ceiling will be non-linear. How will be the floor ceiling function? Okay, it's a floor case, na? Differential equation also will come, Abrar. Yeah, I'll take for differential equation also. See here. Okay, so I'll repeat what my point was. If this is linear, any change in the time argument, any change on the argument on the time means inside the bracket, if you do any change on time, it is still going to be linear. Okay, 5x of t square, or if I had given you something of this kind, 5x of 2t plus 5, this also will be linear, because y depending on x power 1, this is important. Anything inside the bracket or outside the bracket, y depending on x power 1, anything inside or outside the bracket will not affect the linearity. Clear? Both of these are linear. Both of these are linear. Okay, time shifting, y depending on x power 1, yes, that is important. See, you don't only see time shifting. What is the first thing is y versus x. Suppose the question was 3x cube of t minus 1. Then will you say time shifting doesn't affect the linearity? First thing is, dear, y depending on x cube is non-linear, na? If y depends on x power 1, then the time shifting, time scaling, all of them does not affect the linearity. See, again, y depends on x power 1, linear. Then time scaling doesn't affect the answer. Y depend on x power 1, linear. Time folding also doesn't affect the answer. That's what I'm trying to tell you. Okay, now this is y depending on x power 1, linear. The same example I explained you. T square, any change in time argument will not affect the linearity. Okay, y depending on x power 1, any change in time argument, root t square, anything will not affect your answer. It is linear. Okay, it is linear. Then let me also define time invariance, and then I'll take the differential equation cases as well. Okay, see here, dear everybody. Time invariant or time variant systems. What is time invariant or time variant system? Please see here carefully. Okay, what do I mean by time invariant system? Okay, that is whose behavior does not vary with time. It is, does not vary with time means it is something like this, that if input xt is producing the output yt, if you apply the same input tomorrow means time delayed. If you apply the same input tomorrow, or after t naught amount of time, okay, it should produce the same output y. But only thing is, output will also start tomorrow. If you apply the input to a system tomorrow, it will produce the output also starting from tomorrow only. So output will also be shifted. That is what is the simple definition of time invariance. A time shift in the input should give the similar time shift in the output. If this is satisfied, the system is time invariant. Finished. Okay, right. So if a delayed input is applied to the system and output also delayed by the same amount, then it is time invariant. Okay, so we can conclude that input and output are synchronized for the time invariant system, which I am going to call it as TIV in short. Time variant means TV. Okay, now starting with this very basic question first, yt equal to axt plus b, and then again producing some conclusions for time invariance. Okay, yt equal to axt plus b. Yt equal to axt plus b. Okay, see here. Okay, what is the procedure? Now see, what I told you, for xt minus t naught, output should be yt minus t naught. Okay, yeah, I will come to causal also, just wait. Linear, causal, time invariance is going on, stability. See here, what I want to check in this question, this is already non-linear, I want to check time invariance. See, make it a simple two-step procedure. Okay, make it a simple two-step procedure. See, if the input is given as xt, it produces some output yt, correct? Now, step number 1, apply the step number 1. Okay, take delayed input. Take delayed input. Okay, suppose the delayed input is x1t. Okay, delay the input by some amount t naught, xt minus t naught. Okay, what is the expected output? What is the expected output? Yt minus t naught. I will do a separate calculation. Step number 2, calculate separately. 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 calculate separately some output, which is y of t minus t naught. See, some input output relation will be given to you, na? So from that input output relation, can't you directly calculate y t minus t naught? Okay. Now, if input was xt minus t naught, and if it has to be time invariant system, what is the expected output? I don't know what it will be, but what is the expected output? Expected output is y t minus t naught. So that I am calculating separately as y to t. Okay, that means output due to this input. Okay, this is expected output. Okay, take delayed input and calculate the output y1t. Okay, but what should finally happen? That y1t and this y2t should match. If these two are equal, then the system is time invariant, otherwise not. Got my point? Okay. Y2t is yt minus t naught, which is also the expected output here. What is the output here? Y1t. That means these two should match. The answer of these two steps should match. Okay. So just a simple two-step procedure can be applied. But again, mostly you will not have to apply. I'll give you some conclusions very shortly. See, yt equal to axt plus b. I'm starting with this. Yt equal to axt plus b. Yt equal to axt plus b. Okay, let's do for this one. Okay, axt plus b. See here, what I'm going to do for this one, dear. Yt equal to axt plus b, na? Okay, step number 1. Okay, take the delayed input x1t, that is x of t minus t naught. This one is easy only. Okay, so what is the output y1t? It is going to be a into input plus b, a x1t plus b. And that is going to be, what is x1t? X of t minus t naught plus b. Okay. Now, step number 2, as I told you, step number 2 means calculate y2t separately. What is y2t? Yt minus t naught, where yt is given in the question. Okay, you have to calculate yt minus t naught. Okay, so that will be how much? A x of t minus t naught, correct? A x of t minus t naught plus b. Now, whether these two match or not, very clearly they are matching to each other. Y1 is equal to Y2, system is time invariant. Even with the B, the system is time invariant. So what is this condition? This system is non-linear, as I already explained you, but time invariant. So if I modified the question, and if the question was simply Yt is equal to axt, if this was the question, then, okay, if this was the question, then what is the answer? Now you see, then what is going to be the answer? This will be linear. Without B, it is linear. Okay, but it is still time invariance. It is time invariant with any value of B. B may be 0. And such a system which is both linear and time invariant, we will study them separately. They are LTI systems, which is both linear and time invariant. Okay. Now, let us see what disturbs, okay, the time invariance. Okay, what disturbs the time invariance? I'll take two questions here. To explain you that. Suppose, okay, my question is, I'll write down 3 cases, yt equal to x square t. Okay, and I will not derive this. See, this already we know, y depending on x square, this is linear, but this will be time invariant also. This is non-linear, sorry, what I have written here, I'm so sorry. This is non-linear, now y depending on x square. Okay, so this one is non-linear, but this will still be time invariant. You can still apply the same, two-step procedure. Okay, what disturbs the time invariance? That is what I want to discuss. Now, suppose you take the question yt equal to t square xt. Okay, this system is still linear. This one will be linear because y depends on x power 1. Correct, na? Y depends on x power 1. This is linear. Already we discussed this point. Okay, we have to prove time invariance. We have to prove the time invariance. Okay, so the step number, that two-step procedure I'll write down here. Okay, step number 1, take the delayed input x1t, x of t minus t naught. Okay, what is y1t? So what is the input output relation? Output is t square times input, t square times x1t. Okay, that means the output is t square x of t minus t naught, t square x of t minus t naught, t square x of t minus t naught. Okay, t square x of t minus t naught, right? I'll stop here. Okay, then step number 2, calculate y2t separately. What is y2t? Is y of t minus t naught. Okay, y of t minus t naught. What is y of t minus? Now see, y of t minus t naught. Wherever there is t na, you will replace this on the right side. Okay, so it is going to be t minus t naught whole square, x of t minus t naught. Now whether y1 and y2 are same, y1 is t square x t minus t naught, y2 is t minus t naught square x of t minus t naught. y1 is not equal to y2, the system is time variant. The system is time variant. Okay, I'll give you the Telegram link, just wait for it. Okay, whenever I give some break, I will give you the Telegram link. Okay, now next question. Okay, so see here, there was a separate function of time. Now the next case, x of t square. Okay, so for the previous case, the system was linear. I'll write down the answer here actually. Okay, this system was linear but time variant. It is not time invariant. X of t square is also linear because y depending on x power 1, any change in time argument will not change linearity. Okay, now I'm going to check the time invariance. Okay, dear. Okay, step number one, take the delayed input. Take the delayed input x of t minus t naught. What is the output? Output is given by x1 of t square. X of t square. The input is x1 t square. Now please see carefully. What is x1 t square? Any change in t will be reflected here. Na? This is t naught, which is constant. This is not time parameter. It is a constant value. Okay. So what is x1 t square? Will be written as x of t square minus t naught. Any confusion, please tell me now only. Some of you are telling answer as time invariant here. No. Okay. See, only the change here will be this t square minus t naught. Step number 2. Step number 2 is y2t is y of t minus t naught. In the given question, whatever is yt given, place yt minus t naught. So this is t here. Any change in t will be happening here. So be careful. Right side t square, but you have to replace t by t minus t naught now. T minus t naught whole square. So see, in the first y1, it is x of only t square minus t naught. In the x2, it is t minus t naught whole square. What does it mean? Both are not identical. y1 not equal to y2. System is time variant. So dear, what is our simple observation? What is affecting? What is the simple observation? What is affecting the linearity? Just tell me. Sorry, time invariance of the system. Linearity we have discussed. What is affecting the time invariance? Any separate function of time outside? Okay, or any changes in the time argument inside? Okay, any changes in the time argument inside will affect the time invariance. Okay, see. Okay, due to presence of any time coefficient term. What I mean by this separate function of time, that I already told you. If there is any separate function of time, okay, the system will be time invariant. See here. If yt is equal to f of t, separate function of time, into any function of input, that doesn't matter. That function of input will decide linearity. Okay, but any extra function of time, any separate function of time, time variant. Any separate function of time, time variant. Okay, then, yeah, this one, any operations on time argument, this one is important, make the system time variant. That is what I told you. So suppose if the thing is like this, okay, if it is x of, okay, or any function of input, g of x of why I am taking x of ht, sorry, why I am taking g of x of ht. First is, what is x of ht? This becomes the changes in time argument, and this change in time argument makes the system time variant. G of x means any type of input function can be given. See here, understand this way. Output can be, what is one question we solved? X of t square. This is time variant. What I'm trying to tell you is y of t. See, this is time variant but linear. The question may be like this. Okay, sine of x of t cube. Okay, now because it is sine of x, it is non-linear. Okay, but because it is having t cube, change in time argument, it is time variant. Got my point? Okay, got my point? This is the difference. Okay, so whether final input term you see and inside the bracket, if it is only t, okay, not a problem. Any change in time argument, it will be time variant. Suppose if the question was only sine of x of t, This sine of xt means the system is non-linear, but no change in the time argument, no separate function of time. Okay, time invariant. What are the factors which is breaking the time invariance? Okay, changes in time argument or any separate function of time. Okay, that means if I place the next question here, suppose you may have a question like this: sine of t multiplied by x of t. No problem. It is directly multiplied by x power 1 function. It is linear. But this separate function of time, time variant. Because of the separate function of time, it is time variant. See the differences in the question. Okay. Now, any change in time argument is also equal to time scaling. So, time scaling will also make the system time variant. Time shifting will not affect. Okay, but time scaling, time folding, all of them will make the time system as time variant. Okay, amplitude scaling will not change. Okay, so within this operation only, I can write down time scaling, because that is also changing in time argument. So time scaling and time folding, I will write down this separately. It is written above as well, but time scaling and time folding will also be a time variant case. Just wait on, dear, just wait on. Hello. Hello. Yeah. Okay. It would be fine now. Hello. Hello. Yeah. Okay. It would be fine now. Okay. Yeah. Let's continue. Okay, so got it now. The sine t will not disturb the linearity. Y versus x relation depends linearity. Okay. It is linear only, but time variant because of the extra time term. Okay, so that is what we were discussing. Sine of xt, okay, non-linear, the same example I told you, but time invariant. No change in time argument, no separate function of time. X square t, non-linear, but time invariant. Okay, no separate function of time, no change in time argument. T minus 1 sine of xt, non-linear. T minus 1, separate function of time, time variant. Finished. Just observation. Okay, plus 10. Okay, plus 10 means non-linear. Any plus b is non-linear. T into xt, separate function of time. Separate function of time, system is time variant. Okay, cos 2t, separate function of time, time variant. Y depending only on x power 1, linear. Okay, y depending on x power 1, linear, but time scaling, time variant. Time variant. Okay, right? See, in the linearity, in the time invariance, listen to me carefully. I have only taken T domain. Why? Because 100% same result for N domain, for discrete domain. I will not take it separately. If required, any case I will take, but same question if I give you on discrete domain, y of n equal to x of 3n, 110%, 100 not 1000% same answer. Please mind it. That's why I'm not discussing it. Okay. Whatever discussion, see, like periodicity separate discussion required, energy calculation separate discussion I have done at, convolution separate discussion required, I will do it. Okay, but whatever is common, I will take it as in one domain only. Okay, same question, same answer. Okay, same question, same answer here. Okay, yn equal to 2. See, okay, you said and by default a discrete question came up. By default a discrete question came up. See, y depending on 2 power x function, exponential function of input, non-linear. But any separate function of input? No. Okay, so this is time invariant. See the difference in the question. Question could have been this way also. Y of n equal to 2 raised to the power n xn. 2 raised to the power n xn. Y depending on x power 1 only, linear. But now this is a separate function of time. Now this is a separate function of time. Okay, right? Okay. Now there's a separate function of time. So time invariant. Oh, sorry, time variant. Time variant. Okay. Got it? So the first case non-linear time invariant, second case is linear but time invariant. Sorry, linear but time variant. See the difference in two cases. See the difference in the two cases. Okay, dear? Okay. Now, linearity and time invariance of the differential equation given. Let us pick up a simple logic to solve. You don't have to solve the differential equation, get the y versus x relation. No. Okay, see here. Okay. Linearity means all the y and x and all the derivative terms. Okay. Linearity, all input and output and derivative terms, all of them. Linearity is always related to power 1 in first power. Okay, so see here very carefully, you see here. Okay, input x power 1, okay, output y power 1, its derivative dy by dt but power 1. Yes, this is linear. This one is a linear equation. Okay, this one is a linear equation. Okay, all the terms are in first power. Now, separate function of time multiplied anywhere with input or with output. See, the separate function of time can be multiplied by output also. Now, you see here, if the question was like this, if the question was t into yt. See, one question we took earlier, y square t equal to xt. Already I told you non-linear. Okay, not only x, but y, both should be power 1. So, already we discussed this question earlier, this was non-linear. Now, t into yt equal to xt. Okay, there is a separate function of time which is multiplied here to the t, which is multiplied to the output side. So, what is the yt here? Yt is 1 by t xt. Yt is the 1 by t xt. 1 by t xt eventually means what? Okay, separate function of time. So, time variant. Na? Okay, so that is what, see, any separate function of time multiplied either by input side or either by output side, okay, will make the system time variant. If any one was also there, the system is time variant. So what is the answer for this differential equation? It is linear but time variant. It is linear but time variant. Next question. Now look into this. Input power 1. Okay, sorry, derivative of the input power 1. Yt power 1. First derivative of yt power 1. Second derivative power 1. See, this is not power 2. This is the second derivative. Okay, d2y by dt square whole power 1. So, all the input and output terms as well as their derivatives are in first power. This is a linear differential equation. Okay, this is a linear differential equation. Okay, then is there any separate function of time? See, what makes the system time variant? Any separate function of time or changes in the bracket time, changes in time argument, changes in time argument. Okay, so is there any change in time argument? No, all are t only. Any separate function of time? No, what is multiplied are constants. Okay, so there is nothing to disturb time invariance. The system remains to be time variant, time invariant. The system remains to be time invariant. Time invariant. Govind Rao, what was the doubt? I think I missed it by chance. You can please recommend it. Okay, the system is linear and time invariant. That means what type of system it is? Again, we represent this systems as LTI. Again, we represent these systems as LTI system, the systems which are both linear and time invariant. The systems which are both linear and time invariant. These are LTI systems, correct? These are LTI systems, right? Linear and time invariant systems. Now see, pay attention here. These are linear and time invariant systems. Okay. Now, from mathematics point of view, okay, the LTI system, okay, will always correspond to LCCDE differential equation. In mathematics, we call this equation as LCCDE. What is LCCDE? Okay, you attend any of my earlier session on differential equation on YouTube, it will be available. Linear constant coefficient. Linear constant coefficient differential equation. It is linear, I explained you, and all the coefficients are constant, independent of time. Okay, so this is what is constant coefficient differential equation. LCCD. In mathematics, we call it as LCCDE, which we solve by the combination of CF and PI. Okay. In signal and system point of view, you can solve this, equation, okay, by Laplace transform, either by CFPI in mathematics, or from signal system point of view, you can solve this by Laplace transform if it is LCCDE, okay, LTI system. Okay, chalo, anyways, next. Okay, now integral. Okay, integral minus infinite to 3t xt dt. Okay, x tau deta, of course. See, integration operation is always linear. Why? Because simple logic is integral of basic integral property. How do you split integral of f1 plus f2? It is integral f1 plus integral f2. So since basics of integral properties are known to me, okay, integral f1 plus f2 is integral f1 plus integral f2, as well as integral of some k f1 function. K is constant, so it is k integral f1. That means, okay, if input was f1, output was y1. If input is k f1, output will be k y1. It is a linear system. It is a linear system. Integration means linear. Okay, you have to worry about time invariance. Now, integration operation may be time invariant also, time variant also. It depends on the limit. Okay. See, I already told you, Govind Rao. Okay, time shifting does not affect the time invariance of the system. Okay, and as well as linearity of the system. Okay, as well as linearity of the system. Got it, Govind Rao? You are talking about a question of this kind maybe. Suppose y of n is equal to y of n minus 1 plus 2xn, something of this kind, Govind Rao. Correct? Okay. If all of them are in power 1, okay, and there is no separate function of time, no change in time argument, it is going to be time invariant as well as linear. Got it, Govind Rao? Okay. Time shifting in both the cases I told you, time shifting does not affect the linearity also, does not affect the time invariance also. Okay, Ram Yadav, yes. Chalo guys, so it is linear. Okay, now I want to talk about time invariance. Now I want to talk about time invariance. See here. Okay, I will just discuss this point very carefully, time invariance. Okay, for time invariance, I will again do the two-step procedure. What is the step number 1? Okay, take the delayed input, x1t, x of t minus t naught. Okay, then I will place my conclusion. Okay, right? X of t minus t naught. What is the delayed output? What is the output due to this delayed input? The output is given by integral minus infinite to 3t x tau. Here x is x1, x1 tau d tau. I will place the value of x1 tau, integral minus infinite to 3t. What is x1 tau? It is x1 tau. So here I am changing the t equal to tau, so it will be changed here. X of tau minus t naught. T naught is just a constant. Okay, x of tau minus t naught d tau. Okay, x of tau minus t naught d tau, right? Okay, then what is there in the step number 2? Step number 2 means I define y to t. What is y to t? Here also I will do some change, but let me write down y to t. How do we take y to t? Okay, directly wherever there is t, on the right side it has to be changed. On the right side it becomes integral minus infinite to 3 t minus t naught. Okay, 3t minus t naught, x tau d tau, correct? Right side, this is the t, this is the tau term. Oh, sorry, the question is x tau d tau. It has to be x tau d tau only. Okay, so integral minus infinite to 3 t minus t naught x tau d tau. Now whether y1 and y2 are equal or not. Okay, see here, to compare them, first you have to make the common function. Here it is x tau d tau, here it is x tau minus t naught d tau. What will I do? In the first one, okay, call the tau minus t naught as u. In the first one, call the tau minus t naught as u. Okay, so what will be y1t? Integral limits will also change. Okay, but first I will convert this as xu. Okay, now what is d tau? What is d tau? That will be du, because t naught is a constant, so d tau will be du. So now we have the common function xu du or x tau d tau, one and the same thing. Okay, limits. Okay, now tau minus t naught, lower limit of tau minus infinite minus t naught, no effect, minus infinite. Upper limit was 3t. Okay, so what is the upper limit of u? Tau minus t naught. What is tau upper limit? 3t. So 3t minus t naught. Now see here, both of them are not exactly same. Both of them are not same. Here, the upper limit is 3t minus t naught. That means 3t minus 3t naught. Here, the upper limit is 3t minus t naught. Okay, the upper limit is different. Okay, that means when you compare these two, they are not accurately equal. Y1 not equal to Y2. This system is time variant. I will tell you the difference now. I will tell you the difference now. Okay, the difference is, okay, if the question is this way, integral minus infinite to t x tau d tau, integral minus infinite to t x tau d tau. Okay, this system will be linear. This system will be time invariant if the upper limit was only t. Think, you retry the method. If the upper limit was t, then both the answers will match. Okay, the upper limit is t. Okay, then the second case that I have taken in the current question is yt equal integral minus infinite to at x tau d tau. Integral minus infinite to at x tau d tau, and that is going to be how much? Okay, for such a case, the system is still linear but time variant for any other limit other than t, if it is 3t or 2t or t by 2 or anything of that kind. Okay, let me also add on that the above function with t will be causal, okay, but unstable. We will come to causality, unstability. I'm just mentioning the answer here. Okay, so this one will be causal and unstable. We'll come to causality and stability also. This will be unstable. Okay, but this particular term, linear and time variant, this particular term, this minus infinite to at, this will be non-causal as well and anyways unstable. This one will be non-causal. Okay, we'll come to causality and stability, then you can understand this. We'll come to causality and stability. We'll come to that in some time. Where is, oh, by mistake I have reached to some other slide, but no problem, I'll jump to it. Just a second, है ना? Yeah, come on, comment on this one. Don't worry, I will give you Telegram. I'm telling you many times. Whenever I give some break, I will give Telegram. You only are here for Telegram or watching the video. I don't know. Just wait. You will get the PDF in Telegram. Telegram link I'll give you. Anytime I'll give you. Okay. Look into this question and answer it to me. Okay. For the input and output of a system which are related by yt equal to max of 0 comma xt, then the system is what? Yes, good morning, Chinmoy. Right. If the input and output are related by this equation, yt equal to max of 0 comma xt, then the system is what? Then the system is what? Linear and time invariant, non-linear and time invariant, linear and time variant, non-linear and time variant. Okay, see here, max of 0 comma xt. Okay, how can I describe this output? It is max of 0 comma xt. That means whoever is greater. That means if xt is greater than equal to 0, answer will be xt. If xt is smaller than 0, less than 0, then answer output will be 0. Then the output will be 0. Correct, na? Then the output will be 0. Okay. See, we can write down this way also. We can also write down this one as output equal to xt u of xt. U of xt. Another technique of writing the same question. Why? Because, see, how does unit step work, you know, na? Okay. Whatever inside the bracket, if that is positive, unit step will be 1. So, if xt greater than 0, if xt greater than 0, if xt greater than 0, answer will be 1, you will get only xt. If xt is less than 0, unit step will be 0, net answer will be 0. Okay. Or otherwise, one more way you can think about this. What is the y versus x curve? Okay, output equal to x2 only for x positive. Only for x positive, but otherwise 0. So, it is not a continuous line. Okay, I mean, it is, in terms of continuity, it is continuous, but it is not a single unique line passing through origin. Okay, there is this flat line also. There is this flat line also. Okay, the straight line passing through origin from minus infinite to infinite, that was a linear curve. So, this one is clearly non-linear curve. What is the linear curve? I already told you, na? For negative s also, y should be proportional to x. It is non-linear. Okay, otherwise one simple way of talking about linearity. Acha, time invariance, you tell me, no need to do the step 2, na? No need to do the step 1 and step 2 derivation again. Okay, what makes the system time variant? Any changes in time argument inside the bracket? Inside the bracket, it is t only. Okay, any separate function of time. See, this is u of x. This is a function of input, not u of t. Any separate function of time? No, no, no. So, this is time invariant. This is time invariant. Okay, this is time invariant. Graphically, I told you non-linear. Or one more thing you can say. Okay, suppose if the x1 is 2 and if the x2 is minus 3. Okay, what is the y1? Okay, output is max of 0 comma x. So, in 2 comma 0, the maximum is 2. Okay, what is y2? What is the y2? Okay, y2, or let me take it as more simple. Let me call it as minus 1. x2 is minus 1. So, out of minus 1 or 0, who is maximum? 0. y2 is 0. But when you take the input x1 plus x2, when you take the input x1 plus x2, 2 plus minus 1 is 1. Okay, 2 plus minus 1 is 1. What is the output? Max of 1 comma 0 will be 1. Is the output equal to y1 plus y2? No. Output is not equal to y1 plus y2. That is why it is non-linear. That is why it is non-linear. That's what I told you. That's why it is non-linear. Got my point? Okay. So, that is what the answer is, non-linear but time invariant. Non-linear but time invariant. B answer. B answer. Time invariance, nothing. See, many of you told time variant. No, 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 no. It is B. It is not D. It is B. I'm telling you na, if the question was like this, if the question was yt equal to xt multiplied by ut, this is a separate function of time. That makes the system time variant. Right? That makes the system time variant. But here y depends only on x power 1. This will be linear. Okay. What is my current question? Yt equal to xt u of xt. Okay, because of ux function, this was non-linear, but this is time invariant. Both the models written in front of you. Tell me. That's what I'm telling, na, Thanmai. Okay, for time variant, what is required? You think this way. Time variant means any separate function of time like ut. Okay, it is not ut, it is u of xt. Any separate function of time? No. Second thing, any change in bracket time, time argument? No. No, that is why it was time invariant, previous one. Got the thing now? Okay. Next question. GATE 2022 2 marks MSQ question. GATE 2022 2 marks MSQ question. Have a look into this. The output of 4 systems S1, S2, S3, S4 corresponding to input signal sin t for all t are shown in the figure. Based on the given information, which of the 4 systems is or are definitely not LTI? Okay, which of them are not LTI? That means, okay, not LTI means either they are not linear or not time invariant, anything fails. Okay, the system which are both linear and time invariant are LTI. So we have to figure out non-LTI system. Now see here, there are different ways of understanding this question. Suppose if you take the second case, okay, for all the inputs, for all the systems, input is common, sin t is applied and it has given the output as sine of t plus 1. It has given the answer as sine of t plus 1. Sine of t plus 1. Okay, so that means the second system, I can write down the input versus output relation. If suppose input is xt, output is x of t plus 1. X of t plus 1. Now can you say linear or non-linear? Why depending on x power 1? Linear. Okay, time shifting only, and time shifting does not affect the time invariance. It is both linear and time invariant. It is LTI, but my target is to find out the systems which are not LTI. Which are not LTI. The systems which are not LTI. Okay, now second case, okay, or yeah, come to the second case. Sin t equal to sine minus t, output is sine minus t. That means if you assume the input as xt, output becomes x minus t. Okay, output is x minus t. Why depending on x power 1? Linear, but time folding, time scaling and time folding. I told you, time scaling and time folding makes the system time variant. Okay, so option number A also non-LTI. Non-LTI. See, there are two ways of thinking this. Okay, or possibly you may think here sine minus t is minus sine t. Okay, you may think yt is minus xt. You may think this way also. Okay, you may think this way also. Then it becomes LTI. But what if I think the first way? That's what I am telling Ram Yadav. So that is also okay. But if I take directly, you are changing the data to minus sin t, which is okay. I don't deny. But if I go with the original data, then also it should satisfy. But if I go with the original data, it is non-LTI. So it has to be counted as non-LTI only na. Okay. Third system, sin 2t. Okay, so I will take the output as x of 2t. If the input is sin t, output is sin 2t, x of 2t. Okay, why depending on x power 1? Linear. Okay, linear only. Okay, but time scaling, time variant. So it is ln tv, so non-LTI. So this is again non-LTI. This is non-LTI. Okay, next question. Okay, sin t, sin square t. So what I can take here very clearly, x square t. X square t. Okay, so x square t is clearly non-linear. Okay, but no change in time argument. This is time invariant, but any one fails, so it is non-LTI. Okay, so which of them are non-LTI? First, third and fourth, except the second one. Okay, first, third, fourth. ACD. ACD. MSQ. Good question, MSQ. Basic analysis, but good question. ACD. ACD is to be taken as the correct answer here. Okay, everybody. A, C and D to be taken as the correct answer here. A, C and D are taken to be the correct answer. ACD. Okay. See, there is one more thing. I'll tell you one more method for the system number 3. One more thing we should know. Okay, if I talk about system number 3. See, suppose if I am talking about system S3. Okay, what is given? Okay, sin t, sin 2t. Sin t gives the output sin 2t. Okay, if it was LTI system, okay, sin omega t, okay, will give the answer sin omega t plus some phase difference. Okay, some amplitude change maybe, but same frequency. Okay, here it is different frequency. Okay, if a sinusoid is applied to a LTI system, we will see this point also. Okay, this is mentioned also. Okay, so whenever a sinusoid is applied to LTI system, the output is a sinusoid signal of the same frequency. It will have some amplitude scaling and a phase difference, but not frequency difference. The output is the sinusoid of same frequency. So that is also the reason we can call the system 3 as non-LTI. Non-LTI. Okay, different frequency. I will mention here as well. Different frequency sinusoid. That is not the property of LTI system, but this point will be seen. This point will be seen later. Yes. So as of now, ACD correct answer. ACD correct answer. I have marked here, right? ACD is the correct answer, which I have marked here. Okay. So yes, guys, we'll talk more about LTI systems now. As I told you, causality and stability we'll add after some time. Let us start talking about the LTI systems right now. Okay, let us start dedicatedly talking about the LTI systems right now. Yes, are you looking for a break right now, or shall we hold for the break for some more time? I think possibly we can hold the break for some more time. ACD correct answer. ACD correct answer. Okay. We'll go for the break after some more time. Just wait for it. What is there? Just wait for it. What is there? So guys, yeah, I already mentioned that our offline course, the first offline course, is going to begin for GATE 2027-28 at Hyderabad Center on 26th February. Okay, but yes, if you are willing to prepare, if you cannot by chance travel to Hyderabad, and if you are willing to prepare with the OM faculty, ECEE best faculty team, okay, you can still prepare in the online live manner. Okay, and the first online live course for GATE 27 and 28 starts 2nd of February. Okay, it starts 2nd of February. Okay, 1 and 2 year, two different models are available based on whether you wanted GATE 27 or GATE 2028. Okay, yeah. Definitely, I'll give some small break, but let's continue for some more time. Let's continue. I'll give the break after some time. Okay, now coming to the LTI system and the convolution, as I highlighted in the beginning, I have shown you some weightage analysis and whether your branch is EC or EE, or in fact IN also. Okay, the convolution part is actually very important. The classification was also important, so I've covered it by some time. I've covered linearity and time invariance. Later we'll pick up causality and stability, but right now let's talk about the discrete time convolution. Let us talk about discrete time and continuous time, both we will take. Okay, so suppose you have a LTI system. Now you all know what is LTI system which is both linear and time invariant. Okay, where input applied to the system, let's say xn is the input, okay, also known as excitation. Input also known as excitation signal. Simply let me write as excitation. It produces some output, also known as the response of the system. Output or response of the system. Okay, but to calculate output for any LTI system, okay, we need to know Hn, which is known as the IR, impulse response. Again, I'm not deriving how convolution comes, not required right now at the revision phase. Okay. Okay, so let's say IR, impulse response of the system. Okay. So you tell me what is the doubt there, winter child, why you could not understand linearity? Linearity, I have told you two ways, graphically also, and I have taken the simple additivity x1, x2. That simple method I have taken there. Okay, you tell me what is the doubt that is striking to you. Okay, IR, impulse response of the system. Okay, what do you mean by impulse response? Response, as I told you, output. Impulse response means the response of the system. Okay, means the output of the system. Okay, for impulse input, for unit impulse input. Output of the system for unit impulse input. That means if I show you a separate picture here, suppose if you take the same system, okay, if you take the same system, suppose the system is S, let me define the system as S, and when you apply the input as suppose delta n, unit impulse, then whatever output you get is known as the Hn, impulse response of the system. That is known as the impulse response of the system. Correct. Now output is definitely defined as the convolution between input and the impulse response, and given by the convolution sum. In the dt domain we have sum, in the ct domain we have the integral. Okay, what is that convolution sum? It is given by yn equal to summation minus infinite to infinite xk h of n minus k. Okay, yn, repeat, is summation minus infinite to infinite x of k h of n minus k, where k is the summation parameter. Okay, this is the convolution sum. Okay, now before I start any questions, let me also define the properties of the basic convolution. Okay, or before I define the properties also, I'll define both. Let us define both convolution sum and convolution integral, and then keep solving the question. Okay, and then keep solving the question. Yeah. Convolution in the CT domain, it will be convolution integral. Okay, again the same story. There is a LTI system, input xt, output yt, input also known as excitation, output also known as response. Ht is again IR, impulse response, meaning the same definition. Okay, the output is the convolution between input and impulse response, written as xt convolution ht, and defined by the formula integral x tau ht minus tau d tau. Integral x tau ht minus tau d tau. Okay, this is what is known as convolution integral. Now when it comes to property, they follow a set of similar properties, and some properties may be unique. Okay, they follow a set of similar properties and some property may be unique. Okay, so yeah, what are the properties of DT convolution? Okay, just covering the basics of both, and then the question. Here convolution means question is very important, so I have taken a set of good questions also to make this topic from basic to clear level. Okay, the convolution is also always commutative. Commutative means you can swap the operand. Xn convolution Hn is Hn convolution Xn, or if I want to write this mathematically, what was the Xn convolution Hn? It is written as summation of xk h of n minus k, and this is also then equal to summation of hk x of n minus k. Anyways you can write. The convolution is commutative. Okay, now time invariance. Okay, because the convolution is applicable for LTI system which are automatically time invariant. Okay, so see here, if xn convolution Hn is yn, what should be x of n minus n naught convolution Hn? So see, input xn gives the output yn. Time invariant system, x of n minus n naught should automatically give the output y of n minus n naught. A time shift in the input gives the similar time shift in the output. That's what we know. A time shift in the input gives the similar time shift in the output. That is what we know. Okay, that is what we know. The x of n minus n naught convolution Hn is y of n minus n naught. Is y of n minus n naught. Okay, y of n minus n naught. Now because convolution is commutative, you can swap also. The shift can be given to Hn also. Xn convolution Hn minus n naught equal to y n minus n naught, correct? Okay, or x of n minus n1 convolution h of n minus n2 will be, okay, if both are shifted, output is shifted because of both, y of n minus n1 minus n2. Okay, simple but important property. You can find it useful many places. Linearity or distribution, that means x1 plus x2 whole convolution Hn bracket can be opened. Additivity, x1 convolution h plus x2 convolution h. Okay, then convolution with impulse replicates the signal, that is xn convolution delta n is xn. This is also useful in many places. Xn convolution Hn is equal to xn. Okay, this time shifting also very much useful. The general time shifting, the time shifting can be applied to both. Okay, right. Convolution of any signal with unit impulse will replicate the signal. Okay, I'll just see your doubt, Winter. Let me complete the property. Xn convolution delta n will be xn. No change in xn. The answer will be same as xn. That is why we call it as replication. Okay, the step response of the system. Now, what is the meaning of step response? I already defined impulse response. What is impulse response? Okay, what is impulse response? Impulse response is the response due to unit impulse signal. So what is step response? It is the response due to unit step signal. Okay, it is the response. So let me explain you how the step response is actually coming up. Okay, what is the meaning of the step response? Okay, you have a system S whose impulse response is Hn, onto which you apply the input as unit step input. Then whatever output comes up, this is what is known as the step response. The response due to unit step input. Okay, what is the step response? See, how is the step response actually calculated? Now, the step response, any output is input convolution with the impulse response, un convolution with Hn. What is the input here? Only thing is you have to place un. Okay, or you can write down Hn convolution with u of n. Okay, and then open the convolution formula. It is given by summation hk u of n minus k. Okay, k being written from minus infinite to infinite. K being written from minus infinite to infinite, right? Okay, right. So now we all know about unit step function. What is there in the unit step function? Okay, the n minus k must be greater than equal to 0. The n minus k must be greater than equal to 0. Then only the unit step is 1. The argument has to be positive. So what about n greater than equal to k? But summation is with respect to k. So think about k. What is k? K less than equal to n. Okay, so that is why the final relation. What is Sn? It is given by summation of hk, unit step value will be 1, but for what value of k? K less than equal to n. So upper limit is n, lower limit from minus infinite. So minus infinite to n, upper limit modified. That is what I have written in the property directly. Okay, summation minus infinite to n hk, that is the step response. Or if you want vice versa also, na, if you want impulse response from step response, that can be obtained as Sn minus S of n minus 1. Sn minus S of n minus 1. Okay, now these properties, there are some more properties, but these properties, okay, including the step response part, are exactly similar in the CT domain as well. Let me go to the step CT domain. Questions will take together. Okay, so CT convolution integral I defined for you. Okay, looking into the first set of properties, see here, looking into the first set, it is commutative. Okay, commutative means in the integral form, xt convolution xt is integral x tau h of t minus tau d tau is also equal to integral h tau. You can write h first, then x of t minus tau d tau. Okay, the convolution CT domain, DT domain, it is commutative. Okay, then xt convolution ht is yt. So then xt minus t1 convolution ht minus t2, output will be yt minus t1 minus t2, shifted because of both time shifting Rundle property. Then linearity or distributive, you can open the bracket, x1 plus x2 convolution sh is individual, you can open it. Okay, then convolution with impulse will replicate, again replica property, xt convolution delta t is xt. Okay, or time shifting has been applied. Okay, same thing. And step response, where is that step response? Yeah, the step response, as I just explained you, there it was summation hn, here it is integral h tau. Okay, or vice versa, if you want to write down, by the same logic, I calculated step response, by the same logic we can calculate for CT domain. Okay, what is that step response? Integral minus infinite to t h tau d tau. Integral minus infinite to t h tau d tau. Or impulse response if you want. So what is the inverse of integral is differentiation. That will be the derivative of the step response. The definition and how to calculate step response remains to be same. Okay, so that is the step response. Okay, then okay, the starting time, these are some properties that I will usually explain with questions, but you can just note down right now. Okay, the starting time of yt, wherever output will start, that starting time will be the sum of the starting times of the given two signals xt and ht. Same applicable for ending time. Okay, and the duration of the output is equal to the sum of the durations of xt and ht. I'll come to this and I'll explain this. Okay, but all the properties I wanted to be together so that it becomes a easy revision notes for you. Okay, the area of yt, that is integral yt, is the integral xt product integral ht. Okay, an integral of a function is area under the function. So area of yt, very useful property, product of area of xt and ht. Directly 2 mark questions have come 2-3 times only on this property. The area of yt means convolution of xt and ht, is product of the areas of xt and ht. I will show you those questions as well. Okay, right. So if xt convolution ht is yt, if xt convolution ht is yt, okay, x dash t convolution ht is y dash t. That means if the input is differentiated, output is also differentiated. Simple. If input is differentiated, output is also differentiated, because convolution is commutative, so you can swap these two. That means the derivative can be applied on h also. So xt convolution h dash t is y dash t. That means in convolution, if any one signal is differentiated, output is differentiated. Or more generally, I can write, suppose if both were differentiated, so output will be double differentiated. So if any one signal differentiated, output is differentiated because of that. Okay. Scaling, x alpha t convolution h alpha t is 1 by mod a y alpha t. Okay, the scaling property is applicable if both the signals are scaled by the same parameter alpha. Okay, it should not be x2t convolution h3t, then property not applicable. x2t convolution h2t. Okay, x alpha t convolution h alpha t is 1 by mod a y alpha t. Remember, okay, scaling property, but only for equal scaling. Equal scaling. Now this also tells you that if I had chosen alpha minus 1, so time folding will also come, x minus t convolution h minus t. X minus t convolution h minus t is equal to y minus t, is equal to y of minus t. Modulus alpha is 1. Okay, x minus t convolution h minus t is y minus t. Okay, these are the set of properties that you should know for the CT convolution. Okay, for the CT convolution. DT convolution also, almost a few properties I told you. Let me go back to the property discussion of the DT convolution. Okay, these up to step response I already explained you. This was the step response calculation. How do we write down that property? Then same, starting time of output yn is the sum of the starting times of xn and hn. Again with the question this will be shown. Same for ending time. Length. Okay, the length of output in discrete domain is given by the formula Lx plus Lh minus 1. The length of the x, the length of the h minus 1. The length means, okay, the total number of samples from the first, okay, to the last. First non-zero to the last non-zero. Suppose if any signal is written like this. 2, minus 1, 3, 0, 4, 2. Okay. Doesn't matter whatever is the origin. What is the length of this signal? That is what is Lx. The length is starting from the first to the last non-zero. 1, 2, 3, 4, 5, 6. That is what is the length of this signal. Okay. Then in the CT domain, I have shown you the area, the integral property. Na? Integral yt is equal to integral xt multiplied integral ht. Here that integral is summation. Summation yn is summation xn into summation hn. Okay, the sum of the samples in xn, hn, yn are related by this property. Okay, summation yn is summation xn multiplied by summation hn. Of course, because it is a discrete signal, there is no derivative property and all those things that will come up here. Okay, that is going to come up here, right? All right, dear. Okay. Chalo. So going ahead, okay, for the question, okay, and before the question, some more standard results. See, firstly, I will take a question, okay, where unit steps are involved, okay, but I am starting with the question where one signal is unit step and another one is left-sided unit step, u minus n. One is un, which will go to the right. One is u minus n, which will go to the left, okay, which will go to the left. Okay, u1 and u minus n. That way I am taking, okay, we have to convolute between these two. We have to convolute, we have to do the convolution between these two. Okay, you will get a PDF of this in the Telegram. I will share you the Telegram whenever I give some break. Okay. Nah, gentle child, I have never taken that the signal is defined for t greater than 0. The signal can be defined for any value of time. I have nowhere mentioned in my derivation signal is defined for t greater than 0. What is the curve I have drawn is y versus x curve. There was no time parameter there. Shravan Kumar, what was your doubt in max function? Please tell me. Okay. Function, the input can be defined for any time, but whatever time input is there, if it is positive, output will be equal to input. If the input value is negative, output will be 0. That is what is the question. Okay, that is what is the question. Okay, Winter child? Okay, yeah. So, come on, let's start solving this question. Okay, so how do we convolute this? Okay, yeah, let us start the convolution. The question is convolute these two, that is y of n equal to x of n convolution with h of n, to be given by what formula? To be given by the formula summation of xk h of n minus k. Summation of xk h of n minus k, right? Correct. xk h of n minus k. See, that is not piecewise constant function. Okay, and every piecewise function is time variant. Where is that written, Shravan? Nowhere it is written. Nowhere I have told you from the today's class. Okay, otherwise you check it now. You apply the two-step procedure. If you are having any doubt, you apply the two-step procedure, step 1 and step 2. You will come to know that max question will be time invariant. You apply that as step 1 and step 2, and then let me know. Okay. Any doubt means apply. That is why I have told you the background also, step 1 and step 2. Yeah, come on here. Summation xk h of n minus k. So what is there? Okay, summation xk h of n minus k. Okay, I'll just substitute the data first of all. The summation is minus infinite to infinite. What is xk? 3 power k u of 2 minus k. xk means 3 power k u of 2 minus k, correct? And what is h of n minus k? U of n minus k. Hn is un, h of n minus k I need to write. Now, important point here is, okay, whenever unit steps are coming, you have to modify the limit. You have to simplify the limit. How the limit will be simplified? Okay, unit step will be equal to 1 only when the bracket, its argument is positive, greater than equal to 0. Otherwise, answer will be 0. And if any one unit step is 0, overall answer will be 0. So you have to ensure that both unit steps are 1. So first condition is n minus k greater than equal to 0. Second is 2 minus k should be greater than equal to 0. Okay, these are the two conditions, both are required. So from the first, what do you get? K less than equal to 2. And from the second, k less than equal to n. Okay, k is less than 2 and k is less than n. So what is the final condition required? K less than 2 and k less than n. What should be the final condition required? We have to think that way. If k less than 2 and k less than n. So see, k will be less than the lesser number, but which of them is lesser? I don't know. Okay, what I need is, I'll write down the condition here, k less than equal to 2 and k less than equal to n. Okay, so there may be the possibility that suppose n, okay, first case let me take, n is greater than or equal to minus 2. Sorry, n is greater than or equal to 2. I have to compare with this number. Okay, so who is lesser? Okay, who is lesser? Okay, k is less than 2, k less than n, k has to be less than equal to the lesser value. Okay, so I am telling you n less than 2. That means 2 is less than n. 2 is lesser. So k has to be less than equal to 2. Any doubts, please let me know here only. Okay, and then the yn will become, generally the limit of summation was minus infinite to infinite, but what I am telling, k has to be less than equal to 2 means upper limit is 2. Upper limit is 2. Okay, then what is inside the summation? Only 3 power k. Only 3 power k. Both the unit steps are 1, 1. Okay, so now we will solve this summation. But yeah, before I start solving this summation, okay, what about the second case? Second case means n less than 2. Now, if n is less than 2, the n becomes lesser. Okay, and k should be less than the lesser value. So lesser one will be n. K should be less than n now. K should be less than equal to n. So what is going to be the output now? Output will be equal to summation k equal to minus infinite up to n. K is n or less than n. So up to n is allowed. Summation minus infinite to n 3 power k. Now I need to solve both these summation. What is going to happen in the first one? Let me start with the upper limit. So 3 power 2. But from 2 we are going down actually. 3 power 2, 3 power 1, 3 power 0, 3 power minus 1 up to infinity. Okay, this is a GP with the first term 3 square. Common ratio, okay, common ratio 3. Sorry, common ratio 1 by 3, not 3. Otherwise GP is not convergent. Now every time 1 by 3, 1 by 3, 1 by 3 is multiplied. Common ratio 1 by 3. So this answer is nothing but 9 divided by 2 by 3. Okay, 3 you can take above. So 3, 9, 27. 27 by 2 is the first part answer. Second case, what is the answer in the second case? Okay, it is 3 power k. Start from the top limit 3 power n, but we have to go down. The next term will be 3 power n minus 1. Next term will be 3 power n minus 2, etc. till infinity. Again a GP. First term here is 3 power n and common ratio again 1 by 3. Every time 3 power minus 1, negative power of 3 is becoming. Okay, so this answer is 3 power n is divided by 2 by 3. 3 again going up, so you can write 3 power n plus 1 divided by 2. Okay, finished. Okay, these questions usually little calculative and they are not very frequent question also. What is frequent, I will tell you. Convolution I told in the beginning is very important. PYQ history also says very important, but what type of questions are more important? But you have to be ready for this. Okay, so what is the output that has been calculated? Output has been calculated in two parts. Firstly, we got the answer as 27 by 2. Under the first case, when n is greater than equal to 2. When n is greater than equal to 2. Next case, I got 3 power n plus 1. Correct, no? 3 power n plus 1 is divided by 2. Okay, if n less than 2. This is what is the answer you can say. This is the answer to the question. Yn, okay, can be the first or second based on the value of n. Okay, for n greater than equal to 2, it is constant 27 by 2. Otherwise, it is 3 power n plus 1 by 2. Okay, when n is less than 2. Okay. Any confusion in this method, you let me know. Okay. Now, this was the question which was involving unit step. Whenever there is any question which involves unit step and unit step. Okay, this is normally the procedure. Okay, we have to solve the convolution sum, and whatever unit steps are inside the convolution, okay, we have to take the bracket of the unit step and make it greater than 0. Otherwise, unit step is 0, and if unit step is 0, overall answer will be 0 only. Correct? Okay. Similar question, similar philosophy is there in the CT time also. Now in DT time, based on this, some standard results also can be noted. A power n convolution, A power n un convolution, B power n un. How do you solve this? Okay, you can solve this by the same method I told you, or you can solve this by the Z transforms as well. Okay, right? Yeah, you can combine also. You tell me how can you write down the combination? You tell me how can you write down the combination? Yes, you can combine code bits. Try how you can write down. Okay, right? Tabular format for finite length signals, Rikina, for finite length signal. Okay, that I'll come to that also, tabular form. Okay, so by the same method or by the Z transform, by any ways, if you solve A power n un convolution B power n un, it is given by B power n plus 1 minus A power n plus 1 upon B minus A whole multiplied by un. Okay, then the next result, A power n un with A power n un is n plus 1 A power n un. Okay, and then if I take A equal to 1, so I get step convolution step, un convolution un is n plus 1 un, which is also equal to n plus 1 un plus 1, because at n equal to minus 1, n equal to minus 1, this value will be automatically 0. So whether you start at minus 1 or whether you start at origin doesn't matter. And n plus 1 u n plus 1 is r of n plus 1. Final thing that I need to note down is, see, two things important from this slide, okay, for direct takeaway. Okay, the convolution of right-sided exponential, u a power n un convolution b power n un. Okay, a power n un convolution b power n un. Okay, and then second takeaway from this slide is step convolution step, which can also be directly discussed in the exam. Step convolution step is shifted ramp signal r of n plus 1. Okay, this is the next takeaway from this one. Okay, similarly, first let me go to the similar model question. Okay, similar model question. Okay, so yeah, so code bits has given one doubt. I'll write down the answer for both. Can you write down this particular answer in a single format? See here. Okay, we can also write down this answer. It depends on how options are given. Okay, 27 by 2 for n greater than equal to 2. So simple logic, multiply by un minus 2. Why? Because un minus 2, okay, un minus 2 is the unit step signal, okay, which will start at n equal to 2. Un starts at n equal to 0. So un minus 2 starts at n equal to 2. Simple logic, na? Okay, simple logic. Plus the other part, 3 raised to the power n plus 1 divided by 2. Now this is the part to be defined, which is for n less than 2. Okay, for n less than 2. So this can be written as u of minus n plus 2, or u of 2 minus n, how code bits have written. Correct. Okay, so that can be written as u of minus n plus 2. Because you see, okay, when will this signal exist? When minus n plus 2 greater than equal to 0 means n less than equal to 2. Okay, n equal to 2 can be taken anywhere. Okay, n equal to 2 can be taken at anywhere. No. Yeah, that's what. It should not be overlapping. So this answer will actually be, when you say n less than 2, you have to make sure, okay, already 2, discrete time domain, you have included 2 here. So n less than 2 means n less than equal to 1 actually. Sorry, there has to be a correction. Okay, n less than 2 means n not equal to 2. Equal to 2 already included here. Okay, otherwise don't include here or include. You can include anywhere. Okay, so n less than 2 means n less than equal to 1. It starts from 1, not from 2. N less than 2, not equal. So equal to what? 1, 1 and below. Okay, so then this signal is minus of n plus 1. Minus of n plus 1. This has to be the next part. Okay, so code bits, your second part has to be 1 minus n. Okay, that is the correction you have to make. Okay, that is the correction you have to make. So this signal will start from minus n plus 1 greater than 0. That means n less than equal to 1. That is what you will get. Okay. So if the options are in by chance this format, anyways, I told you, firstly, what I told you is, okay, this variety of question, you should know, they may come, but not very frequent. What is very frequent, I'll tell you. Okay, and then based on the same method, you can solve these convolutions, which are important. Suppose here only, if I write down a question based on this result, suppose if there was a question, half power n un convolution 1 by 3 power n un. Okay. Method number 1, you can apply this formula, or you can solve by Z transform. But right-sided exponential, common question, so you can directly apply the formula. No need to, because if you take Z transform, then you will have to break into partial fraction, inverse Z transform, all those. No, you can directly write down the answer. How much? I have written the answer as b power n plus 1, that is 1 by 3 power n plus 1 minus a power n plus 1, that is 1 by 2 power n plus 1 whole divided by b minus a 1 by 3 minus 1 by 2, okay, and then multiplied by un, multiplied by the un, right, multiplied by un. Okay, so when you simplify this, 1 by 3 minus 1 by 2 will be negative 1 by 6 actually. Okay, so that minus sign I'll adjust in the above. 1 by 6, so 6 going above, and minus I will adjust. Okay, so in the numerator, if you adjust the minus, so half power n plus 1 first, then minus of 1 by 3 power n plus 1 is whole multiplied by un, is whole multiplied by un, right? This is what is going to be the answer. Or then if you finally multiply 6 inside, so 1 by 2 will cancel, 3 into half power n, first term, minus 6 and 1 by 3 cancel, 2 into here 1 by 3 power n, whole multiplied by un, whole multiplied by un. Okay guys, this is what is going to be the answer. Okay, this is what is going to be the answer. Okay, so this case also can be done. Now a similar philosophy question in the CT domain, a similar philosophy question in the CT domain, then we'll come to the tabular method. Okay, whatever questions are on same model, I want to take it. So see, CT convolution integral formula I already defined for you, then I have taken the properties and all those things. Many properties were also similar. Then similar first right-sided exponential signals, ut, e power minus at ut, convolution e power minus bt ut is e power minus at minus e power minus bt upon b minus a. Okay, here if you put a and b equal and solve, e power minus at ut with e power minus at ut, we get t e power minus at ut. And next, if I take a 0, then I get ut convolution ut, which is tut, and tut is ramp signal. So step convolution step is direct ramp here, not shifted. This is important. These two are take away from this particular slide, and then I will write down a question with some a and b value. Suppose I have written a question here. Okay, suppose e power minus tut convolution e power minus 3 tut. Now again, this question can be solved by the direct formula that I am telling, or Laplace transform. In the continuous domain, you have Laplace transform. In discrete domain, you have the Z transform. Okay. So what is this value here? E power minus tut convolution e power minus 3 tut. Come on. Okay. So if I directly apply the formula, it is given by e power minus at minus e power minus bt divided by reverse b minus a. That is 3 minus 1 whole multiplied by ut. 3 minus 1 is 2. So nothing. Final answer is I take half outside. Half of e power minus t minus e power minus 3t whole multiplied by ut. E power minus t minus e power minus 3t whole multiplied by the ut. Okay. E power minus t minus e power minus 3t whole multiplied by ut. This is what is the final answer. Okay. Okay. Now a similar model question. Okay, where one is ut minus 1 right sided, one is u2 minus t. Minus t means left sided. Okay. As I have solved that dt question, of course the summation will become integral, but the process and philosophy will not change for the question. Okay, that is why I am taking the similar model question first. Okay, the process and the philosophy will not change. Okay, so let us see what is the process here. Okay, so yt, the convolution has to be done. Okay, xt convolution xt ht, and the formula is integral of x tau, integral x tau h of t minus tau, h of t minus tau, integral minus infinite to infinite, integral minus infinite to infinite, minus infinite to infinite. Okay, now let me place the data. Okay, what is the data here? Integral minus infinite to infinite. What is x tau? E power tau, replace t by tau, u of 2 minus tau, multiplied by h, that is u of ht minus tau, so u of t minus tau minus 1 d tau. Okay, but again, whenever inside the summation or integral unit step is there, what you will do? You will change the limit. What is there? You will change the limit. Okay, what is this? 2 minus tau greater than equal to 0. What is this? T minus tau minus 1 greater than equal to 0. So this tells you how much about tau? Tau is less than equal to 2. And here, okay, here what about tau? Tau is less than equal to t minus 1. Okay. So again, there are two conditions. Okay, right? See, Shravan, if Laplace was always simpler, I would not have taken this discussion. You simply multiply, you take the Laplace, you multiply, you spend time or partial fraction, then you take inverse Laplace. That also will take little bit time. Okay, not lesser than this one. Okay, here if you are practice of this zone, you can solve this simple integration. Finally, e power tau integral. Okay, so if Laplace was way simpler than this, I would have directly gone to Laplace without even discussing it. Okay, okay. Then there is something. Acha, one more thing I'll tell you. Then there is something, sometimes they only ask the value of yt at t equal to 1, t equal to 2. Then we have to complete the integral only for a specific value. That becomes more easy. That becomes more easy. That is why I'm going with this. Okay. Anyways, what is the condition? I've got tau less than equal to 2 and tau less than equal to t minus 1. Tau less than equal to 2, tau less than equal to t minus 1. Okay, so tau less than 2. So again, as I told you, tau has to be less than what? Less than the whatever is the lesser value. Tau has to be less than the lesser value. Simple, na? Okay. So again, who is lesser? I don't know, because t is a time parameter, na? So first case, again you will assume that maybe t minus 1 is greater than equal to 2. We have to compare these two. Okay, so if t minus 1 greater than equal to 2, who becomes lesser? I am calling 2 as lesser. So tau is less than equal to 2. Okay, tau is less than equal to 2. So what about yt? Yt is integral minus infinite to infinite. That is integral minus infinite to 2. Integral of minus infinite to 2. Minus infinite to 2. Tau less than 2, the upper limit 2. E power tau d tau. This integral has to be solved. What is there? E power tau integral is e power tau limit minus infinite to 2. Okay, upper limit e power 2, lower limit e power minus infinity 0. So this answer is constant equal to e square. Okay, second case. Okay, what is there in the second case? Okay, t minus 1, okay, is less than 2. So I'm calling t minus 1 as lesser value, and tau has to be less than the lesser value, less than equal to t minus 1. Okay, so what is yt? What is yt? Integral minus infinite up to t minus 1. Tau is t minus 1 or below it. What is there inside the integral? Inside the integral is only e power tau, because both unit steps will become 1. Okay, so simple integral e power tau integral is e power tau minus infinite to t minus 1. Put down the upper limit, e power t minus 1. Lower limit again 0. So this answer is e power t minus 1. E power t minus 1. Okay, so final answer. Okay, what is the final answer? Final answer is again broken into two parts. It is equal to e square. It is equal to e square for what condition? For the first condition, t minus 1 greater than equal to 2. So what about t? T greater than equal to 3. So it is equal to e square for t greater than equal to 3. And next part of the answer is e power t minus 1. The answer is e raised to the power t minus 1 for t is less than 3. Okay, for t minus 1 less than 2 means t is less than 3. T is less than 3, right? Okay. Correct. Okay, so this is the answer. This is the answer. Or again, if you want the answer in one single line, I can write it as e square t greater than equal to 3. So multiply ut minus 3. T less than 3 or dt or continuous time name in t less than 3 or t less than equal to 3, same only. Okay, because in continuous time, okay, t less than 3 means what is the value less than 3? 2.999999999, which is almost 3. It is continuous domain. It is not discrete domain. Okay, so the next part will be written as e raised to the power t minus 1 u of minus t plus 3. U of minus t plus 3. This is another way of writing the answer. Again, it depends how the options are coming up. Yeah, it's a full class. It's a marathon. It's a full day marathon. Okay. And again, Shravan, as you were mentioning Laplace, okay, before you calculate the Laplace, you have to first apply some time shifting and time folding properties of time shifting, especially property of Laplace, you have to carefully apply. Okay, so it's not that Laplace will give one line answer. First time shifting property, then Laplace calculation, then multiplication, then partial fraction, then inverse Laplace. So that again will take a decent amount of time. Only thing here is you have to analyze unit step and the question becomes simple if you know how to analyze unit step. And what is unit step? It will take the value 1 when bracket is positive, otherwise 0. Whenever unit step is 0, answer is 0. So that's why I'm only taking the condition where bracket is positive and changing the limits of integral. Okay, that is how we can deal with this question. Okay. Okay. All right, guys. So it's 1:30 and I think now can be a good time to take a break. Now can be a good time to take a break. Before the break, just answer me one question, a gate 1 mark question. Just a gate 1 mark question. Suppose a signal yt is obtained by time reversal of the signal xt, that is yt is x minus t. Which one of the following is always true for the convolution of xt and yt? Okay, suppose the convolution of xt and yt, some signal zt, basic understanding of convolution is xt convolution yt. But what is yt? Yt is x minus t, time reversal. Okay, so I'll place down what is zt. Zt is xt convolution yt, but yt is x minus t. This is number 1 point. Okay, but convolution is always commutative. So there are two properties that you apply. Convolution is commutative. You can swap now. If you swap, you can write down the result as x minus t first and then convolution xt. Okay, then because of commutative. 3 here. Then second is, think about time folding property of convolution. I told you. Okay, time folding property of convolution I told you. Okay, as per time folding, okay, z minus t is obtained when both the signals of convolution are folded. Okay, so what should be x? What should be on the right side? X minus t, convolution xt. Okay, now these two become equal. Okay, so zt and z minus t are equal. Z minus t equal to zt. That means the convolution between them is an even signal. Z minus t and zt are same. Left and right are same. Even signal. Now this is method number 1. Those who know correlation, okay, method number 2. What is the method number 2? xt convolution with x minus t. A signal convoluted with its mirror image. Okay, this operation is also used to calculate the autocorrelation. The autocorrelation of the xt. Okay, and autocorrelation is always an even function. If you have studied autocorrelation, you must be already knowing this point. It is an even function. Okay, so otherwise I have solved this also. Option number A. Autocorrelation, because usually EC students will more confine about correlation and all, but this is a general method. Even EE students can easily understand this. Okay. Yeah. The correct answer anyways, it's a even signal. So a fundamental question on the convolution basic formula and basic property. Okay. So guys, time for a break. More convolution questions are there. Okay, but if I continue now, it will be too late for lunch, I believe. You and me, both of us, let's have lunch so that I also energize. You also take a refreshment. Okay, and I'm assuming that you can take the refreshment quickly. Okay, without taking a very long break also, because there is many more things to be done. Convolution questions are there, and after the convolution questions, what I'm going to take, I'll tell you. After the convolution questions, I am going to begin up. Just wait, I will tell you. Just finding a slide here. Okay. So probably around 20 minutes break, 15, 20, 20. Let's keep it as 20 and we'll resume at roughly 1:55 p.m. Okay, that means we are going for a rough 20 minutes lunch break. Okay, now since the content is very much, so we should not spend a lot of time in lunch, and it's an online class. You can also have the lunch wherever you are, at your hostel, at home. You can have it quickly and be ready. Okay, and we shall start in 20 minutes. We shall start after the lunch break in 20 minutes of time. Your countdown has started. Okay, let's connect in 20 minutes. Okay. Yeah, guys, see you in 20 minutes, 1:55 approximately. Okay, refresh. I was telling you, what after convolution question? The next very important topic. Okay, CTFS, CTFT. With CTFS, I will cover DTFS also. Actually, we can correlate and study today. Okay, so all these things to be taken after convolution. Okay, and many more things. Hello, 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 hello. Okay, guys. So, yes. Okay, groups. Okay, students. As you were asking that in which Telegram group the PDF will be available. Okay, so the link of the Telegram group I have shared with you. Okay, the PDF would be available in this particular Telegram group. Okay, and yeah, we went for a lunch break, and we are going to resume now. Yeah, chalo, first let's get started. Okay. Lunch break, and we are going to resume now. Just a second, I believe. Okay. Yes, guys, let's get started. Codebits, you can message me on the Telegram. You can just send me a DM Telegram personally. We can discuss all these doubts separately. I want to focus now on the subject again. Yes, guys, let's get started. So, going back to the convolution questions. Okay, this was one model of convolution question we discussed earlier. Okay, and now the next one. Now, where I'll take the signals involving finite length. Okay, and whenever you have questions with finite length signals, okay, here I take finite length. In CT domain, I will talk about finite duration signal. Okay, so for finite length signals, what you can follow is what I call it as sum by column method, or you can also call it as a tabular method. A sum by column method or a tabular method. a sum by column method or a tabular method. Okay, now see here, what will you do in the, again not deriving the sum by column method, only thing is you should be able to apply it. Okay, what you will do in the sum by column method, you will take any one signal, okay, and write it on the top. Why I told any one? Because I told convolution is commutative. And take the other signal and write it on the side, 2, -1 and 3. Okay, and then multiply all the elements of the top by first 2. Okay, so that will create the first row. So 2 into 1, 2 into 2, 2 into 2, 2 into 3. Then multiply the same elements by next entry here, -1, and write down the second row. But whenever you write the second row, write down 1 unit right, starting from here. Okay, just right shift 1 unit. So -1, -2, -2, -3. Then multiply by 3. So 3 into 1, 3 to 6, 3 to 6, 3, 3, 9. Okay, this is what is the result. Okay, and then add all the columns. That is what sum by column is. Okay, add up all the columns. So this is 2, this is 3, this is 4, 3, 7, -5, 1, 6, 6, 12, -2, 10, and then this is 3 and this is 9. Correct? Now, the next important point is both the signals, see the first sample arrow is marked, and the discrete time sequence, we all know what is the meaning of arrow. Arrow means the origin. That means both the signals are starting from origin. Both the signals are starting from origin. That means this is n equal to 0 and here this is n equal to 0. So tell me, where will output start? Okay, output will also start from 0 plus 0. Starting time property I told you, na? Starting time property I told you. Okay, the starting time of the output is equal to sum of the starting times of xn and hn. Okay, so this also will represent n equal to 0 plus 0, which is 0. That means origin will be here only. So what is the final answer for the question? This is the simple tabular method you have to follow. So what is the final answer? 2 and 3 and 5, 10, 3, 9. Just check the calculation once and arrow is coming up here. Arrow is coming up here. Tell me any doubt. Very simple method. Very simple method. So whenever you have finite length signals, simply fix to this method and try the next question now. Just try the next question and give me the correct answer with the correct arrow placed. Okay, 2 again discrete time signals are given, finite in length. To finite length discrete time signals are given. Give me the correct answer for this next question. Come on all. Okay. Acha, one more thing, just I'll show you. Just I will show you. See, where is the output ending? If this was 0, 1, 2, 3. Okay, so this hn ends at n equal to 3. If this was 0, 0, 1, 2, this is n equal to 2. Now see, if this is 0, okay, 0, 1, 2, 3, 4, 5. This corresponds to n equal to 5. This corresponds to n equal to 5. Why? Because n equal to 5 means this is 3 and this is 2. Okay, as I told you, ending time will also add. Ending time will also add. Just telling you the property. Then, what is the length of the output signal? 1, 2, 3, 4, 5, 6. You count here na, manually. 1, 2, 3, 4, 5, 6. Which should be equal to Lx plus Lh minus 1. Okay, length of the x signal 3, length of the h signal 4. 3 plus 4 minus 1 will be 6, correct? 3 plus 4 minus 1. Okay. Right. Going to the next one. Yeah, please solve this. Time folding, everything will be time folded. X minus t convolution h minus t is equal to y minus t. In time folding, Soumya, you have to time fold each and every signal. Okay, each and every signal. Okay, yeah, come up here and let's start completing this particular question. Okay, I'll again start by drawing the same table, the sum by column method, wherein any one signal you can write on the top, other one on the side. Okay, so I'm writing here, let me make it more simple. Let me just write down 1, minus 2 and minus 3 and 4 here. So that multiplication happens only with ones. Okay, 1, 1, 0, 1, 1. Anyone on the side, anyone on the top, your call. Okay, now multiplying by 1 makes it simple. So same numbers only, 1, minus 2, minus 3 and 4. Again multiplying by 1, so 1, minus 2, minus 3 and 4. Okay, but 1 unit right. Then 0, multiplying by 0, net result is 0. Then multiplying by 1, 1 more unit right. So 1, minus 2, minus 3, minus 4. Last entry, again 1, minus 2, 1 more unit right. Minus 3 and plus 4. Minus 3 and plus 4, correct, yeah. Now sum by column. So what is there? 1, minus 2 plus 1 is minus 1. This is minus 5. this is 2, and this is equal to 3, this is equal to -5, this is equal to 1, this is equal to 4. This is what is the final calculated answer. Okay, so 1 minus 1, okay, -5, 2, 3, -5, 4 and 1. Okay, now where is the arrow? That is also we have to take care. That is also we have to take care. Okay, so where is the arrow for this one? This is the arrow. Okay, so that means if this is the arrow means n equal to 0. So left side -1, -2, -3. This signal starts at -3. The arrow for this one is at center. Okay, this is arrow means n0. So to the left, this will be n -2, -1 and -2. Okay, so this particular signal will start, apply the starting time property. This will start from -2 and plus -3. So this will start at -5. So if this is n -5, -4, -3, -2, -1, and this is n equal to 0. So arrow should be at the -5. Okay, that is why C and D, two answers I saw initially. Arrow should be at -5 here. Okay, so correct answer then is C. Okay, that origin also you have to map very clearly. The correct answer is going to be C. Okay, the correct answer is C. Okay, then next question. Be ready for the next question. Now see, again, two discrete time signals Xn and Hn. MSQ question. Two discrete time signal Xn and Hn are both non-zero. Okay, Xn and Hn both non-zero only for n equal to 0, 1, 2. That means only 3 length. Only 3 samples will be there. Only for 0, 1 and 2 they are non-zero. Otherwise they are 0. Okay, 0 otherwise. So finite length signal. Okay, it is given that x0, x1 and x2. So for xn all the 3 values are given. For xn all the 3 values are given. What is the xn value? Okay, first value is 1, then next value 2, next value 1. First value is at origin. So I will mark the origin here, x0. Okay, now h0 is 1. Only h0 is given. Okay, so what is hn? Hn, the starting value is 1, that is at n equal to 0, but Hn is also non-zero for n equal to 0, 1, 2. So what are the other 2 values? What are the other 2 values? If they are not given, assume it to be A and B. You can assume it to be A and B. Okay. Then let Yn be the linear convolution. Let Yn be the linear convolution of Xn and Hn. Given that y1 is 3 and y2 equal to 4, you have to match the correct option. MSQ question. Yn is the linear convolution of Xn and Hn. Okay, so let me start, and out of that linear convolution, it's like a reverse question where convolution, some values are given, y1 and y2. Okay, we have to find the signal Hn also, which is partially given. Okay, just like a reverse question you can say. So what can I do here? Okay, I'll again draw the same term, sum by column method. Okay, so what is going to be there? Okay, 1 to 1, any one signal I'll write here top, and the other one is 1 A B. Now multiplying by 1, this is 1 to 1. Then multiplying by A, so A, 2A and A, 1 unit, right? And again multiplying by B, 1 unit, right? B, 2B and B. Okay, sum by column. This is 1, this is A plus 2, this is 2A plus B plus 1, this is A plus 2B and this is B. Okay, now both the signals Xn and Hn, they start from the first sample, that is the origin is here. This is n0 and this is also n equal to 0. So output will also start from 0 plus 0, which is 0. Okay, this is y0. Y0 is 1. But what is the data given? They have given y1. Okay, so if this is origin, this value automatically becomes y1. Okay, and y1 is given to you as how much? Y1 is given to you as 3. It is 3. So that means A plus 2 equal to 3. A is equal to 1. Okay, what is the value for y2? What is the value for y2? Okay, the y2 value is equal to 4. Y2 value is 4 and y2 is 2A plus B plus 1 and y2 is given as 4. That means 2A plus B plus 1 equal to 4, out of which A is already 1. So 2 plus B plus 1 equal to 4, and eventually B also is equal to 1. Eventually the B also is equal to 1, right? Now, what is the value of y3, y4, h1, h2? Okay, what is the h1? h1 means A equal to 1, correct. What is h2? h2 means B and B equal to 1. Okay, so this 2 is wrong. Okay, so D is wrong, C is correct. So H information is obtained. Now y3, y4. Okay, y3, y4. Okay, so this is the y3 now. What is y3? A plus 2B. A and B are both 1, so this will be 3. And what is the next part is y4? y4 equal to B and B equal to 1. Okay, so y3 is 3 and y4 is 1. y3 is 3, y4 is 1. Correct answer. A and B also correct. So 3 answers are correct for this MSQ question, A, B, C. Okay, A, B, C, 3 answers correct here. Okay. A, B, C. Not only C, 3 answers are correct here. A, B and C. A, B and C. 3 answers are correct. Y3 and Y4 also correct only. The MSQ question. That's why I have to scan the various parameters here. Tell me any confusion. A, B, C. 3 answers are there. Not only a single one. Okay. Okay. What is there? Next question. Okay. See, Shravan, wherever, see, that's what I told you, na. What is shifted? Shifted signals means you will shift the origin, na. Look into this question. Origin can be anywhere. You start the table from beginning only. There is no change in the table. Okay. Based on where the xn, hn start, you can decide where the output starts. Okay, Shravan, there is no change in the table. Okay, the signal xn and hn can start anywhere. Their arrow can be given anywhere. No change in the table part. Okay. No change in the table part. Right. Next question, what is there? See, a gate 17 2-mark question, a cascade system. Now, again, I don't want to derive, but just a simple thing. I think you might be knowing it also. No, D not correct, only A, B, C, Ramu. Okay. What is given? A cascade system having the impulse response H1 and H2, which is given. Okay. Where symbol arrow, achha, this arrow is missing in the question. I'll tell you, both the arrows are at beginning only. Okay. Now, the input sequence xn, again a reverse question, for which the cascade system produces an output sequence. Output is given to you. Okay. Output is given to you. The first thing is, whenever two systems are connected in cascade, their impulse response are convoluted actually. Whenever two systems are connected in cascade, the impulse response will be convoluted here. The impulse response will be convoluted. Okay. So, if I convolute the impulse response, what will I get? Let me check it here. Okay, I will do this calculation separately. Now, I will have to convolute the H1 and H2. Right? Okay, H1 and H2 is given to me. Okay, firstly, what I have is Hn, which is equal to H1n convolution with the H2n. Okay, and both of them have length 2. The sum by column method I'll again apply. What is that H1n? 1 minus 1, and the other one is 1, 1. 1 and minus 1, 1 and 1. Simple. Multiply by 1. 1 minus 1. Again multiply by 1, but 1 unit, right? 1 minus 1. So, this is 1, this is 0, this is minus 1. Okay. So, both of them started at origin. The output also will start at origin only. 0 plus 0. Okay. So, what is the final net impulse response? It is 1, 0, minus 1. There are two parts in the question. First, the net impulse response. Okay. Then, what is that input sequence which is missing here? Find the input sequence xn for which the output is given to you. Now, see here. Firstly, all options have length 4, but how to judge actually if the length was not known? See, length of the output always will satisfy length of the input plus length of impulse response minus 1. That is what I already told you, Lx plus Lh minus 1. Length of the output 1, 2, 3, 4, 5 and 6. Okay, the length of the output is 6 equal to Lx plus length of the overall impulse response. How much? We got the length of the overall impulse response as 3. Okay, plus 3 minus 1. So, what is the length of x? It has to be 6 minus 2, that is 4. Okay, so you can, assume the signal xn because it has to have length 4. That is clear from options also. Okay, but just I told you. So, you can assume, like in the previous question, 2 parameters were missing. Here, all 4 parameters of xn are to be required, A, B, C, D. Okay, A, B, C, D. Right. Okay, and output starting from origin only. Why? Because again this arrow is missing. The output given was also starting from origin only. So, that is why input will also start from origin. What is the input? Assume ABCD and find the value of ABCD. Okay. What is the Yn is xn convolution with the Hn, and that Yn is given to me as 1 to, how much? I'll just replicate the data. 1 to 1 and then reverse. 1 to 1 minus 1 minus 2 minus 1. Okay, now I will do again the sum by column method. What is xn? A, B, C, D. What is Hn? The final impulse response 1, 0, minus 1. Multiplying by 1, you get A, B, C, D. Multiplying by 0, you get all zeros. 1 unit right shift. Multiplying by minus 1, so minus A, minus B, minus C, minus D. Okay, now sum by column, this entry is A, this is B, then next is C minus A, next is D minus B, next is minus C, next is minus D. Correct, right? Okay, D answers have already started coming up. So let's check the answer then. Okay, what it is going to be? Okay, what is given to us? 1, 2, 1, minus 1, minus 2 and minus 1. Okay, that clearly tells that A will be 1. This tells you that B will be 2. Forget this, directly come here. Minus C is minus 2. So C equal to 2 and last D equal to 1. Okay, what is going to be the signal Xn? Okay, ABCD means 1, 2, 2 and 1. The arrow already I told you is at the first sample. So 1, 2, 2, 1. Okay, that is option number D. Yeah, I think in the comment box also I am able to see D mostly. Yes, the correct answer is D. The very correct answer is D. All right. Next question. Okay. Now, next about the basics of CT convolution, we revised before the break only. See convolution and the properties, important convolution results, and then how to solve the convolution where one is ut and where one is u minus t. All these questions also we solved. Okay, correct. This was one question that we have taken from GATE. Okay, now, like I took finite length signals in continuous time domain, important one, and I took the concept of cascaded system also. Now, finite duration signals in continuous time domain, and whenever I talk about finite duration signal in continuous time domain, two signals and two results are actually very important. That is convolution of two rectangles of equal duration, then convolution of two rectangles of unequal duration. Okay, convolution of two rectangles of equal duration will always result in a triangular signal, whereas the convolution of two rectangles of unequal duration will result in a trapezium signal. Okay, now given a question, how can you directly draw the triangle and trapezium? Okay, have a look into this result. Okay, have a look into this result. Okay, I hope it is visible. I've directly got it, cropped it from pen paper mode. See here, look into the two signals given. Look into these two signals given. X1t, okay, which is a rectangle of amplitude A1 located from T1 to T2. So this is the duration. Okay, this is the duration, which is nothing but T2 minus T1, difference of the time. Another signal is another rectangle only having some amplitude A2, but duration T4 minus T3, which should be equal to T2 minus T1. Both of them should have the equal duration. Okay, and what I am doing is I am talking about convolution of these two, and whenever you have equal duration, okay, whenever you have equal duration, the result you get is a triangle. That's what I told you. But how do you directly draw? How should I give you the result so that you can draw the triangle? Now, first thing is, where will the triangle start? Again, starting and ending point property. Na? Triangle will start from T1 plus T3. Sum of the starting times of the given signal. The triangle will end at T2 plus T4. It will always be a symmetric triangle. I mean, symmetric about the midpoint, whatever is this midpoint, but that is not required. What is the height of the triangle? I won't give you the height formula, but rather I will give you the slope formula. Okay, so that the same slope formula is applicable for trapezium as well. So you have to remember only one common formula. The slope of the first line is A1, A2. A1, A2 are the product of the amplitudes of the two rectangle given. Product of the amplitudes of the two rectangle given, right? Product of the amplitude of the two rectangles given, right? That is going to be A1, A2. Okay, and that is the final slope. If you know the slope is height upon base, you can calculate the height as well. Okay, then whenever there are, I'll take a question on it. Let's convert into numbers. But now, when you take the two rectangles of unequal duration, you see here, there is a duration D1, which is T2 minus T1. Take another signal having the duration D2, which is T4 minus T3, such that the duration D2 is not equal to D1. Then you get a trapezium. Then what you get is a trapezium. Okay, amplitudes again could be anything. Okay, amplitude again could be anything, A1 and A2. Okay, so where will the trapezium start? T1 plus T3, starting time property. Okay, where will the trapezium end? T2 plus T4. T2 plus T4. And again, trapezium, what is the slope of the first line of the trapezium? Is product of the amplitudes A1, A2. So you can calculate this magnitude. But in trapezium, you also need one more thing. Up to which point this will go? Okay, because trapezium, the function starts linearly, it increasing, then remains constant, then decreasing. So up to what point it is increasing, then it remaining constant up to what point? That also I will tell you. Let me take the data and I will tell you. Okay. Okay. Right. Let me take both the cases here. So let's convert this into question. Ft and Ht is shown below. Plot the Yt, which is Ft convolution Ht. First of all, let me look into the duration of the signal given. Ft is a rectangle. Okay, how much duration? 2 units. HT is again a rectangle. How much duration? Same, 2 units. Okay, right. Equal duration case. Whenever two rectangles of equal duration are required to be convoluted, the result is what? The result is a trapeze. The result is a triangle. Okay. Result is a triangle. Yeah, Udaykaran, correct. Very correct. Okay. The result is a triangle. Okay. So, the net result has to be a triangle. Where will the triangle start, dear? The triangle will start from 0 plus 0. That is origin only. Where will the triangle end? 2 plus 2. That is at 4. Okay. So, you have to draw a triangle starting from 0. Going up to 4. As I told you, always there will be a symmetric triangle only. So, this is the midpoint at 2. Okay, height I have not given you any formula, but what I have told you the slope. Okay, what I have told you the slope. Okay, what is the slope of this line is A1, A2. A1, A2 means product of the two amplitudes. 10 into 20, 200. Now, if the slope is 200, what is the slope? Slope is given by height is divided by base. Okay, height of this line is h. That's what I want to calculate. And base of this line is 2. Okay, h by 2. So, what is the h value? It has to be 400. Okay, so this h height of the triangle 400. So, answer should be a triangle located from 0 to 4 and the height, the maximum height occurs at the midpoint and that value of height is 400. Check your answer now. Check your answer now, and any confusion then you can update me. Right? Any confusion then you can update me. Come on. Okay. Otherwise, you can try the next question. Okay, find the convolution of, okay, now I have given the signals in the form of unit steps. Okay, first you have to draw the given signals, okay, and then get the final answer. Come on. Okay. Yeah. Yes, guys. Have we got the answer for this? Okay, let me first draw, okay, these two signals alone. Okay, suppose, what is this signal now? Difference between two unit step signals directly will always be a rectangle signal. Suppose this signal, I call it as xt. This is ut plus 3. Ut plus 3 starts at minus 3, left shifted. And ut minus 1 is at 1. So, the rectangle is obtained between minus 3 to 1. Okay. And this has how much value? 3. Okay. Any doubt in this rectangle? You can inform me. Now, what about this one? Okay, again there are two unit step signals that you are subtracting. So, subtracting them will get a rectangle again. Okay, suppose this signal is ht. Now, ut plus 1. Ut plus 1 left shifted unit step starts at minus 1 and ut minus 1 is at 1. So, the rectangle will be between minus 1 to plus 1. Will be between minus 1 to plus 1. This is the rectangle that you will be obtaining here. Minus 1 to plus 1 having the amplitude of 2. Okay. Minus 1 to plus 1. Okay. Now, these two are required to be convoluted. Okay. What is going to be the net result? That is what we need to find. Now, these are the triangles now of unequal duration. Okay. Suppose this is the duration d1 which is equal to 4 unit. What about this duration? This is the duration d2 which is only 2 units. Okay. So, these are the triangles of unequal duration. The result has to be trapezium. Okay. The result has to be what? Result has to be a trapezium signal. The result has to be trapezium. Okay, now where will the trapezium start? Starting time property, minus 3 plus minus 4, minus 3 plus minus 1, so minus 4. The trapezium starts at -4. Trapezium ends at 1 plus 1, that is equal to 2. Okay, but as I told you, 2 more points will be important. Up to what point it is increasing, up to what point it is constant. Now see, basically what you are required to do, starting to starting you have done, na? Starting to starting, -3 plus -1 is -4. Okay, now starting to ending, starting of first, ending to of the next, -3 plus 1, this is -2. Okay, then ending to beginning, 1 plus -1, this is 0, and then ending to ending, 1 plus 1, that is 2. Okay, so out of that, -4 is already there, 2 is already there. Now -2 will come first, so this is -2 and then origin. That means up to this -2, signal will remain constant. Sorry, signal will be increasing in nature. That is the linear portion of the trapezium. Then up to the origin, it will be constant, and then it decreases up to this t equal to 2. This is how the trapezium has to be drawn. Okay, this is how the trapezium has to be drawn. Okay, then what is the height of the trapezium? So again, I told you, I have given you a slope formula, and that slope formula is a1 a2. What is a1 a2 here? 3 2s are 6. Okay, so the slope is 6. Okay, now the slope, which is equal to 6, is again given by height upon base. Okay, this is the height, this is the height, and this is the height of the line, but the base of this line is 2 units, h upon 2. So h actually will be 12. Okay, so this height is 12. This height is 12, correct. This is the trapezium. You check your answer clearly now. You check your answer. This has to be the answer. Okay. And always remember, whenever you subtract 2 unit step signals, okay, you will get a rectangular signal. Okay. Any confusion in this point also, subtraction of step signal, you can mention it to me. Okay. You can draw 2 unit step signal separately and subtract, you will get the result is non-zero. Okay, only between the starting of the first to the starting of the next. That's it. Okay. Next question. Now, a very nice question of GATE 2023. Very nice question of GATE 2023 to be taken here. Okay, although it's 1 mark, but it's a nice question. For the signals xt and yt shown in the figure, zt is xt convolution with yt, and that result zt is maximum at t equal to t1. It's maximum at t equal to t1. What is the value of t1? Yes, good afternoon, Chinmay, good afternoon all. What is the value of t1? Now see, it is not rectangle with rectangle. 2 standard results onto which direct question come up, I told you that. Okay, what were the 2 standard results? Convolution of rectangle with rectangle. Equal duration, unequal duration. These are the 2 cases that I have differentiated. Okay, but what about here? What about here? One is rectangle and one is some line from t equal to 1 to 5. Okay, there is one line from t equal to 1 to 5. Okay, that is what is there. Okay, that is what is there. Okay, but they are not asking you to do the complete convolution. The question is the convolution between them will be maximum at t equal to t1. What is the value of t1 in seconds? What is the value of t1 in seconds? Now understand how do I approach this question. Understand how do I approach this question. Okay, see, to approach this question, let's come here. Okay, what is zt? Zt is xt convolution ht, or I can also write it as xt convolution ht. This is, sorry, they have given what? Xt and yt data. Xt convolution yt. It is xt convolution yt. Okay, or let me swap then write this as yt convolution with xt. Let this be yt convolution with the xt. Okay, now what is yt convolution xt? Okay, the convolution formula is the integral formula in continuous time domain. It is given by y tau x of t minus tau. Okay, integral y tau xt minus tau. Integral is also equal to area. We have got some answer by Akbar, right? Integral is also equal to area. That means the zt is equal to area under, this is also known as graphical convolution formula, area under y tau x of t minus tau. Area under y tau x of t minus tau. Now see, what is y tau? Already yt is given. I'll just name it as and call it as y tau and calling this axis as tau axis. So this is y tau, but I need to create xt minus tau. Listen to me. Now this is, listen to me very carefully. Okay, let me first call it as tau axis now, converting to tau function. What is this waveform given? This is waveform of x tau. Okay, but don't you think this waveform is symmetric? Please pay attention here. Okay, identical to the left and right. Left also 1, right also 1, and then stop. Okay, for 1 unit of time. Okay, so because this waveform is even symmetric, correct, this is even symmetric, so x minus tau will be same only. X minus tau or x tau is same. So this is x minus tau waveform. This waveform is x minus tau waveform. I can say na. Sai Vikas also given the answer 4. Okay, I can say this is x minus tau. Okay. Now, if this is x minus tau, I want xt minus tau. Okay, so what is xt minus tau? That is the point we have to pick up here. Okay, the function are now tau function. So when you are thinking to plot x of t minus tau, break it this way, call it this way, x of minus common tau minus t. X of minus common tau minus t it is. X of minus common tau minus t. Okay, tau minus t. Okay, x of minus common tau minus t. Right. Now, if this is x of minus tau minus of tau minus t, that means shifted by t. You just have to shift this given waveform by t. Okay, if it started from minus 1 to 1, okay, shifting by t, that means this becomes t plus 1. And shifting this by t, minus 1 plus t, or I can call it as t minus 1. Amplitude same. Only we have to shift it by t units of time. So this becomes t plus t here and plus t here. So t minus 1 to t plus 1. This is the waveform now. Okay, then the concept is area under the product of these two. Okay, the point is this particular waveform, okay, and this particular waveform, they may not be always overlapping, na? They may not be always overlapping. See, first condition, we don't have to solve the convolution fully, but listen to me. Okay, when t plus 1 is less than 1, t can take any value, t is the time variable. Okay, see, first condition, if t plus 1 is less than the 0, sorry, is less than the 1, okay, that means if this particular rectangle ends before the other signal starts, then the answer is 0. Okay, then the answer is 0. They are not going to be multiplied. Y tau xt minus tau itself will be 0. Okay, so area under them will also be 0. Okay, then similarly, this rectangle starts at t minus 1. What about t minus 1 is here? What about t minus 1 is after 5? If t minus 1 is after 5, then again they are non-overlapping. Wherever this is present, this is absent. Wherever this is present, the other one already 0. Any one 0, answer will be 0, na? Any one signal 0, answer will be 0. So the next case is, if t minus 1 is greater than 5, then also, okay, the product of the signals y tau xt minus tau will be 0. And if the product is 0, any area under the signal will also be 0. Okay. The question is, see, even this is not required. The question is not asking the complete convolution. Question is asking, okay, the value of the convolution will be maximum at what time? Okay, and the convolution here is the area under y tau xt minus. Now, you think where the maximum area can come. Okay, this rectangle is of duration 2. Minus t minus 1 to t plus 1, duration is still 2. Okay, when this particular triangle, okay, see, what is the first case I told you, t minus 1 to t plus 1 is here. Okay, then this is slightly moving. Okay, the last case I told you, it completely moves outside. Okay, so there will be a zone where it comes inside. Okay, but here it will give negative area. Okay, this is value 1. Oh. Yeah, sorry. Where is that? So this much has the value 1, but the other one is negative. This will give the negative area. Okay. Now there will come a time it may totally overlap here, 2 units, but total negative area. There will come the next time where it totally overlaps here. Okay. When it totally overlaps here, it will give you the complete positive, maximum positive area, because it may partially also overlap. Okay. There may be a condition it is partially overlapping, some negative area and some positive area cancel out. Okay, so maximum area or automatically maximum positive area will come when, okay, redrawing this, when, okay, this is t minus 1, t plus 1, full overlap with this positive cycle. This also duration 2, this also duration 2. Okay, so maximum area is coming if, where is t minus 1? T minus 1 equal to 3 and t plus 1 becomes 5. I mean, in both the case, you get t equal to 4. That will give the maximum area, and maximum area means maximum value of zt. Okay, so maximum value of zt will come at t equal to 4. The question told the maximum will come at t equal to t1. What is the value of t1? Is 4. Any doubt, please tell me. Maximum automatically here means maximum positive area. Okay, solved by a graphical visualization approach. There is, okay, not much formula. I've just written the convolution formula, but it is all about observing the given graph. Okay, tell me if there is any doubt. Good question it is. Good question. Tell me if there is any doubt. By the time I'll move to the next question. See here, gate 25 2-mark question. Solve this next question now. The gate 25 2-mark question here. Let there be a continuous time signals x1t and x2t, which are mentioned here. Okay, consider the convolution x1t convolution x2t, then what is integral yt dt? Integral minus infinite to infinite yt dt. Gate 25 2-mark question. Okay, yt is the convolution of x1 and x2. So what is the property? What is the integral yt? Integral yt means area of yt, convolution property. I already told you what is area of yt is product of the areas of x1 and x2, whatever the signals you are convoluting. x1t convolution x2t, x1t convolution with x2t. Okay, but x1t and x2t are actually given in functional form. You have to see what can be the area. See, we can simply draw. Now, what is x1t? Let me draw here. I will start with x1t. Okay, what is x1t? See that, read the definition clearly. It is constant 1 for t equal to 0 to 1, for t belonging to 0 to 1. It is constant. Then t belonging to 1 to 2, it is a line 2 minus t. Okay, a line 2 minus t. If you put t equal to 1, 2 minus 1 equal to 1. So you start from here. Then there is a line of negative slope. Negative slope means you can just draw a decreasing line. This is the line 2 minus t, which gives a trapezium. You can find the area of the first signal. Okay, what is, and then 0. Only this much is there, otherwise 0. Then what about the second signal? Let me actually draw both. Okay, x2t. Okay, what is going to be x2t now? For t equal to 0 to 1, x2t is t. Okay, just a straight line passing through region, y equal to x relation. At t equal to 1, x2 also becomes 1. Then for t equal to 2, again 2 minus t, similar line like before, a similar decreasing line. This is x2t. This is x2t. Now what else? Okay, what is the area of x1t and what is the area of x2t? What is the area of x1t? Trapezium area. Trapezium area is half into sum of parallel sides. This is 1 and this is 2. These are the two parallel sides. This is 2 unit, this is 1 unit. Half into sum of parallel side into distance between the parallel side is 1 unit. Okay, multiplied by, or you can break it into a square and a triangle, anything you can do here. Okay, what about the next one? Okay, it's a simple triangle only. We can directly use the formula as half into base into height. Base is 2 units, height is 1 unit. Okay, so that means first one has the area 3 by 2, next one has the area 1. So final answer is 3 by 2 only, or that is 1.5. Option number A. Option number A. Option number A is the very correct answer. Correct. Now see dear, this was GATE 2025 2 marks question, current year. Okay, electrical engineering. Okay, I'll give you now the next homework. GATE 2023, this was in EC. See, that is why for common subjects, I always tell you solve the PYQs of at least ECEE both branches. If possible, solve for IN. For common subjects, solve the PYQ. See, because whether you are, suppose electrical student and you solved and you have written GATE 25 exam, but if you have solved GATE 2023 EC paper, okay, common subject at least, you know that earlier question also, similar question, data is changed. At least, see, data will not be same. Okay, but at least the approach will be very clear to you. What is this question? X1t is given to you. Now, difference between 2 unit step signals, rectangle. X2 is shown to you. Okay, for yt is equal to x1t convolution x2t integral yt dt. Same question, na? Same question, na? Okay. Well, area of yt is area of this into area of x1t. Same question only. It is almost data different, but concept wise it is the same question. And this becomes, because it is same question, Homework number 4. You solve separately and don't write answer right now. Write down the answer in the comment box. Let's other also solve. Don't write down the answer now. Solve it and write down the answer. Okay, after the video gets over in the comment box. Okay. Write down the answer for homework number 4. That's why I've been numbering. For as of now, this is the homework number 4 for today. Homework 4 of today. Correct. Homework 4 of today. Homework number 4 of today. Chalo. Now, as I told you, first I'll be going after this discussion. Let me give you an update. Okay, that the next marathon, okay, which is going to be conducted tomorrow at 11 a.m. Okay, this is specifically for electrical engineering, and that is the marathon, as you can see, electrical machines. Okay, electrical machines by Surendra Reddy sir, tomorrow at 11 a.m. Mark the time, tomorrow it will be live at 11 a.m. Okay, that is the mega marathon for electrical machines. Okay, mega marathon for electrical machines. Okay, tomorrow at 11 a.m. And then already I told you, tomorrow is what? 27th. Tomorrow is what? 27th. Okay, then I already told you, next 28th of January, the next marathon will be analog circuits by Gautam sir. Okay, the next 2 marathons I have updated to you. Next will be analog circuits by Gautam sir. Okay, chalo, next question now. So as I told you, after some convolution questions, I will also move on towards CTFT, CTFS. First I will take CTFT and then I'll go to CTFS. Okay, then I'll go to CTFS, and with CTFS, as I told you, I will also link DTFS and cover both of them. Okay, so yeah, Fourier transform, first of all. Okay, the Fourier transform of the function xt, again not deriving but just starting with the formula and property revision, and practice is important in Fourier transform. Okay, so what is the basic Fourier transform definition? Xt having the Fourier transform x omega, we also represent it this way, the signal xt having the Fourier transform x omega, we represent it by double-sided arrow, meaning xt has the Fourier transform x omega, or x omega has the inverse Fourier transform xt. They are said to be Fourier transform pair, or you may also see such type of double-sided arrows. Okay, right, such type of double-sided, it will come, just wait. I have just updated you next 2 things. Okay, many subjects are going to come in the marathon. Okay, so just you have to wait for some more time. Okay, it will be daily only. After analog also probably you will have power system. So like that, okay, a sequence is coming up based on the faculty bandwidth, but continuous almost daily marathon will be there. Okay, almost daily marathon will be there. Okay, chalo, this is what it is. So basic definition of Fourier transform is integral minus infinite to infinite xt e power minus j omega t dt, or the inverse Fourier transform, where we derive xt from x omega. Xt is 1 upon 2 pi integral x omega e power j omega t d omega. Right. Before I begin, first of all itself, you should know the condition, the Dirichlet's condition. See, even in gate 25 in EC, there was a simple 1 mark question, okay, which was directly connected with the convergence of the Fourier transform condition. So you should not ignore it. Okay, anyways, I've always been teaching this convergence of Fourier transform. Okay, the signal xt will have the Fourier transform, okay, if it is absolutely integrable. This is the first and the important condition. Okay, next 2 are just to define that the signal should be a well-defined function. It should have a finite number of maxima minima and finite number of discontinuities, any finite interval. That means it should be a well, okay, defined function. Okay, so you just have to focus on the first part. Xt should be absolutely integrable. What is the meaning of absolute integration? That the integration of absolute value of xt, absolute means magnitude, mod xt. Okay, integral mod xt dt must be finite. Less than infinite means must be finite. Must be finite. Yes, nice, just wait. Okay, the xt is absolutely integrable. That is, integral mod xt dt must be a finite number. Okay, integral mod xt dt must be a finite number, right? Okay, now what are the properties and important Fourier transform formula? I'll revise them and then immediately we'll go to the question. Okay, so what are the different properties that you have to remember here? Okay, see, linearity. If 2 signals are added or subtracted, Fourier transform will also be added or subtracted. Okay, simple. Time shifting corresponds to phase shift in the frequency domain. Now see what is there in the time shift, x of t minus t naught. This x of t minus t naught will have the Fourier transform e power minus j omega t naught into x omega. Now how the things will change here? See, the important point you should note is, okay, that generally any x omega which can be a complex function, okay, x omega which is the Fourier transform is also broken into modulus x omega e power j angle x omega, where this is known as the magnitude spectrum of the signal. The Fourier spectrum can be broken into magnitude spectrum and e power j theta, where theta means angle x omega. We define it as the phase spectrum. Okay, we define it as what? We define it as the phase spectrum. Now what I am defining here, you see clearly what I am defining here. When you do the time shifting xt minus t naught, the Fourier transform is e power minus j omega t naught into x omega. Now if I take this separately and break it into magnitude and phase, see, it is x omega. Now what is x omega? X omega, as I told you, can be broken as modulus of x omega e power j angle x omega multiplied by only e power minus j omega t naught. That is a phase term. It has a unit magnitude. E power j theta always has unit magnitude. So only a phase term is multiplied. So if you simplify modulus x omega e power j, when you combine them, when you combine this exponential, you will get what? E power j angle x omega minus omega t naught. Angle x omega minus omega t naught. Okay. So that means the magnitude remains same. There is a phase shift. Okay, there is a linear term, there is a linear phase shift. The net phase, the net angle now becomes angle of x omega minus omega t naught. So time shift corresponds to phase shift in the frequency domain. Some points theoretically and conceptually also you should remember. Time shift corresponds to phase shift in the frequency domain. Okay, the Fourier spectrum is phase shifted by omega t naught. Got this? Okay, then time scaling xat 1 by mod a x of omega by a. Now what is the significance of this property? Questions also are very important, but just some basic significance also. Xat, suppose if you have taken x2t, so if you take x2t, what will happen here? 1 upon 2 x of omega by 2. Now x2t, 2t in time domain means compression by 2, but here it is omega by 2. Here the scaling factor is 1 by 2 and 1 by 2 less than 1 means expansion. So if it is compression in time, it is expansion in frequency domain, or vice versa. Okay, compression in time, expansion in frequency. Expansion in time, compression in frequency. Okay, then x minus t, x minus omega, folding in time will represent folding in frequency. Okay, next calculation. Okay, duality property. Okay, now duality, again I'll take questions onto it separately. This is a very important property which talks about transform of transform. See, I'll explain the duality property like this separately. See, if xt has the Fourier transform x omega, okay, which is the frequency function, but suppose again you convert it to a time function and it becomes capital xt, and for any time function we can talk about frequency representation if it is absolutely integrable, right, if it satisfies the Dirichlet condition. Okay, so that means now I am calculating the transform of this particular transform. I convert omega to t function and this turns out to be 2 pi small x minus omega. That means take the original time function and replace t as minus omega. That is what is written here. This is duality. We'll understand more by questions. Okay, conjugation, x conjugate t will have the Fourier transform x conjugate minus omega. Now this is not directly important, but this is important for symmetry properties. Okay, that I'm going to show you anyways. Derivative, d by dt of xt, Fourier transform j omega x omega. So if you differentiate n times, j omega power n x omega. Integral property, integral minus infinite to t x tau d tau. The Fourier transform will be x omega by j omega plus pi x0 del omega. Okay, what is x0? Okay, the value x0 here simply means the value of the Fourier transform at zero frequency. Okay, the zero frequency value also has an importance. I'll discuss this in the upcoming property. Now frequency differentiation. Slightly shift this. Okay, frequency differentiation. Okay, frequency differentiation also known as t times property. Okay, t times property, where I talk about the Fourier transform of t into xt. The Fourier transform for t into xt will be j d by d omega of x omega, derivative in the frequency domain. Okay, multiplication of t in the time domain, t xt j d by d omega of x omega. Okay, next property to be noted is frequency shift. Oh, like I told you, time shift brought a exponential or a phase term in frequency domain. Okay, similarly, a frequency shift brings a exponential or a phase term in the time domain. So, frequency shift means phase shift in the time domain, but please note that opposite sign. If it is x omega minus omega naught, it is e power plus j omega naught t. In the time shift, it was with same sign. In frequency shift, okay, this is because of duality, this opposite sign. Okay. Convolution in time, multiplication in frequency. x1t convolution x2t, Fourier transform is x1 omega into x2 omega multiplied. Multiplication in time is convolution in frequency domain. x1t into x2t, Fourier transform is given by 1 upon 2 pi x1 omega convolution x2 omega. Okay. Modulation, when any signal multiplied by cos omega naught t. Okay, so the Fourier transform is given by x omega plus omega naught plus x omega minus omega naught divided by 2. The spectrum is shifted to higher frequencies centered at plus minus omega naught. Okay, now that was the list of important properties. Now important symmetry results. Okay, for Fourier transform alone this is important, and such symmetry results are applicable. Okay, you see this here, you will see this in the DTFT, you will see this in the DFT as well. So all these properties are similar at most of the places. So if a signal is complex, Fourier transform is generally complex. If a signal is real, okay, Fourier transform can still be complex, but following a special symmetry, conjugate symmetry. Okay, what I told you with this property, I told you, na, conjugation property which is not numerically important. Okay, which is not numerically important, this one, the conjugation property, but it is important for symmetry point of view. Why? Because if a signal is real, okay, if a signal is real, what is the meaning of real signal? That it will be unaffected by the conjugation operation. Okay, this is what is a real signal. Okay, which is unaffected by the conjugation. Conjugate, you know, if I give you a real value 2, what is the conjugate it is to? Conjugation affects the imaginary part, na? Okay, so if the signal is real, x conjugate t is xt, but if these two are equal, their Fourier transform will also be equal. Xt Fourier transform x omega, but what is x conjugate t Fourier transform? Copy from here, it is x conjugate of minus omega, or I will write down x minus omega, conjugation on the right side, x conjugate omega. And here, whenever there is a relation between left and right, whenever there is a relation between positive and negative side, that is symmetry. What type of symmetry it is? Okay, the value of left and right are related by a conjugate operation, so we call it as conjugate symmetry. Okay, we simply call it as conjugate symmetry. So that is what I have listed here separately. The Fourier transform will be conjugate symmetric. What is this conjugate symmetry? What is this conjugate symmetry? Writing down again here, x minus omega is equal to x conjugate omega. And not only this, when a signal is real, 2 to 3 points important. The Fourier transform is conjugate symmetric. Okay, and then when you break it into magnitude and phase, the magnitude part will be even symmetric. The magnitude spectrum of a even signal is always even symmetric, of a real signal is always even symmetric, and phase spectrum, angle x minus omega, will be minus of angle x omega, that means odd symmetry. Magnitude spectrum is even symmetric, the phase spectrum is odd symmetric. The magnitude is even symmetric, the phase is odd symmetric. Magnitude is even, phase is odd. So when a signal is real, 3 points to be noted. Its Fourier transform conjugate symmetric, its magnitude spectrum even symmetric, its phase spectrum odd symmetric. Okay, next. If a signal is even, Fourier transform is even. If a signal is odd, Fourier transform is odd. Okay, right. Then, if a signal is real and even, Fourier transform will also be real and even. If a signal is real and odd, Fourier transform is pure imaginary and odd. Okay, by duality, if a signal is conjugate symmetric, the Fourier transform will be real. Okay, Fourier transform will be real. Okay, real signal, Fourier transform conjugate symmetric. If a signal is conjugate symmetric, the Fourier transform will be real. Okay, duality property. Okay, so this is important symmetry property. Then area under the curves. Okay, next 2-3 more properties. Area under the curve. Okay, what is going to be the area under the curve? Now see, we have the Fourier transform formula, integral xt e power minus j omega t. Just put down the zero frequency. You get integral e power 0 1. So you only get integral xt dt. What is that integral xt dt? Area of xt. So if there is a signal whose area in time domain can be calculated, it can be calculated by Fourier transform by putting the omega equal to 0. Capital X0 is area of xt. And then there have been some nice questions, not directly asking area, but nice questions on this property in GATE. Okay, then xt 1 upon 2 pi integral x omega e power j omega t d omega. Here where you put 2 equal to 0, e power 0 will be 1, and you can write down integral x omega d omega. Okay, into 1 upon 2 pi as x0, and integral x omega d omega means area of x omega. Okay, so what is area of x omega? 2 pi. If you want, you can shift the 2 pi here, 2 pi times x0. So this is area property. Okay. Next, Parseval's theorem. Okay, for an energy signal, the energy formula we have seen. Okay, the energy formula we have seen. Okay, this Parseval's theorem is mostly for real signals. So you can also write down the energy as integral x square t dt. Okay, this is for the energy discussion in time domain we have done in the morning only. Okay, we have done in the morning only. Okay, integral x square t dt, and that is equal to 1 upon 2 pi integral modulus x omega whole square d omega. Modulus x omega whole square d omega. We'll take up the questions on this. Parseval's is also important. 1 upon 2 pi integral mod x omega whole square d omega. For a power signal, okay, the power which was written as 1 upon t integral over one time period. Okay, one time period can be taken as minus t by 2 to t by 2 or 0 to anything. Okay, for a power and a periodic signal. For power and periodic signal. Okay, and this power is also equal to summation mod ck square, where ck are the Fourier series coefficient. I told you Fourier series, I intentionally started with Fourier transform first, and then I'll go to the Fourier series. So the ck are nothing but exponential Fourier series coefficients. These are the exponential Fourier series coefficients. Okay, exponential Fourier series coefficient. This is Parseval's theorem, mostly energy signal Parseval's theorem. This can produce direct questions for you. Okay, now some important signals whose Fourier transform must be known to you. Okay, must be known to you directly. Thanks for the respect, Rakesh, but yeah, it's nothing like God or something, but I'll just try to give my best so that you learn and perform in the exam. Okay, so some important signals whose transform must be definitely known to you directly, because questions will not directly ask you these transform, but questions will be some of this transform plus linked with the property. So we'll see the variety of question. Look into this unit impulse signal. Okay, unit impulse signal Fourier transform is 1. Okay, for 1 the Fourier transform 2 pi del omega. This is what duality is. Okay, this is what duality is. That's what I told you, na. Okay, if A has the Fourier transform B, B will have the Fourier transform like A. If impulse has the Fourier transform which is constant, constant has the Fourier transform which contains impulse. Okay, just 2 pi because of that scaling property. Okay, otherwise the nature of the signal is impulse. Okay, then e power minus at ut, this will have the Fourier transform 1 upon a plus j omega. A should be positive, or you can remember this way, it should be bounded exponential. Otherwise Dirichlet's condition will fail. Why it is required? Otherwise Dirichlet's condition will fail. The bounded exponential, that means A must be positive. Then only the formula is 1 upon a plus j omega. Otherwise, you know, see, it is like this. If I ask you e power minus 2t ut Fourier transform, okay, you can write down 1 upon 2 plus j omega, correct. But if the question was suppose e power 3t ut, and if you blindly write down the Fourier transform, what is A? You can compare with the formula. A is minus 3. And if you blindly write down the Fourier transform 1 upon a plus j omega, 1 upon minus 3 plus j omega, this is absolutely wrong. You have to be careful. So it has to be bounded exponential. Okay. So 1 upon a plus j omega, but a must be positive. Okay. Then look into the next one, t e power minus at ut. Okay. This is derived by t times property. The Fourier transform is 1 upon a plus j omega whole square. Here a also must be positive. Okay. E power minus a mod t, two-sided bounded exponential signal. Okay, two-sided bounded exponential signal. Okay, already we covered this in the energy discussion. This is right-sided bounded exponential. E power minus at right side. This is two-sided bounded exponential. Right side e power minus at. Left side e power plus at. The Fourier transform of this is given by 2a upon a square plus omega square, right? 2a upon a square plus omega square. A positive means bounded exponential signal has to be there. Okay, for unit step signal derived using integral property, the Fourier transform is 1 upon j omega plus pi del omega. For the signum function, okay, the Fourier transform is 2 by j omega. For e power j omega naught t, the Fourier transform is 2 pi del omega minus omega naught. For cos omega naught t, sinusoids, again important, the Fourier transform is, shift this slide above, yeah. So for cos omega naught t, it is given by pi del omega minus omega naught plus del omega plus omega naught, containing only impulses, that too at the fundamental frequency of the signal. So these are the sinusoids, which contains the Fourier transform only at the omega naught or minus omega naught fundamental frequency. Sinusoids are, that is why known as single tone frequency component signal. They only contain a single frequency, and what is that single frequency? The fundamental frequency of the signal. For sin omega naught t, it is turned out to be pi by j del omega minus omega naught minus del omega plus omega naught. Okay, few more, rect t by t. Now I will be specific here. Whenever I use this word now, rect of t by t, you will draw a rectangle. I will define it because these are going to be repeatedly used. Whenever I use rect of t by t, okay, rect of t by t, it is going to be a rectangle of total width t. Rectangle of total width t. Okay, located from minus of t by 2 to plus of t by 2. Minus t by 2 to plus t by 2. Total width t. Okay. Then whenever I use this notation, try t by t. Whenever I use the notation pi t by t, you will draw a triangle but having the width 2t. You will draw a triangle but having the width of 2t. That is located from minus t to plus t, and triangle total width is 2t. Symmetric triangle centered at 0, height 1, rectangle also amplitude 1 I have written. So rect t by t, the width is t. Okay. Rect t by t, the width is t. Okay. Try t by t, the width is 2t. Okay, right, okay, right, the total width is 2t. So for rect t by t, okay, for rect t by t, right, how to handle center shift, as in, can you specify the doubt a little bit more clearly, code bits? Okay, center shift means, what I understand is, you may be asking like this: if I give you rect of t minus 1 by 2, what will you then do is draw a rectangle of width 2 but center at 1, because the center is 0, so whatever t minus t naught, do the center shifting by that much of amount. Clear, code bits? Yeah, so this is what it is. Okay, the width of the triangle and rectangle to be taken care, right? Okay. So what is the Fourier transform? Now rect t by t has the Fourier transform t sampling omega t by 2, where again some important points about sampling also you must know. Okay, so what is this sampling theta function? I'll generally explain in the form of sampling theta. Okay, sampling theta is the function defined as sin theta divided by theta, or in some places you may find the formulas in the form of sinc function. What is sinc theta? Sinc theta is a function defined as sin pi theta divided by pi theta. Okay, they are related simply. Okay, what is sinc theta? What is sinc theta? So if sampling theta is sin theta by theta, so sin pi theta by pi theta will become sampling pi theta. So they are related only. So this is sampling pi theta. Okay, now as I told you, what is sampling theta is sin theta by theta. Okay, important points to note is, what is sampling 0? Okay, what is going to be sampling 0? It is sin 0 by 0, and we solve by limits, it is equal to 1. Okay, it is equal to 1. Then the function is going to be even symmetric. Why? Because if you place minus theta, sin minus theta upon minus theta, minus minus will come from both the side, it will cancel. Okay, it will cancel. Okay, the next is, this is sampling 0, this is even symmetric function. Next, okay, sampling theta equal to 0, where it will be 0? Okay, whenever sin theta equal to 0 excluding origin. Okay, so that means theta equal to pi or minus pi, then similarly plus minus 2 pi plus minus 3 pi. These are known as the null points. So sampling theta. Then how the sampling waveform looks like? How does the sampling theta waveform looks like? Okay, it is maximum at origin, and thereafter it is just decreasing in nature, and it is an even symmetric waveform, as I told you. It has to be an even symmetric waveform. This is how a sampling waveform will look like. The value at theta 0 will be 1. This is sampling 0, and then these are the null points where the sampling theta is 0 at theta equal to pi, 2 pi, 3 pi, and etc. and etc. Okay, right? Okay. So for rectangle, the Fourier rect t by t Fourier transform given by t sampling omega t by 2, even in several gate PYQs, Even in several gate PYQs, you will find this, at least this particular pair, very useful. Rect t by t, t sampling omega t by 2. For tri t by t, t sampling square omega t. For sampling, rect has the Fourier transform sampling, sampling will have the Fourier transform rect. The nature is at least known to you. Triangle has the Fourier transform sampling square. So sampling square Fourier transform should be a triangular signal. Okay. Then by duality, when we calculate the exact term, sampling AT Fourier transform pi by a rect omega by 2a. For sampling square AT turns out to be pi by a triangle omega by 2a. Last one, the Gaussian signal, e power minus AT square. The Fourier transform is given by root over pi by a e power minus omega square by 4a. Okay, e power minus t square, e power minus omega square. Similar function. The Fourier transform of Gaussian is again Gaussian. But yeah, but for it to be valid Gaussian puns, a must be positive. Okay, right. So root pi by e power minus omega square by 4a. Now these are some of the formulas. Okay, yeah. Sometimes they may directly come up in the exam as 1 mark question. But if not directly, at least some of this formula mixed with some property. This is how normally they make a 2 mark question in the Fourier transform. Now I'll keep showing how the questions will look like. Okay, first question directly a gate PYQ, direct one. Tell me. Okay, tell me. This is a direct one. Okay, Gaussian pulse. Okay, directly Gaussian pulse. This is of the form e power minus AT square. Fourier transform, I just told at the last only, root pi by a e power minus omega square by 4a. So what is going to be this Fourier transform x omega? What is the a value? 1. Okay, so answer will be root pi by a is 1, e power minus omega square by 4. Okay, root pi e power minus omega square by 4. Tick mark answer number C. Move ahead to the next question. So sometimes it may be direct formula also. Be ready. Okay, 1 mark question it is. Yes, I Vikas correct answer. Okay, next question. Okay, MSQ question. Tell me this answer. Which of the below Fourier transform pairs are correct? Okay, which of them are correct? Now see, some of them are directly, like how I made this question. Some are direct and some you have to think. Okay, some you have to think. Cos omega 1t. Already I told you cos omega naught t pi delta omega minus omega naught plus delta omega plus omega naught. So at least C is correct. Unit step also you know, 1 upon j omega plus pi del omega. Okay, so this is also correct. These two are not in the standard table doesn't mean that they are not correct. Okay, you have to say whether they are correct or not. C and D are correct. Okay, what about A and B? Just figure out these two. Just figure out these two. Yeah, C and D to for sure correct. A and B you have to figure out. A and B you have to figure out. Yeah, second one, if you know Hilbert, then you know that second one is wrong. Second one is wrong if you know Hilbert transform. See why? Because see, so you know, you may be electrical student also not really focused on Hilbert. If you're EC, you directly will be knowing Hilbert. But okay, I'll tell you. See, I'll start from the signum T formula. Okay, what is the Fourier transform of signum T? That I already told you as a standard formula, 2 by j omega. Okay, start here. Now apply the duality, and what do we do in duality? Convert the omega to t function. So it becomes 2 upon jt, and every time function, okay, may have a frequency representation that I am trying to figure out by the help of duality property, and this will be equal to 2 pi signum of, okay, what we do? We take the time function, original time function, and replace t by minus omega, 2 pi signum minus omega. Okay, now what is the signum waveform, by the way? Okay, what is that you know about signum waveform? Okay, the signum waveform is a waveform which takes the value 1 on the right side, which takes the value minus 1 on the left side, plus 1 here, minus 1 here, simple. Okay, plus 1 and minus 1 on the right and left. Okay, so that means it is odd symmetric function, right and left, they have same magnitude but opposite sign, they differ in sign. Okay, so it is odd symmetric signal. So odd symmetric signals, we can write down signum minus omega as minus signum omega. That is what is the definition of odd symmetric function. So this is minus 2 pi signum omega. Okay, so option number B is talking about 1 upon pi t. Okay, see, 2 and 2 you cancel, pi you bring it here, j you shift on the right side. Simple, na? Pi you bring here, j you shift on the right side, 2 and 2 cancel. Okay, then what is the answer? Okay, minus j signum omega. 1 upon pi t Fourier transform is minus j signum omega. Okay, minus j. It is plus j signum omega, so this is wrong. this part is wrong. Okay, it had to be minus j signum omega. And this is what is the concept of Hilbert transformer as well, not required right now. In communication and all it is required. Okay, 1 upon pi t is the impulse response of Hilbert transformer. Okay, now what about A option? How do you say A option may be right or wrong? B is wrong. Okay, now see here, how do I come to the conclusion on A? What is there? I have just now written 1 upon pi t, okay, which has the Fourier transform minus j signum omega. Okay, now A option has, see, pi term is common, 1 upon t minus 1 by t square. Can you relate? Can you relate A and B? Can you relate A and B? Right? Okay, can I relate t and minus 1 by t, minus 1 by t and minus 1 by t square? Yes, just by differentiating. Okay, differentiate this with respect to time, d by dt. 1 upon t derivative, already you get minus 1 by t square. So this is minus 1 by pi t square, minus 1 by pi t square. And what is the derivative property? J omega x omega, j omega into minus j signum omega. Okay, right. Now minus of j square will become plus 1. So it is omega square signum omega. Correct? Sorry, not omega square, only omega signum omega. Okay. Now omega signum omega. Now what is this value? It is omega into 1. Okay, signum omega is 1 for omega greater than 0, but for omega less than 0, what is the signum value? Left side signum value is minus 1. Okay, so what is the final answer? It is equal to omega, okay, whenever omega is greater than 0. It is minus omega for omega less than 0. Is it not the definition of modulus function or not? Is it not the modulus function or not? Modulus of omega. Yes, correct, na? Whenever omega negative, place minus omega. Whenever omega positive, mod omega is omega. So A option is correct only, dear. This is a good question. A option is especially a good one. So A is correct only. A is correct. B is wrong. ACD, 3 answers correct here. ACD, 3 answers correct. Govind Rao in DTFS, CK is equal to CK plus minus Mn. Yes, any integral multiple of n, correct. No divide by t property in Fourier transform, that is there in Laplace transform, Ananya. Be careful. Right. Okay. John, autocorrelation and spectral density, they form Fourier transform pair, and that is a separate topic. That is why I have not listed any autocorrelation property here. We are first talking about basic Fourier transform and its properties. Okay. Next. This is ACD. Done. So the A1 was something that you have to think. Others were mostly easy. C and D were direct result actually. So that is how I framed a MSQ question, but overall a good question. Okay. Next one, MSQ question only. Tell me the correct answer. Symmetry based question. A symmetry based question. What is given? Choose the correct statement regarding the CTFT of the two functions f1t and f2t shown in the figure. f1t and f2t are shown in the figure. I will come to that question, what you are referring now, Govind Rao. When I come to DTFS, I will take that question. Get electrical. But it was not 2023. You are referring to some other question. Okay, don't worry. But yeah, whatever some questions about electrical DTFS, now I will discuss. Just wait for that. Yeah, tell me. Now see, what is the properties of the two function f1t, right and left identical. f1t is even. Okay. So if a function is even and as well as real, there is no j, there is no complex plane, it's a real time function only. Okay, so this is real and even. Okay, so the Fourier transform is also real and even. Fourier transform of f1 is real and even. Now f2 is again real. Both the signals are real only. There is no j plane, there is no complex plane here. But left and right, okay, they differ in sign. If it goes to +1, this goes to -1. Then constant 1, this is constant -1. This is odd symmetry. Symmetry in the first and third quadrant. Okay, if a signal is real and odd, the Fourier transform is pure imaginary and odd. Okay, so that means the Fourier transform of f2t is imaginary and odd, A and D. Okay, A and D, 2 answers correct. I told you symmetry properties, direct questions, they have come up, they may also come up later. Okay, A and D, 2 answers correct here. Okay, next question. Yeah, Let xt has the Fourier transform x omega, this be the Fourier transform pair, then what is the Fourier spectrum of the differentiated signal? Okay, Fourier spectrum of the differentiated signal. See, xt has the Fourier transform x omega, which can be broken into magnitude and phase, na? Mod x omega e power j angle x omega, that's what I explained you. Now differentiated signal is suppose yt. Suppose yt is given by the d by dt of xt. Suppose yt is the d by dt of xt. Then what about y omega? J omega x omega. J omega x omega. Okay, the derivative property. Now what is the magnitude spectrum? Okay, mod of this part will be omega, or overall modulus of omega x omega. And what is the angle x omega? Angle x omega. Okay, the omega may be real, but j will bring a 90 degree angle plus angle x omega. So this will be angle of x omega plus pi by 2. Okay, plus pi by 2 because of the j term. Okay, so magnitude spectrum is scaled by, it is in f domain. So magnitude spectrum is scaled, is multiplied by omega, means 2 pi f. So A answer is correct. Okay, this omega is 2 pi f. Okay, in the frequency domain you can write this as modulus of 2 pi f, and it was xf if the question was in f. So this is correct. Okay, and phase spectrum is added by 90 degree. See, it's added by 90 degree plus j, na, to plus 90 degree. So A and C. Question on direct property, but how the terms are arranged, what calculations you have to do, that you have to be aware. A and C, two answers are correct here for this MSQ question. Okay, so you might have noticed multiple MSQ questions I have taken today. Some simple, some good. Okay, next one, GATE 22 1 mark question. Tell me the Fourier transform of t upon 1 plus t square whole square. T upon 1 plus t square whole square. You have to think. T upon 1 plus t square whole square. See here. T upon 1 plus t square whole square. I'll give you the hint. The starting point could be, start with e power minus a mod t, which had the Fourier transform 2a upon a square plus omega square. So that at least you have a omega square term. Okay, but the question is in t square. So then you can apply duality. Okay, you can apply duality. Okay. Right? Tell me. 2a upon a square plus omega square. Okay. Now, here it is 1 plus t square. So if you want to make it as 1 plus omega square, first choose a equal to 1, e power minus mod t. Okay, if you choose it as 1, you get 2 upon 1 plus omega square. Okay. Now, there are two properties that has to be mixed in the question. One is duality and one is differentiation also. Okay, one is differentiation also. Okay, so if I first apply duality, converting omega to t, okay, I'll get 2 upon 1 plus t square. 2 upon 1 plus t square. Okay, this will have the Fourier transform 2 pi, okay, this function, replace t by minus omega, e power minus mod minus omega, but modulus of minus 1 is 1 only, na? So you can write this as 2 pi e power minus mod omega only. Modulus minus omega is same as modulus omega. Okay, so what I have done till now, I'll write down the result here. What I have done till now is 2 upon 1 plus t square. This has the Fourier transform 2 pi e power minus mod omega, right? 2 pi e power minus mod omega. But then I want 1 plus t square whole square. Okay, 1 upon x to 1 upon x square, like one of the previous question, differentiation. Okay, time derivative will also come. I told you duality and differentiation. Now, if you differentiate this, then first of all, 1 upon x minus 1 by x square. So, minus 2 upon 1 plus t square whole square. Then by chain rule, when you differentiate the denominator, you will get 2t. T square derivative 2t. And this will have the Fourier transform. Time derivative corresponds to j omega multiplication. J omega 2 pi e power minus mod omega. Now, in the question, you only want t upon 1 plus t square on the left side. T upon 1 plus t square whole square. Okay, so what else is there? This is minus 4, you divide on the right side. Anyways, 1, 2 will get cancelled. Okay, so minus j pi omega minus j pi omega and divide by 2 e power minus mod omega. Now go and match your answer. Go and match your answer. Okay. Minus is not coming. Acha, that they have shifted the j in the denominator. That I can also do here. Okay. So what is 1 upon j minus j, or 1 upon j is minus j. So minus j I am writing 1 by j. So then it becomes pi upon 2j omega e power minus mod omega. Pi by 2j omega e power minus mod omega. Answer is A. A mix of properties. Yes. A answer correct. Some of you have given it. A answer is the correct one. Right. Next question. Okay. Yeah. This was 1 mark question. Moving ahead to the next question. Yeah. A continuous time signal xt has the Fourier transform x omega equal to j omega upon 1 plus j omega. Then find the Fourier transform for e power minus t, e power minus jt x of t minus 1. Okay. See, again a mix of property. If xt has the Fourier transform x omega, if xt has the Fourier transform of x omega, then what about x of t minus 1? First of all, time shifting and frequency shifting, two properties. xt minus 1, time shifting, frequency shifting, exponential term in the phase domain, x omega e power minus j omega. Now comes e power minus jt x of t minus 1. Okay, so now exponential term in the time domain is frequency shift. But in frequency shift, I told you be careful opposite sign. If it is minus jt here omega plus 1. Now every omega on the right, not only x omega, x of omega plus 1 e power minus j omega plus 1, that has to be your answer. Where x omega is already given to you, just convert to x omega plus 1. So you have your answer as j omega plus 1 upon 1 plus j times omega plus 1 e power minus j omega plus 1. Okay, so correct answer is e power minus j omega plus 1, correct na? Yeah, option number B. Option number B. Yes, correct, and I ready. B answer, very correct here. Okay, B answer. Okay, next question. Okay. Yeah, now see here. Okay, how do you take up this particular question? How do you take up this particular question? See, what is there in this question? A line has been given, but not a complete line, a line only from minus 1 to 1. Okay, now this is a line passing through origin. Okay, and what is the slope of this line? The slope of this line is height upon base. Height of this much is 1. Base of this portion is also 1. The slope is 1. Now, if the slope is 1, what is the definition of this line? The definition of this line can be written as how much? Okay, mx plus c, mt plus c. Okay. Trying to write down the equation of this part. So what is the equation of this part? Is mt plus c. Okay, slope is 1 into t plus y-intercept. It is passing from origin, the y-intercept is 0. So that means it is t. Okay, so what is the signal yt shown to you? Okay, the signal yt shown to you, I'll come up here. The signal yt that is given to you is t, but not complete t. T, it is only for the given time, that is minus 1 to 1. Only for the given time minus 1 to 1. Now remember, now this is a good question where I want to teach you a point. Where whenever you want to restrict a function, like the function is t, a linear function, but only from minus 1 to 1. Whenever you want to restrict a function only from minus 1 to 1, okay, only between 2 points, you can use a rectangular window. You can use a rectangular window, right? What do I mean by rectangular window? This function can be written like this: t into 1 minus 1 less than equal to t less than equal to 1. And if I for a moment remove this, suppose this is not there, then what is this? A signal which is constant from minus 1 to 1. A constant signal means rectangular. Okay, constant means rectangular, right? Okay, so this much part, if you draw alone, it is a constant 1. Okay, from minus 1 to 1. Okay, and what is this? This is a rectangle. Now, a rectangle centered at origin. I have given a standard definition of rectangle to you just few moments ago. Okay, what is the rectangle definition? Rect of t by width. How much is the width here? 2 units. Okay, so this is rect of t by 2. This is rect of t by 2. Okay, so yt is t rect of t by 2 multiplied by t. Okay, now I already know the Fourier transform of rectangle, na? I already know the Fourier transform of rectangle. What is that Fourier transform of rectangle? See, what is the formula we have used? Rect of t by t, Fourier transform, t sampling omega t by 2. T sampling omega t by 2. T sampling omega t by 2. Okay, that is the Fourier transform of rectangle. Okay, so what is the Fourier transform for rect of t by 2? Our question has capital T equal to 2. So put down capital T 2, 2 sampling. 2 and 2 will get cancelled, only 2 sampling omega. Okay, and 2 sampling omega can also be written as sine omega by omega, 2 sine omega by omega. Okay, now the question is the Fourier transform for rect of t by 2. The question is not directly given like this, but the waveform we have converted to this way. So which property? Tell me which property? T times property. Whenever you multiply a signal by t, it is the t times property. Okay, and what is the t times property, dear? What is the t times property? Okay, j d by d omega. T times means frequency differentiation property. J d by d omega of the above transform. Okay, which is 2 sine omega by omega. Okay, now just differentiate and close your answer. This is j. 2 also I will write down outside. 2 is a constant. 2j, now numerator by denominator differentiation. Denominator square, then omega constant, differentiation of sine is cos, minus sine constant, numerator constant, differentiation of omega will be 1. Okay, so this is how much? This is going to be 2j omega cos omega minus sine omega divided by omega square. 2j omega cos omega minus sine omega divided by omega square, right? Right? This is what is the answer. Okay, options are also given, I think. Yeah. So 2j, yeah, we can split that actually. How much it was? 2j omega cos omega. So 1 omega will cancel. Cos omega by omega minus sine omega by omega square. Okay, cos omega by omega, sine omega by omega square. Answer is B. You can mark the answer as B answer. Okay. You can mark the answer as B answer. Yeah, some answers came up as B. Correct. Next question. Let's keep practicing more and more on Fourier transform. Okay. Yeah, a GATE 24 2-mark question. Some recent, property based question also I am covering here. Okay, consider two continuous time signals xt and yt shown below. If xf denotes the Fourier transform of xt, then what is the Fourier transform of yt? Okay, so options are asking you to relate the Fourier transform of yt in terms of Fourier transform of xt. But this question, first you have to relate the waveform of xt and yt. Can you do that? First you have to relate the waveform of xt and yt. Please do that. Come on, guys. 2-mark question it is. Okay. Yeah, let's do it. So what is the relation between two waveforms? Now, first of all, you see what is the width here? The width here is 1 unit. What is the width here? 4 units. That is the first point to identify. The width here is 1 unit. The width here is 4 units. That means 1 becomes 4. Expansion has to be there. Okay, expansion. But not only expansion. If you only expand by 4 units, it should be 0 to minus 4. But the center also is now at origin. Okay, so that means time shifting is also there. Time shifting is also there. Okay, so if I don't expand, suppose if I don't expand, then the width will be how much? If you divide by 4, if you divide by 4, it will become, see, if this is means expanded is there, expanded is there, okay. If I draw the unexpanded waveform, if it was not expanded, then, okay, that means divide the coordinates by 4 units. So minus 2 by 4, that is minus half, and this is plus half. Okay. Now can you compare to the original signal? Okay, the original signal is minus 1 to 0, and this is minus half to half. That means you can right shift by half. Okay. What is the original signal? Xt. Okay, right shifting by half, x of t minus half. When you right shift by half, this goes to half, and minus 1 plus half will be minus half. Okay, at the same time, original signal goes to the amplitude minus 1. This is plus 1. I mean just amplitude reversal means minus of x. Amplitude reversal minus of x. Okay, this is unexpanded. Now when you expand, okay, now if you have to expand by 4, if you have to expand this signal by 4, okay, you have to bring what? You have to bring t by 4. Expansion means a greater than a less than 1. So x of t by 4 minus half. Okay, this is the correct relation between the given signals. Okay, I'll write down the relation here once again. Okay, what is the yt? Yt can be written as minus of x t by 4 minus of 1 by 2. Shifting was by half unit, correct? Okay, now xt has the Fourier transform x omega. Okay, or xf, just keep a habit of solving the formulas and property in one parameter, omega or f. If you have habit in omega, do it in omega. At the last step, omega is 2 pi f, that you can put. Okay, so xt has the Fourier transform x omega. What about x of t minus half? Okay, time shifting, x omega, e power minus j omega by 2. Time shifting, na? E power minus j omega by 2. Okay, then I will carefully first shifting, and then I will apply the scaling. X of t by 4. Tell me, x of t by 4. Okay, so what is xt by 4? What is xat property? See, if you only write down xat property, time scaling, what was the property? 1 by modulus a, x of omega by a. X of omega by a. Okay, so here it will be 1 upon modulus of a. What is a here? 1 by 4. So 1 upon 1 by 4. Okay, x of omega by 4. But here the above Fourier transform is not only x omega e power minus j omega 2. Every omega replaced by omega by a. That you have to be careful. Right? Don't only do here. Here also you have to do e power minus j omega replaced by how much? Omega by 1 by 4. And I'll separate this half, e power minus j 1 by 2 into omega upon 1 by 4. Okay. Right, and then I have to place a minus here. So minus of xt by 4 minus half. What is this Fourier transform? Okay, minus on the left, minus on the right. 1 upon 1 by 4 is 4. X of omega by 1 by 4, 4 omega, e power minus j how much? 1, 2 cancel, and this 2 going up, e power minus j 2 omega. Converting it into f domain. In the f domain, minus 4 x of 4f e power minus j 2 omega. Now what is 2? Omega is 2 pi f, 2 omega will be 4 pi f. In the functional form, we don't necessarily convert here. Okay, x of 2 pi f or x of f. X finally is a function of f. Okay, so we leave it this way, minus x of 4f e power minus j 4 pi f. Minus 4x of 4f e power minus j 4 pi f. Option number A. See, option number A. It is not B. It is not B. A. I think probably you might have done the mistake I was telling you. Okay, that it is not only x omega by a. This is the above Fourier transform, and in the above Fourier transform, you have to replace omega by a. Okay, so correct answer has to be actually A here. Correct answer is actually A here. Okay. All right, next question. What is there? Okay. Let x omega be the Fourier transform of the signal e power minus of t power 4 cos t. Gate 24 EE1 mark. Easy question. Okay. But easy means good. It's not, you have to think. What is the value of the derivative of x omega at omega equal to 0? What is the value of derivative of x omega at omega equal to 0? Yes, correct. A correct answer. Derivative of x omega at omega equal to 0. We have to think. Okay. See, let the derivative of x omega, suppose, let the derivative of x omega be y omega, first of all. So what we need the value of y0. Okay, we need the value of y0. But what is y0? Okay, what is y0? The value of any Fourier transform at zero frequency, area property. What is y0? Y0 means area property, area of the yt signal, area of the yt signal, or integral yt dt. So we have to figure out about integral yt dt. But what is yt? What is yt? Derivative of omega, derivative of x omega, frequency differentiation, that comes in the t times property actually. That comes in the t times property. See what I have told you, xt, if it has the Fourier transform x omega, then txt, this has the Fourier transform j d by d omega, j d by d omega of x omega, j d by d omega of x omega, correct? J d by d omega of x omega, correct? So I want only d by d of omega of x omega. Divide the j on the other side. 1 upon j is minus j. So I can write this as minus jt into xt, minus jt into xt. This will have how much Fourier transform? D by d omega of x omega. Okay. So now if this is y omega, okay, on the right side this becomes yt. This becomes your yt. So what is the yt signal, dear? Yt signal is minus jt xt. Yt signal is the minus jt xt, correct? Minus jt xt, right? Where xt is given to you, where xt is given to you, e power minus of t power 4, I'll write down this, minus jt xt, xt is e power minus of t power 4 into cos t. The question was, coming back to the question, the question was capital Y0, and as I told you, that is area under yt or integral yt dt. Okay, now what is this integral equal to? Looks like a complex function, na? Okay, complex question, integral minus jt e power minus of t power 4 cos t, and it should not be a much complex question for 1 mark at least. Integral minus jt e power minus of t power 4 cos t dt. Some answers have started coming up. See here, important point to be noted is, okay, t power 4, okay, is an even term. Cos t is also an even function. Cos minus theta is cos theta. Minus of t power 4 is t power 4. So both of these are even, but t power 1 is directly odd. Okay, so odd, even into even is an even function, but odd into even will be an odd function. And integral minus a to a for any odd function, whatever minus a to a, integral minus a to a, whether it is minus infinite to infinite also, integral minus a to 8 for odd function is always 0. So your net answer is 0. It is actually more of the basic integration sense. Of course, Fourier transform properties are required, but without the proper integration sense, you can't give a full stop to this question. Okay, that is anyways expected. Basic integration techniques, that anyways has to be expected from you. Correct? Okay. Now, some more actual, important and good questions that can turn up here. Now, look into this. Look into this. Consider, MSQ question it is, consider an LTI system whose magnitude and phase response are separately given to you. Magnitude response modulus h omega, this is modulus, and phase response angle h omega is given to you. Okay. Both of the response are given from -2 to 2. Okay. The input to the system is 3 plus 2 cos 2t plus 3 sin 3t. Which of the following is or are correct? Okay. What is the output of the system? Okay. What is the power of the output signal? What is the impulse response of the system is real? What is, now see, C and D. Let me first talk about C and D. Let me first here talk about C and D. Just a second. Okay, let me first talk about C and D actually. Okay. Let me first talk about the C and D. See guys, what is this? The magnitude response of a system is even symmetric. Okay, and the phase response, okay, left and right Okay, they are equal in magnitude but opposite sign. This goes to pi, this goes to minus pi. It is odd symmetric. Now, magnitude response even symmetric and phase response odd symmetric, okay, happens when the impulse response is real. I told you, okay, these two conclude that a combination of these two concludes that impulse response of the system, suppose ht, will be real. Okay, and so that the Fourier transform of it, also known as frequency response of the system, will be conjugate symmetric, right? This is in the symmetry property already I discussed with you. Okay, so impulse response of the system is real, the frequency response is conjugate anti-symmetric. No, conjugate symmetric only. So D wrong. Okay, so now C correct. Now A and B. How do you calculate the output of the system due to sinusoid input? Okay, due to sinusoid input. Okay, due to sinusoid input. Now here I'll first cover up that point. Suppose, okay, I'll first write down the point here. Suppose if the xt, okay, if the input to the system is any sinusoid a sine omega t, or it could be a cos omega t as well, doesn't matter. Okay, what is the output of the system? The steady state response to sinusoid, it is given by, okay, or I will, show it in the picture format only. This is applied to a system S whose frequency response is h omega. Okay, where h omega, you should break it into magnitude and phase spectrum, and that is given in the question separately only, e power j angle x omega. The output of the system is given by a times modulus of h omega naught. Okay, let's say this frequency is omega naught, the frequency of the applied sinusoid. Okay, the output is given by the amplitude of the input multiplied by the amplitude of the system at omega naught into cos of I will better write down the output here. The amplitude of the input multiplied by the magnitude of the system at omega naught. And then the phase part. What is the phase of the input? Omega naught t plus angle of h. Okay, the phase of the system at the omega naught. Will be added here. Okay, this is the general formula. Wow, it disturbs. Okay, this is the general way. Okay, now this is with respect to sinusoid. Okay, this is with respect to sinusoid. Now, if the input to the system is, next case, if the input to the system is just constant and the frequency response of the system is given, okay, again I'll assume the same thing, the frequency response of the system given as h omega, where h omega is broken as modulus of h omega e power j angle h omega. This is usually solved as, okay, the eigensignal way. Okay, this is usually solved as eigensignal way. Okay, so what is there? Let me give you the general formula only. Suppose if the input was actually a e power j omega naught t. Okay, where e power j omega naught is the eigensignal. So output is given by simply the frequency response a, the input a, amplitude a multiplied directly by the frequency response at omega naught a, h of omega naught e power j omega naught t. Simple. Okay, so if the input xt is simply taken as a, that means if you take omega naught 0 here, then the output of the system will be given by a into h of 0. That's it. A h of 0. Okay, omega naught equal to 0. Correct? A h of 0. So now coming back to the question, what is the input given? Input, the first term is a constant here, 3, then plus 2 cos 2t, 3 plus 2 cos of 2t plus, see, the good question, such question can be definitely a 2 marker question, and then 3 sin 3t. Okay, there are 2 sinusoids part and one is the constant, the DC part. Okay, but for the DC part, as I told you, output is given by a into h0, right? A into h0, correct? A into h0, but what is h0? Okay, the magnitude is 0. Okay, so h0 will be 0. Okay, magnitude is 0, then phase is not required. Na? Okay, now come to 3. Okay, for sinusoid, what is the output? Okay, for sinusoid, the output is given by Where is that gone? It is given by A into modulus of h omega naught. That means the magnitude response of the system will come at the applied sinusoid frequency. At the applied sinusoid frequency, what is the sinusoid frequency? 3. And what is the modulus of h omega naught? So at omega naught, which is equal to 3, magnitude response is again 0. Magnitude response is only non-zero up to 2. It will only pass the frequency up to 2. So this is 0. Okay, so output will also be 0. Now coming here. Here, this is omega naught equal to 2. At omega naught equal to 2, what is this? This is the magnitude, the maximum magnitude. Modulus of h omega naught is 10. Clearly, this is shown. See, the question can give you any other frequency also. I made it simple. The question can also give you frequency 1. So, where you have to find this magnitude. If by the equation of line, that also can be done. Okay. What is the phase angle of h omega naught at omega naught equal to 2? So, at omega naught equal to 2, how much is the phase? Minus pi. Okay, it is minus pi. So, what is the only output to the system? What is the only output of the system? The output will be, the first and third part will vanish away. Okay, it will be given by the magnitude of the input multiplied by magnitude of system, and phase to phase added. Here phase 2t added with minus pi. Okay, so the net answer is 20 cos of 2t minus pi. One of the option is also talking about power. Okay, but for power of output, ultimately it's a sinusoid one. Okay, so what is the power of the output? Okay, the power of the y signal, amplitude square, sinusoid power a square by 2. Okay, so 20 square by 2, that will be 200. Okay, so output is given by 20 cos 2t minus pi, correct expression. The power output is 200, correct. A, B, C, 3 answers are correct. 3 answers are correct here. Three answers are correct here. Okay, dear. Next question. Next answer. Okay, so let's take the next question. Now this was this can also be a filter question where it is blocking the low frequencies. I mean, low frequencies are passed with less gain and it is passing some frequencies towards 2 with higher gain. Okay, now I will take the question. A gate question here, easier than this. A gate 2 mark question here, which when you draw this impulse response, you will understand that this is nothing but a low pass, ideal low pass filter. A continuous time signal, again sinusoids are given. Okay, it is input to a LTI filter. When this is input applied as input to a LTI filter, whose impulse response is given. Okay, whose impulse response is given. Now sine 300 pi t upon pi t, like appearance of sine theta by theta, but only thing is you have to make here also 300. Okay, so you can write down, divide and multiply by 300, 2 into 300 sine 300 pi t. Okay, then I will multiply 300 in the denominator also. Denominator becomes 300 pi t. So what is this? This impulse response actually becomes 2 into 300, that is 600. Okay, sine theta by theta is sampling theta. Okay, sampling how much theta? 300 pi t. Sampling 300 pi t. Okay. Okay, now already we know what is the sampling 0 value. Already we know, I told you separately, what is the sampling 0 value? 1. So anyways, at t equal to 0, the answer has to be 600. They have separately given but not required. Okay, but now dear, what is the impulse? Impulse response is the sampling function. Okay, so what you have to recall, sampling Fourier transform pair. Okay, sampling Fourier transform pair. What is the sampling Fourier transform? Sampling Fourier transform is actually given by the formula pi by a. In the table I already discussed this, pi by a rect of omega by 2a, correct? Pi by a rect of omega by 2a, that is what I already discussed. Okay, pi by a rect of omega by 2a, right? Okay, so now here the impulse response is how much? It is given by 600. So 600 sampling 300 pi t. Okay, sampling 300 pi t. Okay, so what is going to be the frequency? This is the impulse response. Okay, what is the frequency response of the system? H omega. The frequency response, if you apply the formula, okay, pi by a. Okay, what is a here? 300 by pi by a rect of omega by 2a. Rect of omega by 2a means rect of omega by 600 pi. Okay, so pi cancel, 600 by 300 is 2. Okay, so the frequency response is 2 rect of omega by 600 pi. 2 rect of omega by 600 pi. Okay, now how will you draw this rectangle? Okay, it is a rectangle. As I told you, whenever rectangle you see the denominator, that represents the total width, the total base of the rectangle. So total width of the rectangle has to be 600 pi. 600 pi, and we draw it symmetrically. That is from minus 300 up to some plus 300. Okay, but entirely it is constant, having the height of 2, and that is why I told you this is an ideal filter. Constant gain filter. It is an ideal low pass filter because it passes all the low frequencies up to 3 pi and then it blocks the frequency. So this is the cutoff frequency. This is the cutoff frequency. This diagram is what is the ideal low pass filter. Ideal low pass filter, right? The ideal low pass filter. Okay. So see, you can also, now first let me complete the question and then I'll write down the important points. What is the xt here? See, what is the xt here? Okay, 4. Now there are two frequency components given here. 4 cos 200 pi t. Okay, the first one is 4 cos of 200 pi t. And the next one is 8 cos 400 pi t. 8 cos of 400 pi t, correct? This is the first, this is the second. Okay, now this particular frequency omega 200 pi, is it less than omega c? Yes. Okay, so it is going to be passed with the gain 2. The gain will be multiplied here. But see the second frequency component, this has omega 400 pi, which is greater than omega c. What happens at 400 pi? What happens at 400 pi? The gain of the system is 0. So that means if the gain of the system is 0, output is input gain into a system gain. Okay, answer will be 0. Okay, this is like, we call it as blocked frequency, and this gain will be a passed frequency. This is in the passed band. Okay, if it is passed with how much gain? Okay, 2. So what is going to be the output? I'll write down the output here only. 2 times the first component. 2 times the first component plus there is no second component. The answer is 8 cos 200 pi t. If they ask the expression, it is 8 cos 200 pi t. They ask the maximum value. So cos theta maximum value 1. Here answer will be 8. Maximum value of modulus yt, answer will be 8. Answer will be 8. That also you can do. I'll tell you that Maxwell. See now, important points. The important message from the question. This was easy, but what are the important message from the question? Basic things about ideal low pass filter. If you want to remember, because lot many questions in competitive exams, especially in GATE, you can find about ideal low pass filter, especially based related around Fourier transform. If you want to have an ideal low pass filter with cutoff frequency omega c and gain equal to 1, I will tell for gain equal to 1, then any gain you can multiply later. Okay. Okay, what is the frequency response? The frequency response, because it is ideal, means constant gain, and I am taking the gain 1, rect of omega by 2 omega c. Rect of omega by 2 omega c. Okay, ideal low pass filter. This has to be the frequency response. Okay. Okay. Minus omega c to plus omega c, constant 1. So total width is 2 omega c. Okay, this is frequency response. Then what about the impulse response? Okay, so impulse response you can write down in terms of sampling as well. See, like previously what I first got, it was 600. 600 is what? 2 into 300. Here the gain is not 2, here the gain is 1. So we also write it this way. We write it as omega c divided by pi sampling omega ct. Okay, omega c divided by pi sampling omega ct, or the impulse response. In books you may also form it in the form of sin theta by theta. So when you write down sin omega ct by omega ct, sin theta by theta, so omega c will get cancelled. You will have it in the form of sin omega ct divided by pi t. Sin omega ct by pi t. Right? If you remember this better, because see, like that there can be any other filter, but this is a very commonly discussed data in the exam. That's why I'm asking you to remember this basic configuration about the ideal low pass filter, can directly save your time. Okay, now let me tell you, I'll give you this question, very easy. GATE 2025 double E, it's very easy question for 2 marks, and this is your homework number 6. I think we are on numbering 6. Okay, see, the ideal low pass filter, okay, frequency response constant up to 200 pi. Okay, let HD be the time domain representation. What is the value of H0? What is the value of H0? Okay, what is the value of H0? This is homework number 6. Within 10 seconds you can solve it, but let this be a homework. Okay, because you can directly write down the answer, na? Sin omega ct by pi t, or omega c by pi sampling omega ct. Anything you can do. Anything you can do. Or H0 you can find by the area property. Anything you apply and get your answer. This is homework 6. Okay. Now GATE 22 2 marks. Again a better question. Okay. 5th or 6th? I remember it as 6th. Okay. I think 5th I have given. If not given, this will be 5th. No problem. Whatever I am writing on the board, you mention in the comment box by that number only, because I am also continuously taking the session from long, so numbers I can forget. Okay, whatever it is, you mention it by homework 6 only. Whatever it is. Okay. Whatever number I have put here, let this be HW6, because I think some 5th I have given, but not given means no problem. You forget. This question, when you comment by the answer of HW6. By the HW6. Okay. Next one. Let an input, again sinusoidal inputs are given, 4 different sinusoids are given. 1, 2, 3, 4. It is passed through a LTI system having the impulse response to sin 10 pi t by pi t. Now see again, sin omega ct by pi t. If I see, forget this part. If you only think about this one, this is again an ideal low pass filter. Ideal low pass filter. Okay. What is the output of the system? Okay. Then multiplied by 2 means gain of the filter becomes 2. Okay. Then multiplied by cos omega naught t. Multiplying any particular signal by cos omega naught t. Okay. Modulation. The spectrum is shifted to higher frequencies. The spectrum is shifted to higher frequencies. Okay. So first, if I only talk about 2 sin 10 pi t by pi t. See. If I only talk about 2 sin 10 pi t upon pi t, if I only talk about this one, what is going to be the spectrum of this ideal low pass filter? Ideal low pass filter, how much cutoff frequency? Omega ct, omega c is 10 pi. Okay, this one will be ideal low pass filter, cutoff frequency 10 pi. That means magnitude spectrum or the frequency spectrum will be minus 10 pi to plus 10 pi, and gain 2, gain equal to 2, gain equal to 2, right? Okay, but when any particular signal is multiplied by cos omega naught t, what is that modulation? What was the modulation property? See, I'll write down that modulation property here separately. As a quick review, if xt has the Fourier transform x omega, xt multiplied by cos omega naught t, the spectrum is shifted x omega minus omega naught plus x omega plus omega naught, and also amplitude whole divide by 2. Okay, so if I just use this and then write down that the given impulse response ht is twice of this 2 sin 10 pi t divided by pi t, further whole multiplied by cos of omega naught t, and how much is the cos term multiplied? Cos 40 pi t. Cos 40 pi t. What will be the spectrum? I'll directly draw. Okay, I'll directly draw. So this has the spectrum h omega that I am going to draw. So to draw this, what I have to do? Okay, I have to shift the above spectrum. Okay, I have to shift the above spectrum by the frequency 40 pi. Right shift and left shift both, and amplitude divide by 2. That means if the gain of the above filter was 2, divide by 2, it will now be 1. Okay, it will now be 1. Okay, but the center which was 0, right shift by 40 pi. Right shift by 40 pi. Okay, right side 10, left side 10. So this will be 50 pi and this will be 30 pi. And also left shift by 40 pi. This is centered minus 40 pi. This side minus 30 pi. And this side again 10 units minus 50 pi. Now this gain will be 1. Okay, this gain is 1 because amplitude divide by 2, original 2 divide by 2. Okay. Now the given input. What is the given input? 2 sin 10 pi t. So there are different components, but some of them are outside. So what is this type of filter now? What is the type of filter if you have to name it? This is again an ideal filter because of constant gain, but ideal band pass filter. It is not a low pass. Okay, without the cos, it was an ideal low pass filter. Okay, this one is definitely ideal low pass filter, gain 2. Okay, but the resultant filter is an ideal band pass filter which passes a band of frequency, neither low nor very high, a band of frequency from 30 pi to 50 pi. It is an ideal band pass filter. It is an ideal band pass filter. Okay, now I will write down the input versus output here. Okay, what is xt? I'll just copy the input. What is that xt? 2 sine 10 pi t plus 5 cos 15 pi t plus 5 cos 15 pi t plus 7 sine 42 pi t plus another component, okay, 4 cos 45 pi t, cos 45 pi t. These are the different components given. Okay, now see here. Okay, this is the frequency 10 pi and 15 pi, but the frequency that will be passed is only from 30 to 50. Okay, so 10 pi and 15 pi, both of them, what will happen? Rejection will happen. These are rejected. Okay, 42, and whatever frequency passed, it is passed with gain 1. Okay, 42 and 45, both are in this range. Okay, both these frequencies are going to be passed with how much gain? Gain 1. Okay, passed with gain 1. So what is the output? Okay, so what is the only output? The last two terms, because gain is 1, so no change in the gain. The last two term, 7 sine 42 pi t plus 4 cos 45 pi t. Last two terms are passed. Option number C. Option number C. Yeah, some of you already given the answer. C. Such questions you have to handle, at least from Fourier transform, rather than the property questions I have already done, but these are like, you can call it as good question. Now dear, one more question, little better than this. This was GATE 2022 electrical 2 marks question. This was GATE 2022 EE 2 marks question. A GATE 2023 EC 2 mark question, where again a sinusoid input is given. Okay, and again modulation will come because a particular function is going to be multiplied by cos omega naught t, but here the input is not sin omega ct by omega t, sin omega c is omega ct by pi t whole square. Okay, sampling square function which has the Fourier transform triangle, not rectangle. Okay, so this one is your homework number 7. Okay, this is a better question as compared to previous, but if you know to solve previous, you can attempt this because you know the Fourier transform of sampling and sampling square both. Everything you need to know to solve the question, everything you need to know to solve the question I have provided to you. Okay, that I have provided to you. So that is why this is a good question, and this is homework number 7. You mention your answer as homework number 7. Okay, right? HW7. Place your answer by the code HW7. Place it in the comment box later down the night when you are free. Okay. Now, let me come to the CTFS. Okay, let me come to the Fourier series discussions for some time, the continuous time Fourier series. Okay. Okay, the CTFS, the continuous time Fourier series representation of the continuous time periodic signals. Of course, the Fourier series is for periodic signals. Okay, in the Fourier series, we represent a signal. Okay, starting with the exponential Fourier series, we call this as exponential Fourier series EFS, where we break a signal into different exponential terms, e power. Okay, so there are some typo error. Just forget this typo error here. I will rewrite this. Okay, xt given by summation k equal to minus infinite to infinite ck e power j k omega naught t. What was missing here is the k omega naught t. Okay, where we break the signal into different exponential signals, okay, corresponding to the frequency multiple of omega naught, multiple of the fundamental frequency of the signal. Okay, omega naught is the fundamental frequency of the signal, which is related by the time period, of course, 2 pi by d. So we can write on the other form as well. Okay, and ck, Fourier series coefficients, these are known as the exponential Fourier series coefficients given by the formula 1 upon t integral for one time period xt e power minus jk omega naught t dt. 1 upon t integral for one time period xt e power minus jk omega naught t dt. Okay, this is the way to calculate ck, and there is another way to calculate ck, that is directly using Fourier transform knowledge. I will cover that also. Okay, using the Fourier transform values, you can calculate the Fourier series coefficient. Now see here. Okay, so what is that? I already told you, these set of coefficients ck, they are known as the CTFS, Fourier series coefficients, or the spectral coefficients. Okay, C0 is the DC term, okay, because C0 will come when you take k0. Okay, and when you take k0, you will get what? Okay, when you take k0, you will get the zero frequency term, because the different frequency terms are given by k omega naught. So zero frequency means the DC term. Okay, or the constant component. Okay, and in the previous formula of ck, when you put omega equal to 0, you get 1 by t integral xt dt for one time period. 1 upon t integral xt dt. Okay, integral of the signal for a time period t divided by the length of that interval is also average formula for continuous quantity. Okay, so the C0 mathematically is also the average value of xt over one period, or generally average value of xt, not necessarily over one period. Okay, it is generally known as the average value of the xt. Okay, so regarding to periodic waveform, average power, RMS value, average value I have left for this one only. The question sometimes can be given a periodic signal, they only want average value. Okay, how to calculate the average value, that will be covered within this topic. Average value is also equal to C0, or the DC value. Okay, the constant component of the Fourier series, 1 upon t integral over one time period of xt, or you can also call it as area under xt for one period. Area under xt for one period divided by the value of the time period. Okay, right. The terms corresponding to k equal to plus minus 1 will be the fundamental components, okay, or known as the first harmonic, normally known as fundamental terms. The terms corresponding to plus minus n, k plus minus n, that will have the frequency how much? The frequency is k omega naught, that means plus minus n omega naught. Okay, and the terms having the frequency integral multiple of the fundamental frequencies are known as the nth harmonic terms. They are known as the nth harmonic terms. Okay, they are known as the nth harmonic terms. Okay, now convergence of CTFS, more or less the similar Dirichlet's condition. The signal must be absolutely integrable, okay, over any one period. Okay, that is absolute integration. I already told you, integral of modulus xt dt must be finite. Okay, the signal must be absolutely integrable over any one period, and the same finite number of maxima minima and finite number of discontinuity, just to mention that the signal should have a well defined shape and a waveform given. Majorly what is important, the signal must be absolutely integrable over one period. This is the Dirichlet's condition you should take care. Okay. Then with respect to the continuous time Fourier series, the trigonometric form is actually very important. Okay, sometimes see from Fourier series, now Fourier transform, I'll differentiate here. Fourier transform, if you talk in terms of question, there are many questions around properties and applications numerically. Fourier series, if you see gate PYQ, the questions are more of conceptual, okay, nature, or symmetry based nature. Symmetry, where especially even symmetry, odd symmetry and half wave symmetry are very important. That I'll cover. But dear, before I take the trigonometric form of CTFS, okay, I just want you to correlate and study the topic, since it's a revision session and you want to cover up multiple things in the less amount of time. I'll first go and also correlate okay, the DTFS. Okay, then we'll solve the questions together. I'll come to some properties also, but see, this is what is the CTFS I just covered, na? Okay, okay. Yeah, it applies to other means Fourier transform. Okay, not the Laplace, but it applies to Fourier. Laplace it applies, but then we define more of a concept of ROC rather than applying the Dirichlet's condition. Okay, yeah. So CTFS review. What is that CTFS? We just discussed. The signal is broken as summation ck e power jk omega naught t. Okay, and the Ck is given by the formula 1 upon t integral xt e power minus jk omega naught t dt. Okay, now with the motivation of this, I am defining the DTFS, discrete time Fourier series as well. Okay, which is again, the Fourier series is anyways for periodic sequence. Now I will consider a discrete time periodic signal of fundamental frequency n, fundamental period n. Okay, the DTFS is given by, see this notation is similar, summation Ck e power jk omega naught n, but summation is only for one period 0 to n minus 1. I will tell you the reason for this. Okay, here we have done here we have done summation minus infinite to infinite, here only summation 0 to n minus 1 Ck e power jk omega naught. Limit logic I will explain, but the representation, the logic of Fourier series is one and the same, na? Okay, breaking the signal into exponentials. Now see, why do we do it, how the Fourier series form comes up, how Ck comes up, all this derivation is not required right now and I am not doing it. Okay, I am just writing down the forms and understanding the question model here. Okay, summation Ck e power jk omega naught n, where Ck will be given by the formula 1 upon n summation for one time period. Because it is discrete data, so you have to apply summation. In continuous data, see what was the Ck? 1 upon t integral for one time period xt e power minus jk omega naught t dt, correct? Okay, in the discrete domain 1 by n summation will come, summation for one time period 0 to n minus 1, okay, xn e power minus jk omega naught n. The Ck formula are similar, only thing is integral replaced by summation. Now while breaking a signal into different frequency components, why we only take e0 to n minus 1, why only one period? Why? Because I'll tell you a simple logic here. Okay, that see again the same things, the Ck are DTFS coefficients, the C naught is the DC or the constant term, which is also the average value of xn over one time period also, okay, or general average value of xn. Okay, 1 upon n summation xn, summation for one period divided by the time period. Okay, summation of one period divided by the time period. Okay, the signal has to be absolutely summable rather than integrable for the convergence of DTFS. Okay, what is important here is xn and Ck are actually both periodic with period n. See, I'll tell you later on, there is a relation that you will also explore. See, the Ck formula, specifically you see the Ck formula here. Okay, what is, I'll write down this separately. Ck is given by the formula 1 upon n, okay, summation of n equal to 0 to n minus 1 x of n multiplied by e power minus jk omega naught n. What is omega naught? 2 pi upon time period. What is omega naught? 2 pi upon time period. Okay, so 2 pi by n into n. Okay, for k being 0 to n minus 1, right? If you already know DFT, okay, otherwise later we will see that this whole summation is nothing but also the DFT formula. It is also the DFT formula. Okay, so Ck is related to the DFT as 1 upon n of xk. This is something important that you should note. Okay, 1 upon n xk, where xk is the DFT. That is a separate thing to be discussed, but if you know it, you write down, otherwise we will see later. Okay, what is this xk? It is known as the DFT of the discrete time signal xn. Okay, but before DFT, first I will definitely take DTFT, because DFT is what? A sampled version of DTFT. Okay, so the Ck are related to 1 by n of xk, and these DFTs are always periodic. X of k plus n is always equal to xk, and that makes the Fourier series coefficient also periodic, that we can individually also prove. Okay, x of k plus n equal to xk, and also that makes Ck plus n equal to Ck. Okay, so already, because we are talking about Fourier series is for periodic signal, so xn is a periodic signal. When I told xn is a periodic signal, that means the value of the signal xn will repeat after every fixed interval of time. And what is that minimum amount of time? Fundamental period n. So x of n equal to x of n plus n. Similarly, Ck is also equal to Ck plus n, and that is the point I was trying to mention here. And this is important for DTFS, that the Fourier series coefficients, okay, Fourier series coefficients are also periodic. Xn and xk, x of n plus n is equal to xn, and Ck plus n equal to Ck, okay, are periodic with the same period of n, Now let me tell you, this is unlike CTFS coefficients. Because in CTFS coefficient there is no periodic. CTFS coefficients are aperiodic. They can take any value, but the DTFS coefficients will always be periodic, and the values of Fourier series coefficients will repeat after n. That means all the frequency terms after n will be repetitive in nature, and that is why when we break the signal into different frequency components, we only consider the frequency for one period 0 to n minus 1, rest is just repetition. Okay, this is the basic highlight of DTFS. Okay, then I will show you whether you are EC or electrical. Okay, electrical students think that this is not the topic that they should study, they can skip, but I'll show you recently questions coming up, and many of the questions are just logical. See, psychologically, if you don't study a topic, you will not attempt the question also. If you skip DTFS and if you see a question talking about DTFS, you will mostly skip it. But I'll tell you how simple the question would be. But yeah, let me jump back to, that's why I'm relating the topic and studying and telling the differences as well. Okay, now if I go back to CTFS, I'll come to questions later. I'll show you very simple questions of DTFS that you can get for 2 marks, sometimes 1 mark, even 2 marks also simple question. Okay. Yeah, but before that, coming to the CTFS conclusion. Okay, so CTFS, so I already concluded with the basic formula and important terminology that you should know. Okay, but then for the continuous time domain, the trigonometric form is also important. Need not study the trigonometric form for discrete signals, you just forget it. Okay, just focus on the trigonometric form of the continuous time Fourier series, where we break the signal as xt equal to c naught plus summation k equal to 1 to infinity ak cos k omega naught t plus bk sin k omega naught t. AK cos k omega naught t plus bk sin k omega naught t. Okay, this is what is the summation. This is what is the trigonometric form, where c naught is the same. Okay, or in some of the books you may also find this representation this way. Okay, you may also find this equal to a naught by 2. They will start by this representation, a naught by 2. Writing down whole expression in terms of ak and bk only. Summation k equal to 1 to infinity ak cos k omega naught t plus bk sin k omega naught t. So in trigonometric Fourier series, we break a signal into, okay, we break the signal into what? We break the signal into a DC term and cosines and sines. Because of the cosines and sines only, we give this particular form as the trigonometric Fourier series form. Okay, what is the C naught formula? Is already known to you. Okay, now what is AK and BK? AK and BK are known as the trigonometric Fourier series coefficients corresponding to cosines and sines. Correct? Now, okay, have a look into this. What is the relation between trigonometric and exponential Fourier series coefficient? Okay, CK is actually given by half of AK minus JBK, or AK. Okay, AK is CK plus C minus K. Okay, final form you should remember. What is AK? It is given by CK plus C of minus K, and BK is given by the formula J times CK minus C minus K. Sometimes, you know, you may be using this, but not very important. Then already I told you what is CK formula. Okay, using the CK formula and solving these relations, we get the final AK and BK answer. Okay, what is AK and BK answer? AK will be 2 by t integral xt cos k omega naught t for one time period. BK will be given by the formula 2 by t integral xt sin k omega naught t for one time period. Okay, now coming to more important point. Okay. Okay, if a signal is even symmetric, okay, that is xt equal to x minus t. Okay, then applying the trigonometric property. What trigonometric property? Okay, one property I already told you earlier. See, whenever you solve integral minus a to a for any value of a for odd function, what I told you, we use this property in one of the Fourier transform question, 0. Okay, and then whenever it is integral minus a to a for an even symmetric function, okay, the result is given by twice integral 0 to a, okay, of that same function. Correct? Okay, so if a function is even symmetric function, what are the results based on the formula? I'm not deriving it, but this is easy result. Okay, actually BK will be 0. That means no sine terms. Okay, C naught, you know, 1 upon t integral over one time period. I should write this way actually, integral minus t by 2 to plus t by 2, integral minus of t by 2 to plus t by 2, integral over one time period. Integral minus a to a has been simply written as twice integral 0 to a. Similarly, AK formula has been converted to twice integral 0 to a. Okay. What is important is, I'll tell you, rather than this conclusion, I'll put it this way. If it is even symmetric signal, what is the trigonometric Fourier series? What is the trigonometric Fourier series? Let's be a simple, because conclusions are important. Let me apply a simple logic here. See, trigonometric Fourier series, where it has gone. Trigonometric Fourier series, I told you, contains three types of terms. Okay, DC, cosines and sines. DC, cosines and sine. Okay, you know that. So, let's write it in this format only. Trigonometric Fourier series generally contain three types of terms: DC, cosines and sines. Correct? Now, if a function is an even symmetric function or if a function is an odd symmetric function, see, put a simple logic that, okay, even function can only contain even terms. See, sine is an odd function, cosine is an even function. What about DC? How do you draw DC? If I ask you to plot C naught, okay, if I ask you to plot C naught, DC means constant for all values of time. Okay, that means left and right are same. And if left and right are same, you can call it as even function. Now, if a given function xt is even, the trigonometric Fourier series cannot contain odd terms. So, sines will not come, cosines can come, DC will come. But if a function is an odd function, it cannot contain any even terms. Now, odd will only contain odd. So, what is odd? Sine. It cannot contain cosines, it cannot contain DC. That is what has been just proved by calculation as well, by the integral property, that for even symmetric function, sine terms will not be there. That's what I told you. For even symmetric function, sine terms will not be there. So, how will I write down the trigonometric Fourier series then? Okay, the trigonometric Fourier series expression can only be written as C naught plus summation k equal to 1 to infinity ak cos k omega naught t. That's it. There is no need to write the bk sin k omega naught t term. Only this much. Okay. Now, if a function is an odd symmetric function, it will only contain odd terms. It will not contain DC. Okay, there is no DC or there is no cosine terms. That we can prove by integral calculation as well. So, what is the trigonometric Fourier series expression that is going to come up? Okay, for an odd symmetric signal, it will only contain sines, no DC, no cosines, no C naught also. Directly writing summation k equal to 1 to infinity bk sine, only the sine term, sine k omega naught t. So, if I simply ask you to write down the Fourier series representation for even and odd signal, that also you can do. Or many times in exam they have asked, the trigonometric Fourier series for even function will contain what, for odd function will contain what. Okay, so you can simply remember by this simple logic that I have drawn here. Okay, odd can only contain odd terms, even can only contain the even terms. Okay. This is what is the simple logic that you can put down here. Okay. Okay, properties of CTFS not really that important. I told you properties of CTFT very important and many questions are there in PYQ. CTFS, okay, but only thing is you should be aware about the properties. Okay, but if you talk about numerical questions coming up, very less important. Okay, xt and yt are suppose periodic signals with period t and the coefficient ck and dk. Okay, linearity, if signals are added, the coefficients are also added. Time shifting, same effect what I have told you in the Fourier transform. Phase term, exponential term, xt minus t naught. Fourier series coefficient Ck multiplied by e power minus jk omega t naught. Okay, frequency shifting, so shift in frequency Ck minus m. Okay, exponential term in the time domain, opposite sign. If it is minus m here, e power plus j m omega naught t. Okay, next one is conjugation. Okay, then the similar symmetry property I told you, if a signal is real, okay, Fourier series coefficient are conjugate symmetric. Okay, that is c minus k equal to ck star. If a signal is real and even, okay, Fourier series coefficients also real and even. Same thing was seen in CTFT. If a signal is real and odd, the coefficients are pure imaginary and odd. Okay, time reversal x minus t, Fourier series coefficient are c minus k. Okay, time reversal leads to c minus k, reversal in the Fourier series coefficient. Okay, time scaling, be careful here. Time scaling is the one property which does not change the Fourier series coefficient. For x80, the Fourier series coefficient will be ck. Okay, convolution in time, because periodic signal, so we talk about periodic or circular convolution. Multiplication with tau ck dk. Multiplication in time, convolution in ck, not important. Differentiation in time, okay, so again jk omega naught, like j omega, here omega is simply replaced by k omega naught. Simply you can remember by this. Okay, so in Fourier transform you saw j omega x omega, here it is jk omega naught ck. Okay, integral in time ck divided by jk omega naught. Only thing is, for this property k should not be 0, otherwise property not applicable. Okay, so that's what, not really that important, but just what is now more important, I'm coming here. Can you tell me any type of symmetry in this particular waveform? Just tell me any type of symmetry in this particular waveform. Whether this waveform is clearly visible to you, let me just check it here once. Okay, I think it is visible only. Any type of symmetry you see here? Acha, is it also odd symmetric? And I say odd symmetry also. Okay, let me make it clear. Number one, it is not odd symmetric. If it was odd symmetric, see, try to draw the mirror image. Left and right should only differ in sign. When you draw the mirror image, right, it goes this way. So when you draw the mirror image, left, it will go this way. Okay, and then if it was odd symmetric, this should be lying here. So when you take the negative amplitude, here it goes to plus a, so here it should have gone like this, minus a. Symmetry in first and third quadrant. Okay, it is not odd. It is not odd symmetry. Many of you are actually telling odd. It is not odd. It is not odd. Okay, odd means you see by value, if this is 0 to a, it should be here 0, and wherever it becomes a, it should have gone to minus a. Rather, it starts minus a and goes 0. No. Okay, if it is a, it should be minus a here, but here it is 0. No odd symmetry. Tell me, is that clear or not? Okay, so with respect to even or odd, it is known as nano. Neither even nor odd. Even though anyway is not there. Okay, it is not odd also. Okay, it is not odd. Okay, be careful about this. What is nano? Neither even nor odd. Okay, so some waveform may be neither even nor odd. Okay, this one is NENO. This one is that category, neither even nor odd. Okay, but what is the condition here? Okay, see, what I will do is, first let me draw the waveform and then explain you the conclusions. Okay. Suppose if the above waveform is ft, I will draw f of t minus t by 2. Now see here, okay, this is mentioned as t, so this becomes half of the time period, one positive cycle and one negative cycle. Okay, left side this is minus t, this is minus t by 2. So when you shift by what? Half a time period. Okay, right or left shift, anything is okay. Either you may right shift or you may do the left shift. Okay, ft minus t by 2. Either you can do the right shift or you can do the left shift. Right shift or left shift, anything okay. Oh, sorry. Okay. So when you right shift, suppose I start with the right shifting, okay, so the minus t by 2 where negative cycle is starting, okay, that will right shift to origin. Okay, so this is how negative cycle will happen. Okay, then the positive cycle which was starting at origin will start at t by 2. So this will go here. Okay, and then the positive cycle will start and that will go up to t. Okay, then again, then that is repetition. Negative cycle and then again positive cycle. This point is t by 2, this amplitude a, this is minus a. Okay, at minus t the positive cycle was starting, that will come to minus t by 2. Here it will be like this. Okay. Now you see the above and below waveform carefully. Now you should be seeing the above and below waveform, right? See, above waveform, you see this portion, okay, it goes 0 to A. Similarly, it goes 0 to minus A, exact sign reversal. Here, if you see the left side, it starts from 0 goes to minus A. It starts from 0 goes to plus A, only sign reversal. That means this waveform, ft minus 2, I can say it is just negative of the above waveform. Wherever it is positive, it becomes negative. Wherever it was negative, it has become positive. Okay. That is what is half wave symmetry. When you shift the waveform by half a period and it turns out to be minus of ft, that is what is half wave symmetry. Okay, this is what is half wave symmetry. Otherwise, purely the waveform is neither even nor odd, and this is known as a half wave symmetry. Correct? F of t minus t by 2 is minus ft. Okay, so now why half wave symmetry is important? The conclusions I will tell you. Okay, half wave symmetric signals. Okay, this satisfies the condition x of t plus minus t by 2 is minus xt, or minus we can write any place. Okay, so xt is minus of x t plus minus t by 2. Okay, now when we talk about the Fourier series expansion of half wave symmetric signals, all even harmonics of cosine or sine, everything, all even harmonics are absent. Okay, all even harmonics are absent. Only odd harmonics are present. Okay, only odd harmonics. So even harmonics present means, okay, even harmonic present means ck, see, I'll write down this way. Okay, ck equal to 0 for k equal to even. So k equal to even means 0 plus minus 2, 0 is also counted as even, plus minus 4, plus minus 6, etc. Okay. Ck will be non-zero only for odd harmonics. Okay, now Ck equal to 0 for k equal to 0. This means C0 is also 0. There is not going to be any DC component also. No DC term also. Okay, no DC term will also be there. Okay, a half wave symmetry can be further even or odd. I'll take another example where the half wave symmetry plus even or odd symmetry is there. But this signal is half wave symmetry but neither even nor odd. Okay, neither even nor odd. Okay, so what is important is the Fourier series coefficients. Okay, this is about exponential Fourier series coefficients. I can write down the result for trigonometric Fourier series coefficient also. As I told you, okay, even the AK and BK will be 0. Okay, for k equal to even. Okay, now k equal to even means anyways in trigonometry k starts from 1 to infinity. So positive 2, positive 4, positive 6, or any of them it will be 0. Okay, any of them it will be 0. C0 here also will be 0. So only odd harmonics are present. Okay, only odd harmonics are present. Again, this can be an important result for you. Okay, only odd harmonics are present, right? So now this was a signal having the half wave symmetry. F of t minus t by 2 is minus of ft. This is half wave symmetry. Okay, this is half wave symmetry, but neither even nor odd. Neither even nor odd. Okay. Now look into the next question. Look into the next question. This point is 10. This point is 5. Correct. This will be then 15. This is minus 5. This is minus 10. Correct. Yeah. For the signal shown below, find the fundamental period, DC component, type of symmetry, which terms are present, which harmonics are present, and etc. Okay, several questions, from basic questions only. Okay, which are all these basic questions are important only. Okay, yeah, so what is the, let's do it. What is the fundamental period? I have the waveform here, let me mark it here. From the first positive cycle to the next positive cycle, the time gap is t equal to how much? 0 to 10. This is the time period of the signal. Okay, now DC, before you start calculating DC, don't start calculating. See, I can calculate DC also. There can be some questions which are directly on DC. I'm going to take that. See, there is another question that I will discuss, which is only going to talk about the DC component. That is a separate question. Okay, forget, we will come to this question. Okay, but what I want to calculate here is, what I want to calculate here is, okay, without calculating DC, first let's talk about the type of symmetry. What type of symmetry here? Now you see right and left, right 5, left minus 5, then right plus 5, right minus 5, left plus 5. So they differ in sign. Or you can say symmetry in first and third quadrant. Okay, symmetry around this line. Okay, symmetry in the first and third quadrant. Okay, so yes, it is odd symmetry. So this particular waveform is odd symmetry. Okay, now because it is odd symmetric, what all it cannot contain? Okay, because it is odd symmetric, it will not have DC, so no need to calculate. That's what I'm telling. No DC and cosines. No DC and cosine. It will only have sines. Okay. Now, is it also, now when I talk about symmetry, there is one more thing I taught you, half wave. Is it also half wave symmetry? Okay, again I will draw carefully. You see, every time you may not need to draw, but okay, understand here once again. Okay, so what do we do to check half wave symmetry? We shift the signal by half a period. What is half a period? 5, because full period is 10. So half period means T by 2 means 5 here. Okay, so I'm going to shift it by half a period. Okay, when I shift it by half a period, okay, this negative cycle which was starting by minus 5, shifting by 5, the negative cycle starts at origin. So what starts at origin? Negative cycle. This is there for 5 units of time. Okay, then positive cycle, okay, which was starting at origin, right shift at 5. Okay, so here what will start? Positive cycle. Then again after 5 units of time, negative cycle. And it will repeat. The rest is just repetition. Now, if you carefully compare the above and below, 5 becomes minus 5. Okay, minus 5 value becomes plus 5. Okay, just opposite in sign. Just opposite in sign. So what I have obtained here is when I shifted by half a period, x of t minus 5 is minus xt. T minus 5 means t minus t by 2. That means the waveform is also having half wave symmetry. So what do you know about half wave symmetry? Half wave symmetry means here also I can say there will be no DC. Anyways, that is concluded by odd symmetry also. No DC and no even harmonics. Only odd harmonics. Only odd harmonics. That too, what type of harmonics? Only sine terms will be there. Okay, so see here. Fundamental period, I'll write down the answer now. T equal to 10. DC component, C naught equal to 0. DC component, C naught is 0. Type of symmetry, it has odd symmetry. That is a separate concept, and it has a half wave symmetry. Okay, which terms are present in trigonometric Fourier series? Only sines. Which harmonics are present in trigonometric Fourier series? Only odd. Only odd. Shall I write down the trigonometric Fourier series general expression here? Okay, what will be the trigonometric Fourier series representation for this signal? It will be given by, normally you start with what? C naught, but no C naught here. Then what do we write down? We write down summation k equal to 1 to infinity cosines and sines, but no cosines here. Okay, only sines. So bk sine k omega naught t. Okay, bk sine k omega naught t. But normally we write down summation k equal to 1 to infinity, but it is not summation k equal to summation, not all values of k. Summation, only odd harmonics will be there. So how do we write down this one? K equal to, by writing this way, 1, 3, 5, etc. This is how we write down. Okay, trigonometric Fourier series if the signal is odd and half wave symmetric. If the signal is odd and half wave symmetric. Okay, so this is odd and half wave symmetric. Okay, by chance, if I give you a separate question where the signal turned out to be even as well as half wave symmetric, then how will you write down the expression? Then you will write down the expression as, anyways, half wave symmetry means no C naught, no DC component. Okay, No DC component. Okay, you will directly start with summation. Now because it is even, it will have cosines but not sines, so only cosine terms. AK cos k omega naught t. AK cos k omega naught t. Is it for all values of k? No, because of half wave symmetry, only odd values of k will come, no even harmonic. So again k equal to 135 like that. Govindrao, whether you left or right shift by half a period, whether it is advanced or delayed, it will be same type of result only, because signal is periodic with period t. So left shift by minus t by 2 or right shift by plus t by 2 will give the identical waveform. Just check the result carefully. Okay. Whether you draw x of t minus 5 or t plus 5 will be same here. What is there? If you left shifted, then also what will come? This negative cycle will come up here, na, left shifting. You just check the result carefully. Okay. Now, as I told you, there can be separate question on the DC component. Okay. What is the DC component? What is the DC component? What is the DC component? Okay, C naught. What is that DC component I told you? If the waveform is given, suppose this is some signal xt. Okay. What is the C naught? If you want to go by the formula, 1 upon t integral xt dt for one period. Integral xt dt for one period. I also told you, okay, it is area under xt. It is area under xt. Which area? Only for one period. Area under xt for one period divided by the value of the time period. So better you just write down the area and close the answer. What is the C naught? So this is one next probable question. Then you are going towards quarter wave, Govindrao. Okay, so which is not required here right now as of now. Okay, so what is area under xt for one period? What is area under xt for one period? See here, if you take the area under xt for one period, okay, break it into what? Triangle, square and a rectangle. Okay, so area of triangle half into base into height, half into 1 into 1. Sorry, base is 2 units. Half into base into height. Plus then the square part, height into base 1 into 1. And then next, the triangle part. Okay, what is that triangle part here? Sorry, rectangle only again, not triangle. So base is 1 and height is equal to 3. Okay, whole divided by time period. What is the time period? Time period will be 6 actually. The next pulse, the next similar signal starts at 6. Okay, so divide by 6. So how much it is? 2 to cancel. 1 plus 1 plus 3, 5. 5 by 6 it is. It is 5 by 6. The answer will be A. Answer will be A. Yeah, so easy one only. Okay. Find the Fourier series coefficients xt for the signal shown below. Okay. Now I'll tell you a simple thing. You can go by the CK formula. But I'll tell you something, to be remembered here. And one more point I will add here. See, this is some waveform given. Okay. This is some waveform given. For a reference, let me just copy this slide. There are 2 to 3 things that I wanted to explain here. Just replicate this. Okay, yeah. So 2 to 3 things I wanted to explain here. Come here, guys. Sorry. Look into this. Find the Fourier series coefficient. Okay. What is one thing here? Okay. I'm not asking about type of symmetry. I just want to find the calculation. I want to calculate CK here. I actually want to calculate Ck here. Okay, my focus is Ck here. Then I will talk about symmetry as well. Okay, now what is method number 1 to calculate Ck? The direct formula. Okay, Ck given by the formula 1 upon t integral for one time period xt e power minus jk omega naught t dt. Okay, what is the time period here? Okay, the time period here, the center of the next rectangle is 4. The time period is 4, omega naught will be, okay, 2 pi by 4. And then what is the time period? I am placing the time period as 4. Okay, so then integral for one time period. Let me take one time period here, minus 2 to plus 2. We can take this way also, na? Okay, this you can call it as the total period. Okay. Okay, so integral over one time period, that is integral minus 2 to 2 xt e power minus jk omega naught t. What will be omega naught? Omega naught will be further 2 pi by t. Okay, that is 2 pi by 4 or pi by 2. Pi by 2. Okay, that is pi by 2. E power minus jk omega naught I will put here. E power minus jk pi by 2t dt. Correct? This is what is the calculation required. Okay, but now further it will be equal to 1 by 4. What is the xt now? Xt value is constant too, but only from minus 1 to 1. So because of that, I will further simplify the limit and put it as minus 1 to 1, because outside that the signal is 0. In minus 1 to 1, what is the signal? Xt is 2 e power minus jk pi by 2t. Okay, so it's because the signal was constant, it's a simple integral left in front of you. Okay, it's a simple integral left in front of you. Okay, and that will be 1 by 4 into 2, that is 2 by 4. And let me complete this actually here. This will be equal to 2 by 4, and then integral of the exponential term. Let me do that. Integral of e power minus jk pi by 2t. Okay, that will be e power minus jk pi by 2t divided by minus jk pi by 2. Pi by 2, limit minus 1 to plus 1. Okay, so what is this? This is 1 by 2. This is also 1 by 2. That will cancel actually. So then I put upper limit e power minus jk pi by 2. Minus lower limit is minus 1. So it becomes e power plus jk pi by 2. And I told you this 1 by 2 will get cancelled. Minus jk pi is still left. Okay, minus jk pi is still left. Okay, or then to ease out the things, take the minus above. Okay, so you will have e power jk pi by 2 minus e power minus jk pi by 2. Okay, divide by jk pi. So let's divide by 2j and I multiply a 2 extra. Okay, and then k pi. Separate the k pi. Okay, because e power j theta minus e power minus j theta. Divide by 2j. Okay, divide by 2j. Okay, is known as what? Okay, is known as sine theta. Okay, so the answer can be written as 2 upon k pi sine theta, where what is theta? Sine k pi by 2. Sine k pi by 2. Okay, not a difficult one, but yeah, okay, we have got the answer. Okay, we have got the answer. It's not a difficult one. But now see, I just want to tell you a quick method here because you are clear. Okay, same question, method number 2. Same question I have copied. Okay, the next method for the Fourier series coefficient is, calculate the Fourier series coefficient by this formula, 1 by t xp k omega naught. Directly use this shortcut, 1 by t xp k omega naught. Okay, 1 by t xp k omega naught, where what is xp omega? Xp omega is the Fourier transform of one period. Suppose one period is xpt, one period of xt. Now see, what is one period here? What is the one period here? This is the one period, and in one period the signal is a rectangle. Okay, because you know the Fourier transform formulas directly, you can use it without any calculation. What is that one period here? Rect of t by 2. Okay, rectangle of how much width? Of the width 2. So this becomes rect of t by 2. Rectangle of the width 2. So this is rect of t by 2. Clear now? This is rect of t by 2. So what is going to be xp omega? Rectangle Fourier transform t sampling omega t by 2. When you apply t sampling omega t by 2, you get the answer 2 sampling omega. Okay, 2 sampling omega. Okay, then what is t and what is omega naught? Our t value is 4. Our omega naught is 2 pi by t, which is pi by 2. Okay, so what is going to be Ck? Ck, as I told you, just use this formula. So all that integration, calculation and manipulation of the terms, it is saved. 1 by t xp k omega naught. 1 by 4. Now what is xp? 2 sampling sampling omega. What is sampling omega? Okay, sampling omega. Omega means k omega naught you have to put, and omega naught is pi by 2. So this way. So Ck can then be written as 1 by 2 of sampling k pi by 2. 1 by 2 sampling k pi by 2. This has to be the Ck answer. 1 by 2 sampling k pi by 2. The previous answer can also be finally written in the form of sampling. In the form of sampling. Do I have a calculation not matching here? It shouldn't be the case. Sorry, this is not, this is equal to 2 times rect. The height of the rect I missed here. This is 2. Okay, so this also will be further multiplied by 2. This is 2 into 2 sampling omega. Okay, that is 4 sampling omega. Okay, yeah, so answer will match up only. Okay, and because it is 4, this 4 and 4 will cancel. Answer will be simply sampling k pi by 2. Sampling k pi by 2, sin k pi by 2 upon k pi by 2. Okay, that you can do here as well. Okay, you can write down this one as sin k pi by 2 divide by k pi by 2. Okay, this 2 has been shifted to denominator, it becomes 1 by 2. Okay, sin k pi by 2 upon k pi by 2 is sampling k pi by 2. Okay, but here I integrated, I used the basic formula of Ck and I got the answer. Okay, the other method, the method number 2 that I am telling, and I want you to use it most of the times. Okay, at least for the pulse whose Fourier transform is known to you, this is going to be helpful for you. 1 by t xp k omega naught. 1 by t xp k omega naught. Clear? Okay, now some more analysis here. Same waveform I have taken here. 1 by t xp k omega naught. Okay. Yeah. My answer has been sampling k pi by 2. Okay. Sampling k pi by 2. Now, what is C0? What is C0? Sampling 0. That already I discussed with you. What is the value of sampling 0? Sampling 0 is 1. Already I have told you. What is the value of C1? Okay. Okay. I'll write it this way so that you can calculate the answer. Okay, what is happening? Okay. I'll write this way. Sampling k pi by 2 means sin k pi by 2 upon k pi by 2. Sampling 0 is 1. Okay, now the C1 value. What should be the C1 value? The C1 value will be sin pi by 2 upon pi by 2, and sin pi by 2 is 1. So 1 upon pi by 2. Okay, so final answer is 1 upon pi by 2 means 2 upon pi. Okay. Similarly, now C2. When you take C2, it becomes sin pi actually. Sin pi upon, okay, 2 pi by 2, but sin pi is 0. Okay, when you take C3, okay, it will be sin 3 pi by 2 divided by 3 pi by 2. Sin 3 pi by 2 is minus 1. Okay, so final answer, when you take 2 above, it will be minus 2 divided by 3 pi. It will be the minus 2 is divided by 3 pi. Okay, then again if you take C4, when you want to write k equal to 4, numerator will be sin 2 pi actually divided by something, but sin 2 pi is 0. Okay, that means again you are getting a result that Ck equal to 0 for k equal to what value? 2, 4, 6, etc. Okay, but C0 this time is not equal to 0, and C1, C3, C5, these are not equal to 0. Odd harmonics present, DC also present. Okay, a result similar to half wave symmetry. But now let me go and check whether the waveform is actually half wave symmetric. Okay, when you shift it by half a period, what is there? What is the half period here? What is the half period here? Okay, 2. The full period is 4, the half period is 2. If you shift it by 2 also, na, okay, this waveform will start here. Okay, wherever it is plus 2, it becomes 0. Wherever it is 0, it becomes plus 2. But after shifting by half a period, the signal above and below should differ by sign. Okay, 2 should become minus 2. Okay, but it is not possible here. It does not have half wave symmetry. This waveform is not half wave symmetry. Okay, this waveform is not half wave symmetry. Okay, now understand the next important point here. Understand the next important point here. This is 2. This is minus 2. What was the DC component? See the DC component of the signal 1, that you can find directly also, like previous question I told na. Okay, area under 1 period divided by time period. Okay, anyways I know the DC value here. How much is that DC value? Okay, how much is that DC value? I'm using the DC value and I'm drawing a line here. Okay, the line that corresponds to the DC value. Okay, the mean value of the signal. DC value also known as average value, na? Okay, so let this be C naught, which is equal to 1, and this is what is known as the mean line. This is the mean line. Okay, imagine this to be new x-axis. This mean line is now going to be imagined as your new axis. Imagine it to be your new x-axis. Now dear, if this is x-axis, any voltage above x-axis, if this is x-axis, any voltage above x-axis is the positive voltage. So already you are at 1, you go to 2, that means 1, and any voltage which is below the x-axis is negative voltage. Okay, this will be -1. This will be -1. Okay, now when you think about symmetry around this line, okay, is there any symmetry around this line? Anyways, the signal is even symmetric, that is anyways there. Okay. Okay, now when you right shift or left shift anything by half a period is 2 here. Okay, so this waveform will come up here like this, and then again I will draw that mean line here in this new chart also. Okay, this is again the mean line here, C naught equal to 1. Okay, now when you see if this is 1, okay, how much is this value? -1. Wherever you had +1, now it is -1. And how much is this above x-axis? This is 1. Wherever -1, it is +1. Okay, so what can I say? The signal about the new x-axis means mean line. About the mean line, okay, the signal satisfies x of t minus 2, t by 2 equal to -xt. That is half wave symmetry. Okay, not about the original x-axis. Okay, but when there is the symmetry about the mean line, those symmetries are defined as hidden symmetry, and this waveform is said to have hidden half wave symmetry. This waveform is said to have hidden half wave symmetry. Okay, now what was the result for half wave symmetry? Difference, I will write down the difference. If it is half wave symmetry, okay, if it is half wave symmetry, okay, Ck equal to 0 for k equal to 2 or -2 plus or -4 etc. Ck equal to 0 for k equal to 0 also, no DC. No DC. Okay, and Ck is not equal to 0 for k equal to +-1, +-3 etc. Odd harmonics are present. Okay, but if it is hidden half wave symmetry, the difference is only in terms of the DC component. Okay, DC component. Ck will still be 0 as I have seen in the earlier question for k equal to +-2, +-4 etc. Okay, but C naught will be non-zero here. Okay, C naught will be non-zero here, and Ck will be non-zero for odd values of k as well, k equal to +-1, +-3 etc. This is the difference in the results. The only difference will be DC. Now, hidden half wave symmetry or any hidden symmetry is about which line? Only about the mean line. It's not any random line you have to think. If there is a hidden symmetry, it will only be around the mean line. Okay, there can be hidden half wave symmetry, there can be hidden odd symmetry also. Even symmetry will be normally also available. Okay, so what is the conclusion for this waveform? What is the conclusion for this waveform? This has even symmetry. Anyways, left and right is identical. It has an even symmetry and hidden half wave symmetry. That is the final conclusion to be taken for this waveform. It is even symmetry and hidden half wave symmetry. And I repeat, hidden symmetry will not be around any random line. You don't have to search randomly in the air. Okay, if there is a hidden symmetry, it is only about mean line, about the DC line, about the mean line. Okay? Okay. Chalo. If you have understood and if you have still not put your attendance, put your attendance. Okay, what is attendance? Just press the like button and your attendance is registered on the YouTube. That's it. Okay. Now what is there? Next question. Now next question I want you to solve by the logic I told you, CK. Okay, what is the logic I told you? See, because if you start integrating here, it is going to take a lot of time. Okay, what I just told you, we will use the CK 1 upon T xp k omega naught. Let us solve it by this logic. 1 upon T xp of k omega naught. 1 by T xp k omega naught. Okay. 1 by T of xp k omega naught. This is what is the CK that I am going to write here. Okay. Now, what is the time period here? What is going to be the time period here? Okay, let us check it out. Okay, the time period, if you mark it from center to center, the time period is definitely 5 here. Okay, the time period is 5. So, omega naught is going to become 2 pi by 5. Okay, but what is the signal in any one period? Okay, it's a triangular pulse, and we know the Fourier transform of triangle. That's why this approach is easy. This approach is easy. What is the one time period? It is a triangle pulse having the amplitude 3. Take care of that. Okay, triangle of how much? T by, okay, now triangle total width is 4, but we write try T by 2 because I told you whenever you write try T by T, then automatically total width is 2T. Try T by 2 minus T2 minus 2 to 2, total width 4. Okay, hope you remember that. Okay, so it is try T by 2. Okay, what is going to be the Fourier transform xp omega? 3 times into, okay, what is the formula I will use? Okay, just let me quickly recall here only. Okay, what is the Fourier transform for triangle I told you? Try T by T, Fourier transform given by T sampling square function omega T by 2, correct. So, sampling square function, sorry, with T multiplied, what is that T value here? 2. 2 sampling square omega into 2 by 2. Okay, so that xp omega, that is the Fourier transform of one period, is 6 sampling square omega. So, what is CK? Just put down the data then. What is CK? 1 upon T, that is 1 upon 6, sorry, 1 upon 5 into xp k omega naught. What is xp? 6 sampling square omega. At what omega? Omega equal to k omega naught. What is omega naught? 2 pi by 5. 6 by 5 is 1.2. So, final answer CK will be 1.2 sampling square 2 pi k by 5. This is the answer. Now, if you want to try by the CK direct formula, by the integration CK formula, you keep trying, it will take much more time than this one. That is why I wanted you to learn this technique. It will take much more time as compared to what I have just told you. You try. You try. By the time I would have finished 2-3 more questions. So that's why, at least for these very common waveforms, see, because for majority of the waveforms that can come, Fourier transform I have already given to you. They have built a table for Fourier transform important formulas and property. So you can use it. You should use it, I would say. You should try to use it and convert your answer quickly. Okay. Now easy but 2 important questions. Okay. From the GATE 2025 MSQ question, 2 marks. Okay, let ft be a periodic signal with the fundamental period t naught greater than 0. And now consider another signal yt, which is f of alpha t, where alpha greater than 1. Okay, what is the Fourier series expansion of ft and yt? Okay, are given by this representation. Okay, which of the following statement is or are true? Now see, what is the relation between yt and ft, f of alpha t? ft is summation ck e power jk omega naught t. Omega is 2 pi by t naught. The Fourier series coefficient ck. Okay, yt summation dk e power jk omega naught t. Omega naught becomes alpha 2 pi by t naught because of the time scaling. Okay, so these are some results, 2 marks, but these are the results you already know in the property form. If yt is f alpha t, okay, time scaling, does this change the period? Yes, it changes the period. Okay, and the original period divided by alpha. I already told you, we have even taken question onto it earlier. Okay, so t naught by alpha, yt is still periodic with period t naught by alpha. Okay, but time scaling, okay, does not change the Fourier series coefficient. Okay, the Fourier series coefficient dk will be same as the Fourier series coefficient of f, that is ck. Okay, dk will be ck, not divided by alpha. Option number A. I told you already, na? The time scaling is one property which does not change the Fourier series coefficient. That was seen separately as well, correct? That we have discussed separately as well. Okay, next question. Gate 21, 2 marks. Okay, let us take up this question. The gate 21, 2 mark question. The exponential Fourier series representation of a continuous time periodic signal is defined to you. Xt equal to summation minus infinite to infinite ak e power jk omega naught t. So in these ak are not the coefficient of that cosines. This is the trigonometry. This is the exponential form only. Okay, so this ak, earlier I used to write ck, but they can use any name. These are the exponential coefficients only. Exponential Fourier series coefficients. Okay. Omega naught is the fundamental frequency and the coefficients are ak. The following information is given about xt and ak. Xt is real and even having a fundamental period of t. Okay, xt is real and even. So if a signal is real and even, what about Fourier series coefficient? Use the property one by one. 2 mark, good question. You have to build up on the property. If a signal is real and even, Fourier series coefficient ck, or here they have called as ak, real and even. The ak will also be real and even. Correct, na? The ak will also be real and even. Okay. What is the average value of xt? Okay. What is the average value of xt is given as 2. Average value means C naught or A naught here. Average value is also the DC value. Okay. And ak equal to k for k 1, 2, 3, otherwise 0. But it is even also, remember. Okay. So what is the information? This third information, I will draw this separately. What is ak? Ak is directly equal to k. Correct, na? For k equal to 1, 2, 3. Okay, 1 less than equal to k less than equal to 3 and 0 otherwise. That means a1 will be 1, a2 will be 2, a3 will be 3. But these are also even. Okay, so a1 is also a minus 1, a2 is also a minus 2, a3 is also a minus 3. Remember that. Okay, and one more value was separately given to you. The DC value is 2. Okay, the A naught value is 2, the average value is 2. What is the average power of the signal? Now, no need to build the entire signal, it will take time. Okay, it will take time. What is the average power of the signal? The average power of the signal, which is given by generally what formula? 1 upon t, okay, integral x square t dt for one period. Energy in one period divided by time period. But the same thing by the Parseval's formula, I already told you in the property. By the Parseval's formula, the average power of a periodic signal is also equal to summation of modulus ck whole square. We apply modulus ck because ck may be the ck may be complex as well, but here they are all real. Okay, so summation of modulus ck square. Okay, so what are the different ck or ak? I'll again convert this to ak. Okay, so what are the different values of ak? If I have to write it in the sequence form, see ak, okay, a minus 3 is 3, then 2, then 1, then a0 is 0. This is a0 for k0. Okay, then a1, a2, a3 is 1, 2, 3. These are the Fourier series coefficient. These are the only non-zero Fourier series coefficient. I have written it in the set form. Okay, summation of the square of them. Okay, that is 3 square plus 2 square plus 1 square plus 2 square, and then right side again repeat 1 square plus 2 square plus 3 square. So how much? This is 9 plus 1, 10 plus 4, 14, 14 to 28, and 28 plus this 4, 32. Check the calculation once. The answer has to be 32. 14, 14 to 28 and a 4 in between. Okay, 32 is what I am getting. Summation mod ck square directly, 32. The average power of signal will turn out to be 32. Okay, yes. 32 is what is the correct answer. Okay. Yes, Shravan, Winter Child, correct answer. Okay. Guys, before moving forward, the next important update for you, if you or if any of your friends you know or juniors you know, they are planning to prepare for the AE examination, the Telangana or AP Genco Transco Discoms. Okay, so for the Genco Transco Discoms, for both AP and Telangana, the new offline batch, okay, this is offline batch, the new offline batch, Okay, at our Hyderabad center, starts 29th January. For any queries, you can contact 95156940539. 95156940539. Okay, right? Next one. Okay, now next here, this is already CTFS I have taken. DTFS, what are the comparisons and what are the difference? That basic part we have already reviewed. Okay, the important point is DTFS coefficients are periodic unlike CTFS. Okay, unlike CTFS, that is what you should know. Dirichlet's condition, okay, this periodicity point I told you, and then I told you I will take some logical type of question on DTFS. Okay, just by the concept you can answer this question. Gate 15 2 marks question, come on, answer this. Gate 15 2 marks question, come on, answer this. Come on. Okay. Yeah, students. Okay, let us see. Rahul, how can I answer this? It's just my interest and passion that keeps me going. Okay. So, yeah. But yeah, very soon I'll take a break. I'll take probably a 5 minutes break only because already it's post 5 and at least many more things I have to tell you. Okay, so we'll just take a 5-7 minutes break. I'll just have a basic tea or coffee, only that much. Okay, I've asked for coffee. As soon as my coffee is ready, I'll take a 5 minutes break. Okay, you also can take a 5 to 7 minutes of refreshment. Okay. Now, what is there? Xn equal to 1 plus cos pi by 8n be a periodic signal with the period 16. Okay, that you can anyways figure out. Why the period is 16? Because omega is pi by 8. Okay, and 2 pi upon pi by 8 is 16, which is directly integer. And whenever 2 pi by omega is integer, so the time period is that integral value only. Otherwise, that K method you know for discrete signals. Na? Okay, so the time period is 16 here. Okay, the time period is 16. The DFS coefficients, the DTFS coefficients are, we already know the formula. This also is known to you, nothing new. Okay, what is the coefficient A31? See, what is this is actually the same formula, 1 upon n. If you see, this is 1 upon n, summation n equal to 0 to n minus 1, the signal xn or x hat n, e raised to the power minus j, e power minus j. How I have written e power minus j k omega naught. Omega naught is 2 pi by 16. That is why it becomes pi by 8. So this is known to you. Even if they don't give it, not required. Okay, now see why this question is simple and logical, because whenever especially trigonometric functions are given, okay, and the question is about exponential Fourier series. This is what the exponential Fourier series coefficient. Okay, you can break any trigonometric function, whether it is cos form or sine form. Okay, you can break it into exponential, na? Yes, so how can you write down the signal? The given signal xn is nothing but 1 plus cos theta. Okay, and cos theta is e raised to the power j theta, e power j pi by 8n plus e raised to the power minus j pi by 8n is divided by 2j. Is divided by 2j. E power j pi by 8n plus e power minus j pi by 8n divided by 2j. Correct? Correct. So what is this equal to? Okay, now let me shuffle and rearrange the terms. Okay, sorry, divided by 2. It is cos theta, not sin theta. Okay, divided by 2 only. Okay, and then I will write down this as 1 by 2. Okay, 1 by 2 e raised to the power minus j pi by 8 na. Pi by 8 again I am writing this way. Pi by 8 means 2 pi by 16 only into n plus a 1 and plus 1 by 2 e raised to the power minus j 2 pi by 8 into n. Okay, now normally how do you write down xn? Okay, normally how do you write down xn? You write down xn as summation of ck or ak, here they have named as ak, again I will use the name ak, ak e raised to the power jk omega naught n. What is omega naught? 2 pi by n. This is the Fourier series form, na? Summation ak e power jk omega naught n, correct? So when you compare e power, see, look into this, this was plus and this was minus, e power plus j 2 pi by 16, typo error, I think I have written typo error. Okay, so if this is directly omega naught, where is k? K equal to 1. E power minus j omega naught n, so k is minus 1. Okay, so what are the different terms? This corresponds to k equal to 1. Okay, this corresponds to k equal to minus 1 and this is constant. Constant means corresponding to k0, the DC term. So what are all the Fourier series coefficients that you can write from here? Okay, so this will be a minus 1, na? A minus 1 is half, then the a naught is 1. This is going to be a naught corresponding to k0 and this coefficient, the coefficient of exponential term is ak. So what is multiplied? This will be a1, a1 equal to half. Okay, so this will be a1 which will be half, a naught is 1. If they ask any coefficient, that is ready. But now what is the question? What is the question is a31. There is no a31. Is it 0? No, 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 no. Is it 0? Remember this periodicity. The question is a31. Is it 0 because it is not seen here? No. If it was a CTFS question, you will say answer 0. If it was a CTFS question, you will say answer 0. Okay, but here a31 will be same as a15. Why? Because DTFS coefficients, they follow periodicity. AK plus n is equal to AK, or AK plus 16 is equal to AK. Okay, here the period is 16. Here the period is 16. So what is a31 will be same as a15. Okay, 15 plus 16, and this will be same as a minus 1. You can reduce or you can add 16. Okay, so answer is equal to a minus 1. What is a minus 1? 1 by 2 or 0.5 or 0.5. That's it. That is what is the answer. That is what is the answer. Okay, got it, dear? That is what is the answer. Okay, so what is the value of the coefficient a31? 0.5. Let me tell you, if the same question, okay, let me tell you, okay, if the same question, see the difference. If the same question is in the continuous time domain, convert n to, t, okay, then what is a minus 1 or a1? That is equal to half, and a naught equal to 1. Question is a31. There is no a31, that will be 0, because only these are the non-zero coefficients and no repetition is there. No repetition is there. Okay, so that is the difference in DTFS coefficients. The coefficients follow periodicity because of the reason I explained you earlier, but not in case of CT. The primary reason is also time being integer, and the continuous time can take any value. Okay, can take any value. So this is what is the answer. Done? This is what is the answer. Next question. Let us be ready for the next question. What is there? Similar sinusoid question. So homework, I think number 8. I remember it as number 8, I guess. Okay, this is the homework number 8. Similar question. Okay, similar question. I think this is around one question that Govind Rao was referring. This one or similar to this one. Okay, try it. Same sinusoidal type of question. Break it into exponential. Okay, break it into exponential and apply the DTFS periodicity, because it is again a discrete time signal. Okay, so periodicity will again be there. AK will be equal to AK plus N. Okay, the time period will be 10 here. Okay, the time period will be 10 here. Okay, will be 10 here. And if it repeats after 10, it repeats after every 10, 20, 30, etc. Homework number 8, answer I want in the comment box. I don't want any answer right now. Okay, spread it in the comment box after the video is over. That comment box, not the live chat box. Okay, homework number 8. Mention the answer as answer of homework number 8 is whatever you calculate. Okay, later I will reply. Let everybody Solve. Let everybody solve, okay? Next question. Gate 22, 2 marks, electrical question. Gate 22, 2 marks, electrical question. There has been one more very good question in electrical, gate 23, but that I will take once DFT is done. That is a connection between DTFS, DFT and DTFT. Very good question, electrical. Okay, so there have been good questions in EC, no doubt, but why I am stressing this point, this is also electrical, because earlier also I told you, electrical people think that DTFS and DTFT, they have to skip. No, you get questions. Recently, I've got good questions. Okay, after this, I will go to DTFT. Okay, because we have done CTFT, so DTFT, many of the properties you can correlate. Chalo, come on. Let's take this question, electrical engineering question. This is the DTFS representation of a signal with period n. Anyways, we know. Summation ak for one time period e power jk omega naught n. Omega naught is again 2 pi by n. This is anyways known to us. A discrete time periodic signal, okay, with period n equal to 3. There is a discrete time periodic signal with period n equal to 3, has the non-zero Fourier series coefficients. Now, only these are the non-zero Fourier series coefficients. What are they? Minus 3 and A4. Okay, now because period is 3, the Fourier series coefficients will also be periodic, correct, with period 3. But what are going to be one set? Okay, what is going to be one set? If the, period is n equal to 3, okay, so if you put down that period n equal to 3, what do you get here? K equal to 0 to 2. Okay, what do you want to construct the signal? The final question is, what is the signal xn? Oh, this question is missing here. Okay, this is the data given, then what they are asking? The final question I will write here. The signal xn is equal to, this is the question. So you have to choose the correct signal here. Again, a more of a trigonometric and logical question, 2 marks. Okay, see, how will be the signal xn here? It will be given by summation k equal to 0 to 2, because n minus 1 will become 2, ak e power jk 2 pi by 2 into n. Okay, 2 pi by 3, sorry, 2 pi by 3 into n. Okay, but before we expand this, I need to know what values. Okay, I need to know a0, a1, a2. Okay, so to complete this, I need the value of a0, a1 and a2. Okay, now out of which is a0 given? Okay, a0 is not directly given, but a0 will be equal to a minus 3. Any 3 units gap value will repeat. A minus 3 is given as 2. Okay, then a1 should be same as a4, again 3 units of gap. This is 1. Okay, a2. Now a2 should be either a5 or a minus 1, but no other value given. Clearly question mentioned the only non-zero coefficients are given. That means other are 0, na? Others are 0, not given means 0, so a2 will be 0. Okay, a2 will be 0. Okay, so what is there? What is the signal xn? I'll write down as I've written earlier. We need to solve summation k equal to 0 to 2 ak e raised to the power jk omega naught n. Omega was 2 pi by 3 into n. Now I will open the bracket. I will open the summation starting from k0. If I start for k0, what will come? A0. A0. Okay, e power 0 will be 1. Then what will come? A1 e power j 2 pi by 3 into n for k equal to 1. For k equal to 2, a2 e power j 2 into 2, that is 4 pi by 3 will come into n. Okay. Or let everything be in terms of omega naught only right now. Okay, twice of 2 pi by 3, twice of omega naught into n. Okay, now I will put down the value. What was a naught value? I'll just see. A naught was 2, a1 was 4. A naught is equal to 2, a1 is equal to 1 and a2 is 0. Okay, so the last term actually not required. Okay, so what is the signal xn? Okay, it is simply equal to 2 plus e power j 2 pi by 3n. So question should finish here, but I think it will not finish here. A2 was 0, na? Confirm? Yeah, A2 was 0. See, the question will not finish here because options are not given this way. Okay, options are having some cosine term. Okay, so that means our answer is correct, but it has to be rearranged. It has to be manipulated and rearranged. Our answer is correct only. Okay, our answer is a correct answer only. Okay, so 2 plus e power j 2 pi by 3 into n, right? So what it is going to be, see, to rearrange, I will first break this 2 as 1 plus 1. I will break this 2 as 1 plus 1 and then I will break this e power j theta, na? Theta by 2 and e power minus j theta by 2. Okay, let me write down this one as, okay, see, first to make it simple, I'll write this way, 2 plus e power some j theta. Okay, let this be theta. Okay, just a second guys. मैं open करता यही रख. Okay, let this be theta. I just want to make this representation simple. Now I will write down this 1 plus 1. Okay, I'll mention here only. I'm going to write down this 2 as 1 plus 1, and the next one let us break as e power j theta by 2, e power minus j theta by 2. And this e power j theta, break it as e power j theta by 2 into e power j theta by 2 only. So that plus theta by 2 plus theta by 2 will be theta, and these two will cancel, you will get 1 only. Okay, you'll get 1 only. Now you will get the answer as 1 plus e power j theta by 2 common, and then you will get e power minus j theta by 2 plus e power j theta by 2. Okay, and then this is finally 1 plus e power j theta by 2. This is going to be how much? 2 cos theta. Now place down the value of theta and write down the complete answer. 1 plus 2 e raised to the power j theta by 2. Theta was this one, so theta by 2 will become pi by 3. Pi by 3n into cos of, okay, into cos of how much? Into cos of theta, and theta is 2 pi by 3n. Theta is 2 pi by 3n, right? Okay, now you can match the answer. What is matching here? 1 plus 2 e power j 2 pi by 6. I think then cos theta, theta was, this was also theta by 2. I'm sorry. This was also theta by 2. Okay, so theta by 2 will be pi by 3, or you can write it as 2 pi by 6. Here also let me write it as 2 pi by 6. I written pi by 3. It's one and the same thing only. Okay, then you can match the answer as, what is there? Option number B then. B will match. B is the perfect match. Correct? B is the perfect match. That's it guys. Okay. All right guys, just a 10 minutes break. Okay. And we'll resume at 5:40. 5:40 p.m. We'll resume at 5:40 p.m. Okay. We'll resume at 5:40 p.m. Okay. Chalo, bye bye. See you in 10 minutes. Okay. Okay, guys, I'm coming back. Yes. Okay. Govind Rao, how A minus 4 is A4? Just justify that point first. How A minus 4 is A4? That is only if there was some even symmetry. Where is some even symmetry? Nothing mentioned. So how you are taking A minus 4 as A4? A2 will be 0 only, dear. Just check it out once again. What you are telling up to A minus 4 is okay. Okay. But A minus 4 is not A4. Okay. Chalo. Right. So these were some 2 mark but logical questions on DTFS. See, after DTFS, I first wanted to discuss DTFT. I will go to DTFT, but before I go to DTFT, now I want you to understand the connection between DTFT and ROC of Z transform. Okay, the Z transform with basic ROC and then DTFT and then Z transform property. Like that I will mix because I want you to first go to DTFT because CTFT is done. But you know, several times in the question in the exam, number one, Z transform alone ROC has been important, and number two, the connection of ROC of Z transform with the DTFT has been actually important. So that's why I don't want to miss that connection first of all before entering into, because I want you to first go to DTFT. Okay. Okay. So Z transform, aware about the Z transform, if Xn is a discrete time signal, okay, it has the Z transform again represented by the two-sided arrow, Xn having the Z transform Xz or Xz having the inverse Z transform of Xn, and given by the formula summation minus infinite to infinite Xn Z power minus n. Okay. So, now let me start with some fundamental signal here. Suppose I wanted to discuss the Z transform for a power n un. How will I start the calculation? I'll start with the formula only. What is there? What is the formula I just told? The Z transform is summation from minus infinite to the infinite. Summation minus infinite to the infinite Xn Z power minus n. I will place the value. Summation from how much to how much? Summation n equal to 0 to infinity, because the signal has un component. Okay, and then what is the signal? A power n. Okay, the signal is a power n, right? A power n into unit step value is 1 and Z power minus n, or you can combine both the terms. Summation n equal to 0 to infinity a Z power minus 1 whole raised to the power n. Okay, now open up the summation. When you open up the summation, what do you get? First power, anything power 0, 1. Then AZ inverse, then AZ inverse power 2, the power will keep on increasing, making it as a GP term, AZ inverse whole power 3, etc. Okay, the GP with infinite number of terms, so answer for the GP is A upon 1 minus R, 1 upon 1 minus AZ inverse, but only if the GP is only convergent if, the GP is only convergent if magnitude of the common ratio is less than 1, modulus of AZ inverse is less than 1. Modulus of AZ inverse is less than 1. Okay, now what is this meaning? Modulus of AZ inverse less than 1 means modulus of A by Z less than 1, or reverse you can say mod A less than mod Z, or reverse mod Z greater than mod A. That means what is this condition? This is the condition, magnitude of common ratio less than 1, then only the infinite GP is convergent. Then only the infinite GP is convergent, correct? Then only the infinite GP is convergent. Okay, so mod Z has to be greater than mod A, then only this formula is applicable. So what can I say about the DTFT of A power n un? Okay, I can say that the signal A power n un, sorry, not DTFT, Z transform. I'm first into the Z transform here. Now see here, what can I say regarding the Z transform of this signal? A power n un has what Z transform? It has the Z transform 1 upon 1 minus AZ inverse. 1 upon 1 minus AZ inverse, or you can also write it in positive power of Z, Z upon Z minus A. Okay, Z upon Z minus A. But this is only defined, if mod Z greater than mod A. Now, what is the meaning of this condition? What is the meaning of this condition? See, firstly, if I ask you mod Z equal to constant, what is this? Forget the greater than or less than. Okay. Right, mod Z equal to A, this is known as the equation of circle in the Z plane. Mod Z equal to defines a circle with how much center? Center with 0, 0, okay, and radius equal to A. radius equal to a. When you write down modulus of z minus z naught equal to a, then the z naught becomes the center. Okay, right. So mod z equal to a is a circle. Okay, here what is the equation? Okay. So if I have again taken mod z equal to mod a, or suppose if I take a as some positive real number, let me also write down what is the pole of this function. If I ask you pole of this function, only one pole is there. Okay, and that is z equal to a. Only one pole is there, and that is at z equal to a. Okay, right. And suppose a is some positive real number. So let me mark this pole here. Okay, let me mark this pole here. But what is the condition you need? Okay, if I ask you mod z equal to mod a, then you will draw this circle, na? Then you will draw this circle. But what I want mod z greater than mod a. That means, okay, you have to go outside this circle. So what is this portion? Okay, this is the portion. See, this is the condition where z transform is defined, and I am converting this condition into a diagram in the z plane. Okay, a diagram in the z plane. Okay, wherein any value of z you select from this region that I am highlighting, any value of z you select in this region, the z transform of the signal is defined. Okay, the z transform of the signal is defined, but not inside this region. And this region is, that is why known as what region? ROC. This region is, that is why known as region of convergence. The ROC of the z transform. Known as what? ROC of the z transform. Okay, right? ROC of the z transform. Okay. Govindrao, signal is not given real, its coefficients are real, that is different thing. What you are telling, conjugate symmetry applies if the signal is real. There is no such information. Please read a property and question clearly, very clearly. Okay, now ROC, that is the region in the z plane. ROC is what? It is the region in the z plane for which the z transform of a signal is defined. Okay, for which the z transform of a signal is defined. Okay, similarly dear, if you take another signal, okay, similar to this, if you take another signal, okay, let me copy some of the things here. Yeah. So now I'll tell you, I'll just erase some required calculations. Okay. So, like I have calculated for a power n u n, similarly we can calculate for a power n u minus n minus 1 the left sided signal. Okay, and this will have the similar z transform, only a minus difference will come, minus 1 upon 1 minus a z inverse, or you can again write this as minus z upon z minus a. But actually condition will reverse. Again, same GP condition will come. So I am not deriving the similar thing. Okay, mod z less than mod a. Again, what is the pole of this function? It again has a pole at z equal to a. It again has a pole at z equal to a. Okay, where is the z equal to a? Suppose this is z equal to, assuming a to be positive real. Okay, so what is mod z equal to mod a? Again a circle, but this time what you will be looking is mod z less than mod a. That means inside this circle. That means inside this circle. So what are the first two natures of the ROC? Okay, the first two important natures of the ROC is either the exterior of a circle or interior of a circle. Okay, exterior or interior of a circle, and that interior is confined by the poles. Okay, you should also know the location of the pole. Here also this was the pole z equal to a. Okay, the difference in the signal, this is a power n un. Un starts for n greater than equal to 0, means where will this signal go? If you wanted to draw the signal will start from n equal to 0. Okay, a power 0, a power 1, a power 2, some value which will be right sided. So unit step you all know will go towards the right. Okay, this signal is right sided signal, and the ROC of it is the exterior of a circle. The other signal u minus n minus 1, because of the minus n the signal is left sided, and ROC of it is interior. Okay, if I take the next example of this kind, suppose you take the next example this way.
suppose the signal xn is taken as a raised to the power mod n. Okay, a power mod n. Again, you know how do you break a power mod n? Okay, for positive value of n, for n greater than equal to 0, mod n is n. For n is less than 0, mod n is given by minus n. Mod n is given by minus of n, right? Okay, so if you again want to write it in the detailed form, x of n will be given by a power n u of n, because n greater than equal to 0. N less than 0 means what unit step? N less than 0 means n less than equal to minus 1. So a power minus n can be written as 1 by a power n, u minus n minus 1. Unit step starting from minus 1. Okay, now what is the ROC for this? See, Z transform anyways you can write. What is the Z transform? Okay, for a power n un, just now we have written z upon z minus a. Okay, for again a power, this is 1 by a power n, z upon z minus 1 by. That's what I told you, only a minus sign difference, minus z upon z minus a. Okay, minus z upon z minus a. Here it will be minus z upon z minus 1 by a, because this is 1 by a power n, correct? Okay, what about the ROC? Okay, the ROC for this one, will be mod z greater than mod a. The ROC for the next one is mod z less than, okay, less than what? Less than 1 by a, or modulus 1 by a. Okay, and whenever you are constructing two Z transforms together, when you are adding two transforms, okay, both the ROCs should be valid, na? So that means you have to take the intersection of both. If you go outside any one ROC, what will happen? Think logically. If you go outside any one ROC, that particular Z transform is undefined. So overall answer undefined. So if you have to define the overall answer, you have to consider both ROCs commonly. That means intersection. So here, whenever two signals are added or subtracted, or whenever two Z transform you see together, their ROC has to be the intersecting ROC, common ROC. Okay, so my important result is ROC here. See, the signals you can add and subtract. Okay, you simplify this. What are you going to get finally? Z into a minus 1 by a upon z minus a, z minus 1 by a. As I told you, in the Z transform, first important area is the ROC. Okay, is the ROC. Now, what is the ROC? Greater than a, less than 1 by a. Greater than a, less than 1 by a. That means ROC has to be between a to 1 by a, modulus a to modulus 1 by a, so that it is greater than a but less than 1 by a. Greater than a, less than 1 by a. But yeah, for this condition, mod a should be less than 1. Okay, then only the sequence will satisfy, na? Okay, if mod a is greater than 1, suppose if you take mod a 2, mod z greater than 2 but mod z less than half, impossible, na? If mod z is greater than 2, it cannot be less than half, that becomes impossible. So mod a should be less than 1. Automatically 1 by a will become greater than 1. So the sequence has to be satisfied. Okay, so yeah, so this is the next case. So see, like this Z transform formula, again, as I have done for CTFT, okay, this is the property of ROC. This is the important point I wanted to come. But like I have done for CTFT, again, important Z transform pair, okay, are ready for you in the table, like delta n, Z transform 1, okay, with the ROC. Okay, I'll talk about delta n or shifted impulses as well. A power n un, this is what I actually derived right now. Z upon Z minus a, or negative power formula 1 upon 1 minus a Z inverse. Okay, a power n u minus n minus 1. Then next I have just now calculated a power mod n. Achha, it is written in negative power, I have written in positive power. Okay, anything is okay. Okay, this is the ROC that I wanted to discuss. Similarly, n a power n un. Okay, the Z transform is written in front of you, because I told you, every Z transform you didn't need to derive today, but whatever are the important Z transforms, only limited Z transform that you need to remember are in this table. n a power n un, okay, az inverse upon 1 minus az inverse whole square, or az upon z minus a whole square. ROC mod z greater than mod a. I am going to tell you some property of ROC. That's what is the important point. You can automatically write down these ROCs on the own. That's what I want to do, right? For unit step signal, nothing. In the previous formula only, if you want to go to the unit step signal, just put a equal to 1. You will get unit step answer. Just take a equal to 1. I think I am not tired. Many students are yet not tired, but this board is tired. It is responding slow. But okay, there is also a machine running almost from 8 hours now. More than 8 hours, I guess say. Okay, so unit step Z transform is written. Then n into un, RAM signal. Okay, n into un, also known as the RAM signal, R of n. Okay, so Z transform is written. Okay, from n a power n un. Okay. Sinusoids, cos omega n un, sin omega n un. Okay, all these Z transforms on calculation I have wrote it here. Okay, let me go back to the ROC discussion. What are the three cases of ROC that I have shown you till now? Okay, the third case I want to draw here again. I just went and shown you the table. See here, what is the third ROC that you have written here? Okay, the ROC is between mod Z is between mod A to modulus 1 by A. Modulus A to modulus 1 by A. First thing is, let us construct this diagram in the Z plane. Let us construct this diagram in the Z plane. And there are two poles and two radius involved here. Now, you yourself see what are the poles. I have written the answer in front of you. Now, what are the poles here? When you may take from the denominator Z equal to A and 1 by A. At A and 1 by A, you will get 1 upon 0 appearance. Okay, and that is known as the pole. Okay, that is known as the pole. Okay, at Z equal to A and 1 by A. Okay, so what is there? Let me also write down the poles here. This is one pole, A is less than 1, and then this is 1 by A. Okay, what is the mod Z you want? The mod Z is between A and 1 by A. Okay, A and 1 by A. A and 1 by A. Okay. Yeah, winter child will come to that later. But I don't know when the time permits. But okay, see what is the causal? Right-sided signal. For causality, what you want? Hn should be 0 for n less than 0. Okay, listen to me orally. Okay, so ROC from Z transform you want to answer, na? ROC of the signal must be exterior of a circle. ROC of the signal must be exterior of a circle. That first case, exterior, I have drawn, na? Because causal means the Hn, impulse response of the signal, is right-sided. Okay, winter child. Now see, this is what is the picture coming. Neither exterior of circle nor interior of circle. It is coming up as a region between two concentric circles, which we call it as annular region or a finite ring. Okay, this is the next case of ROC, which is going to be known as a finite ring ROC. A finite ring ROC. Okay, a finite ring ROC. See, so what I have learned till now? Okay, ROC will always look like circular regions. Okay, and all the circles are centered about origin. I mean, you will never get any such ROC. This is the circle and ROC is outside the circle. Impossible. Okay, ROC will look circular, and that too the circle centered about origin, not any random circle. Okay, number one point. ROC cannot contain any poles. You all know what is a pole. Okay, pole is the point where Z transform is undefined. ROC is the region where Z transform is defined. Complementary, they can contradicting to each other, they cannot be together. Okay, leave the third point, go to the fourth one. Third one example I'll take. If xz is rational, okay, and xn is right sided, important point, right sided signal. The first case, ROC is the region in the Z plane. Okay, ROC is the region in the Z plane. Okay, outside the circle of radius equal to largest magnitude of the poles. Okay, or simply call it as ROC is the region outside, okay, the outermost pole. Which type of region? Circular region. Exterior circular region. Okay, I will explain the concept of this outermost pole. Okay, now if a signal is left-sided, okay, then what about the ROC? If the signal is left-sided, okay, then the ROC is the region in the Z plane. What type of region? Interior of a circle. Interior of a circle. Okay, that will be inside the innermost pole. I will explain you this outermost and innermost pole. Okay, and if a signal is two-sided, okay, that's what I just told you. ROC will be a ring in the Z plane. ROC is the ring in the Z plane. Okay, okay, ROC will be a ring in the Z plane. Now, let me ask you this way. Suppose I tell you an information that a signal xn has the Z transform xz, and this Z transform xz has the poles at Z equal to 1 by 2 and Z equal to 3. These are the two poles. Okay, these are the two poles. Tell me the possible ROCs. Tell me what can be the possible ROCs. So I have told you three types of ROCs till now, na? Okay, exterior, interior and a ring ROC. Remember, exterior, interior and a ring ROC. This is what is known to us. Okay, exterior and interior and a ring ROC. So what is the first possible ROC? Think this way. What is the first possible ROC and what are the poles here? Let me only construct the poles first. Okay, pole is at 1 by 2 and another pole is at 3. Okay, what can be the first possible ROC? Exterior ROC. Exterior circle ROC. Okay, but if you have to draw exterior, okay, it should be outside which pole? Okay, earlier the question that I have taken had only one pole, z equal to a. You took mod z greater than mod a. Okay, but can you take here mod z greater than half? Okay, suppose you take mod z greater than half as the exterior ROC. What will come? Pole will come. Pole should not come. Pole should not come. So that is why I mentioned if it is an exterior ROC, it will be outside the outermost pole. Outermost pole, that means which is the farthest from origin. Outermost pole. That is what was mentioned here. That is what I have written here very, very clearly. Outside the outermost pole. Clear? Okay, yeah. Okay, exterior ROC, mod z greater than outermost pole, which is 3. Second possible ROC is the interior ROC. Is the interior ROC. Okay, mod z. Now interior, if you want to take interior ROC means interior of a circle. Can you take interior of 3? Again, if you take interior of 3, a pole will come which is not allowed. So you cannot take interior to 3. You have to take interior of innermost pole so that no other pole comes inside. Mod z less than half. Interior of innermost pole. Innermost pole. Okay. Innermost pole less than half. Third case. What is the third possible ROC? Finite ring ROC. Okay. What is a finite ring ROC? It is a ring between, okay, two concentric circles. What should be the center of the two circles? It is between poles actually. One circle starting at half, one circle radius 3. Okay, and then you get the ROC between 1/2 to 3. Between 1/2 to 3. That is the third possible ROC. So given these two poles, if I ask you how many possible ROCs, you can say 3. If I ask you what are the ROCs, this is the answer that you can give it to me. Clear everybody? And then I have also explained you this outermost and innermost pole concept. ROC should not contain any pole. So that means if you are going outside, you should go outside the outermost pole. If you are going inside, you should go inside the innermost pole. Okay. Otherwise, if you are talking about a two-sided signal, ROC is a ring between two concentric circles, also known as annular region. Correct, Shravan Kumar. Okay. Okay. Now, one more point. If xn is of finite duration, okay, or finite length rather, okay, ROC is entire z plane except 1 or 2 points, that is 0 or infinity. That is 0 or infinity. Let me write down this particular condition here. Okay. This is a simple one. Forget. Let's go to a better question. You can directly take down this result. Take any finite length signal and see what can be the ROC. Finite length signal means signal given in the form of sequence or in the form of impulses. Okay, 2, 1, 3, 4. Suppose take this as example. Try to find the Z transform and write down the ROC. So this is easy one. Okay, majorly what conceptual questions will come? Right-sided, left-sided and two-sided. That is what you have to be ready with. Okay, that is what you have to be ready with. Okay. So now these are the important points about ROC. Acha. One thing, one question I will show you. Okay. Yeah. Just tell me this answer. For the DT signal given below, find the ROC. Okay. A combination of two signals has been written here. What is this? Let's try to solve this. Okay. So I told you now, whenever two signals are added or subtracted, in terms of ROC, you have to take the intersection, common ROC. Okay. So what is the ROC for the first one? Okay. A power n un ROC. A power n un ROC, mod z greater than mod a. What is A? 1/3. Okay. What about the ROC of this one? Okay. Mod z less than A power n u minus n minus 1. The ROC mod z less than mod a. A is half here. Okay, and then you have to think about the intersection of them. So mod z should be greater than 1/3 and should be less than half. Greater than 1/3 and less than half. So ROC is between 1/3 to half. Greater than 1/3, less than half. 1/3 less than mod z, less than half. One by 3 less than mod z, less than half. Correct it is? Okay. This is the answer. Next question, you tell me the answer now. For the signal shown below, find the ROC. Find the ROC. Okay. right? One by 2 power mod n minus of minus 2 by 3 power n un. Come on. Yeah, Winter Child, correct for the previous one. Thank you, Shanmuka. Thank you for your appreciation. God bless you. Keep preparing hard and really prove all the points in the exam. You get marks in the exam, that is more than happy. I am automatically happy if you get marks in the exam, as many marks as you can get. Okay, keep doing the hard work. Okay, half power mod n minus of minus 2 by 3 power n un. Okay, minus of minus 2 by 3 power n un. Come on, let's do this. Let's do this. What is this? What is this? Now see, I want to write down the ROC once again. Now see, half power mod n. Okay, a power mod n. Just now I told you, no, for a power mod n, what is the ROC? The ROC is between mod a to modulus 1 by a. Okay, so here ROC will be half to reciprocal of half, that will become 2. This is first ROC. Intersection with the next ROC. Right sided signal, mod z greater than mod a. Okay, a is minus 2 by 3, but you have to write down modulus of it. Don't write minus 2 by 3. Anyways, this is radius. Na? Radius can't be negative, so you have to write down 2 by 3 only. This is the next ROC. Okay. Now, what is the common between them? What is the common between them? Okay, Vignesh, if these two are interchanged, previous question, no ROC will come. Correct. I'll tell you that first. That also is possible, no ROC. But okay, let me complete this first. Okay, see 1 by 2 to 2. Okay, if I write down the sequence 1 by 2 and then will come 2 by 3 and then will come 2, na? Okay, so if you want common half to 2, this is one possibility, and greater than 2 by 3, that is the next thing. Okay, greater than 2 by 3. So that means between 2 by 3 to 2, if you want the common condition, 2 by 3 to 2. Final ROC, 2 by 3 to 2. 2 by 3 to 2. Okay. Yeah, previous one, that is also a twist. Vignesh is asking us a doubt. I'll put it for everyone. That twist also you should know. By chance, if the question was, okay, I'll swap the numbers, half power n, un, minus of 1 by 3 power n, u of minus n minus 1. Okay, now if I write down the ROC for this one, right sided mod z is greater than half. For this one, left sided mod z is less than a and a is 1 by 3. Now tell the common ROC here. Mod z greater than half but less than 1 by 3. Intersection of them. Mod z is greater than half, mod z is less than 1 by 3. Mod z is greater than half, mod z is less than 1 by 3. Tell me. Greater than half, less than 1 by 3. Okay, so what is that? If mod z is greater than half, it cannot be less than 1 by 3, na? Can it be less than half, greater than 0.5? So it is already greater than 1 by 3. It cannot be less than 1 by 3. That means there is no intersection. Okay, so there is no common ROC. No common ROC. That means no ROC means no Z transform. That means the Z transform, okay, the Z transform of the given signal xn does not exist at all. Doesn't exist. So this also you should know. The Z transform does not exist at all. Okay. No common ROC, no Z transform. That also is a possibility. Okay. That also is a possibility. Okay. Now, as I told you, ROC in the Z transform, first I will only discuss basic Z transform and ROC. Properties of Z transform are there, but I have discussed ROC because I first wanted to go to the DTFT. I told you now, after DTFS, DTFT. After the DTFS, DTFT. Okay, see here. Okay. So, what is the relation between the DTFT and the Z transform? See, Z transform is defined as x of z defined by summation of xn z raised to the power minus n, n is minus infinite to infinite, okay, where z is a complex variable generally written in the form of r e power j omega, okay, where r e power j omega, r means magnitude of z and omega means the angle z, the phase part, which is the frequency also. Okay, now what if we have taken r equal to mod z equal to 1? if r equal to 1 you take, z becomes e power j omega. Okay, right, z becomes e power j omega, and DTFT is nothing but the z transform at z equal to e power j omega. That means evaluated over unit circle, because what is this mod z equal to 1? Mod z equal to constant, anyways I told you circle, but how much radius here? Unit radius. So this is a unit circle for us. Okay, this is the unit circle for us. Okay, so what is DTFT? Okay, DTFT then becomes, if I put z equal to e power j omega, x e power j omega, and given by the formula summation minus infinite to infinite. Okay, put down xn z power minus n. So what is z power minus n? Minus n over this, it will become e power minus j omega n. This is nothing but the DTFT formula. Okay, x e power j omega, or you can simply call it as x omega. Ultimately it depends on omega, na? R has gone. Okay, x e power j omega depends on omega. Right, so this we normally call it as x omega. Now you see it is analogous to the CTFT formula. Okay, that is why I told you, na, CTFT and CTFS we discussed, so we wanted to now go to the DTFT. Okay, so DTFT, it is just like the CTFT formula. If you correlate, what was the CTFT formula? Okay, the CTFT formula, x of omega is given by, of course, in continuous time domain integral, in discrete summation. That analogy you have to map. Okay, discrete time signals cannot be integrated, they will be summed up. Okay, this is integral minus infinite to infinite xt e power minus j omega t dt. Okay, other than the integral and summation, do you see any other difference? Integral of the signal xt e power minus j omega t, summation of the signal xn e power minus j omega n. Okay, okay, so this is the DTFT and CTFT formulas are similar. Okay, but because I have, I wanted to discuss the relation between DTFT and Z transform, important in exam as well. Okay, I can say that the DTFT is the value of Z transform by putting Z equal to e power j omega. That means I have used the value of mod Z equal to 1. Okay, R equal to 1. But as I just now told you in the previous example, there may be possibility Z transform of the signal itself is not defined. Or if the Z transform is defined, it is only defined within the ROC. Outside the ROC, no Z transform. So whatever the ROC is there, okay, that ROC should definitely include the unit circle. That ROC should definitely include the unit circle. Let's speak with example. Okay, so guys, example. Xn is suppose half power n un. Okay, what is the Z transform of this? Just now we discussed, na, 1 upon 1 minus az inverse. 1 upon 1 minus half z inverse. 1 upon 1 minus half z inverse. That is the Z transform of this. 1 upon 1 minus half z inverse. Mod z greater than mod a. That is mod z greater than half. Okay, this is the Z transform. How can you convert to DTFT? By putting z equal to e power j omega. Okay, what do you get? You get DTFT by putting z equal to e power j omega. Then this is x e power j omega or simply x omega. How much? 1 upon 1 minus half. Okay, z equal to e power j omega. So z inverse means e power minus j omega. That's it. This is the DTFT. Now see the another question here. Xn, if the question was suppose 2 power n un. What is the Z transform? Still the Z transform formula is 1 upon 1 minus az inverse. For a power n un, Z transform always defined. The only thing is you have to write down the ROC. What is the ROC? Mod z greater than 2. Okay, now I want to convert to the DTFT. Z equal to e power j omega gives me the DTFT, right? Okay, and the DTFT answer of this signal is 1 upon 1 minus 2 e power minus j omega. Okay, as soon as you write down this one, this is wrong. The DTFT of this signal will not exist actually. If you try to calculate by the DTFT formula also, na, okay, by this formula, you will get that DTFT of the second case will not exist. Why? See the ROC. Okay, when you are putting z equal to e power j omega, let me again clarify. Z equal to e power j omega will come if you take the magnitude mod z equal to 1. Okay. If you see in the previous case, mod z is greater than half. Okay, so is mod z equal to 1 allowed or not? Yes. Greater than half, any value allowed. So mod z equal to 1 allowed. Okay, mod z equal to 1 allowed. Mod z equal to 1 is what? As I told you, unit circle. So whether the unit circle is inside the ROC? Yes. But see, now second case, mod z is greater than 2. Now, when you say mod z greater than 2, so mod z equal to 1, allowed or not allowed? Mod z cannot be 1. Any value greater than 2 allowed, mod z cannot include 1. Okay, so what can I say here? Mod z not equal to 1. That means ROC here does not include mod z equal to 1. Okay, does not include unit circle. The ROC does not include unit circle, and hence the DTFT of the signal cannot be defined. DTFT not exist. This is one important point that you have to very carefully note down here. DTFT will not exist. See, that's what. Okay, so DTFT x omega x e power j omega is summation minus infinite to infinite xn e power minus j omega n. Okay, DTFT is also equal to Z transform evaluated by Z equal to e power j omega. Okay, DTFT will only converge, important point, very important point. Okay, if ROC contains the unit circle. Otherwise, DTFT cannot be defined. That is one important point. Otherwise, the DTFT cannot be defined. For DTFT to be defined, okay, the ROC should definitely include the what? Unit circle. Okay. Now, next. Okay. Now, next important point, that is unlike CTFT, okay, that DTFT is a continuous and periodic function with period always equal to 2 pi. Okay, this is unlike CTFT. CTFT, I never said that Fourier transform is periodic. DTFT is always periodic. Why? Because see, you know the x omega formula, na? Summation of xn, okay, summation xn e power minus j omega n. Okay, when you write down x omega plus 2 pi, that too period is fixed as 2 pi. What will happen? Summation of xn e power minus j omega plus 2 pi. I am simply replacing omega as omega plus 2 pi. And then what you get is summation of xn e power minus j omega n e power minus j 2 pi n. E power minus j omega n, e power minus j 2 pi n, and the value of e power minus j 2 pi n, you solve, will get it as 1. Cos 2 pi n, okay, minus j sin 2 pi n. Sin 2 pi n 0, cos 2 pi n 1, because n is integer. In CT time, the t will not be an integer, it can be any value. So that is why this is 1. So what is left? If this is 1, what is left is the original DTFT formula, summation xn e power minus j omega n. So DTFT of any signal is periodic with a fixed period of 2 pi. This is not valid in the CTFT. Okay, and that is why while defining the IDTFT formula, okay, it's only necessary to consider the result for one period. Okay, from x omega, if you know the x omega for one period, what is this one period? 2 pi. Okay, so what is the IDTFT? Xn. Okay, extracting xn from x omega, 1 upon 2 pi integral x omega e power j omega and d omega. This formula is again same as inverse Fourier transform in the continuous domain, but the difference is only limit. Why only a limit of 2 pi is required? This limit of 2 pi, see, when I have written limit integral over 2 pi, it means integral over one time period. You can take 0 to 2 pi, or you can take minus pi to pi based on the nature of the signal, symmetry of the signal given. Okay. Clear? Okay, so only difference is limit. In the inverse Fourier transform continuous domain, the limit was full, minus infinite to infinite. Here only integral for one time period sufficient. Why? Because x omega is periodic with the period of 2 pi. Anything after 2 pi is repeated. Okay, so whatever information about the signal can be obtained is enough from the one period of the DTFT. One period of the DTFT. This is some result unlike CTFT. Okay, rest the formula is same. The final DTFT formula, limit difference will be there. Okay. What is next? Yeah, convergence. Same, Dirichlet's condition. The signal must be absolutely summable. In CT domain, of course, I told you integral. Here it is absolutely summable. That is, summation of modulus xn must be finite. Summation of modulus xn must be finite. Then only the DTFT will defined. Okay. Now, next, what I have done is, before we go to the question, like I have done for CTFT, all important formulas that you should know directly, onto which question can come directly or indirectly. Direct question, 1 mark. Indirectly, one Fourier transform mixed with one property, like we have seen in CTFT, like 2 mark question can also be built. Okay, so important DTFT pairs. Okay, suddenly why I have written sine omega naught n, or is it coming up from some typo error? Achho, no, the slide moved on, sorry, yeah. This is the first one, yeah. Impulse, again having the DTFT one. For 1, the DTFT is 2 pi del omega. For e power, now see, many of the formulas are same as CTFT, are similar to CTFT at least, okay. So I will, I'll just use a code. I will just use a plus symbol which will mention that this is similar to CTFT. See, I'll keep putting this code. This is same as CTFT. This result is same as CTFT. E power j omega naught n Fourier transform 2 pi del omega minus omega naught. Same as CTFT. Cos omega naught n Fourier transform, that impulse, okay, del omega minus omega naught plus del omega plus omega naught. Same. Okay, same result for sine omega naught n, same as CTFT. A power n, now this is different arrangement. A power n, from Z transform I told you, na, 1 upon 1 minus AZ inverse Z equal to e power j omega. Okay, but that ROC including unit circle gives me this result finally. Mod A should be less than 1. That is why for the first question, half power n DTFT defined. For the second question, 2 power n un DTFT not defined. I explained you this point already. Okay, A power n u minus n minus 1. Okay, again, sorry, this will be minus here. Minus 1 upon 1 minus a e power minus j omega mod a greater than 1. N a power n un, a e power minus j omega upon 1 minus a e power minus j omega whole square for mod a less than 1. Okay, now, sorry, unit step signal 1 by j omega plus pi del omega. Okay, rect n by 2n. Okay, sine n plus half omega upon sine omega by 2. Sampling an. Now this one is similar to CTFT. Pi by a rect omega by 2a. Okay, pi by a rect omega by 2a. Okay, right, sampling an. Ideal low pass filter case. Again, remember this important thing was discussed with the case of ideal low pass filter. Okay, now important properties. Properties also, many of them are same as CTFT. Linearity, okay, if signals are added or subtracted, Fourier transform added or subtracted. Time shift is equal to phase term or phase shift in the frequency domain. Same property, e power minus j omega n naught into x omega. Frequency shift also same property, e power j omega naught n xn, x omega minus omega naught. One additional property, half period shift. Okay, because DTFT is periodic having a period 2 pi. There is no period in CTFT. So what is half period? Pi. So when you put omega naught pi or minus pi anything, here it becomes e power j pi n. E power j pi n, when we calculate we get minus 1. Okay, e power j pi n we get minus 1 power n into xn. Okay, but not very important property. Okay, then time reversal, frequency reversal, same, x minus n DTFT x minus omega. X conjugate n, okay, x conjugate minus omega, same. Time difference. Now in continuous time domain you talk about derivative and integral. Here it is difference and accumulation because discrete signal cannot be differentiated or integrated. So we talk about the difference xn minus 1. But this is not a new property. You can automatically write down this result from time shift also. Xn minus 1. What is there? Xn minus 1. Okay. X omega e power minus j omega. Okay. That is what I have substituted. X omega. Okay. Common 1 minus e power minus j omega. Summation property or accumulation property, summation of xk, x omega by 1 minus e power minus j omega plus pi x0 del omega. Okay. Now frequency differentiation, this is same, frequency differentiation or n times property. Or like t times I told you, n times, n into xn, j d by d omega x omega, exactly the same it is. Okay, convolution in time, multiplication in frequency, x1 omega into x2 omega, multiplication in time, 1 upon 2 pi, convolution in frequency, exactly same as CTFT. Modulation also exactly same, xn cos omega naught n, the spectrum is shifted to higher frequency centered at plus or minus omega naught, amplitude divide by 2, exact same. So at least most of the properties that you have seen now is exactly the same. Okay, Parseval's also similar, only thing is the limit difference. See, what was the Parseval's theorem which talks about the energy of the signal? Okay, energy of the signal, summation modulus xn square is 1 upon 2 pi, integral over 2 pi mod x omega whole square d omega. I will just put a plus sign because it is similar, only thing is in the continuous time domain, it was integral minus infinite to infinite modulus x omega whole square d omega. Okay, in the CT domain, this was the formula, energy is integral x square t dt, okay, given by 1 upon 2 pi integral minus infinite to infinite modulus x omega whole square. Here the integral required only for one time period. Why? Any calculation required on x omega is sufficient for one period because beyond that it is repeated. Okay, so that is why integral only for one time period, that is integral, okay, minus pi to pi, or as I told you based on the symmetry, integral 0 to 2 pi, anything. That is the only difference, rest the formula is same. Okay, thank you Senthil. Okay. Now guys, okay, the gain at low frequency, the zero frequency, where in the CTFT that was area property, here it is the sum property. Why? Because what was the x omega? Summation xn e power minus j omega n. As soon as you put omega 0, e power 0 becomes 1, you get summation xn. In CTFT, I call this as area property. Here it is summation xn, x0, that is low frequency gain. Then the gain at high frequency, when you take omega equal to pi, because one spectrum is minus pi to pi, pi is known as the highest frequency. Okay, pi will be known as highest frequency. So when you put omega equal to pi, again, what is this formula? Summation of xn e power minus j omega n. When you put omega pi, you get e power minus j pi n. What is e power minus j pi n? Will be minus 1 power n. So this is summation minus 1 power n into xn. Let's see where, as and where this is required. Okay. Now this is the question for you. Okay, the MSQ question. Time is 6:30. We started morning 10, around 10. And I'm seeing after 6, the attendance has sharply started dropping. As I told you, I have not put any upper limit on timing from my side, but as and when you are motivated. Okay, we started with more than 100, but now the attendance has dropped. Okay, let me see how it is responding for some more time. Okay, but this is not promising as of now. Okay, take this next question. Take this next question. For the signal shown, okay, x e power j0. Okay, x e power j0 and x e power, see, for the signal shown, xn has the DTFT x e power j omega. Now any symbol of omega you can use. Okay, omega is frequency only. I told you just to differentiate in DT domain signals, I take this symbol as omega, or you can simply call it as x omega only, whatever representation. Okay, so option number A, I want to calculate x0. I just told you one property, sum of series. What is x0? What is x0? It is simply but nothing but summation of xn. So what is going to be the summation of xn? What is going to be the summation of xn? Okay, what is going to be the summation of xn? Add up all the values, na? Okay, minus 1, 0, 1. Okay, I can write down the xn. Let me write down the xn in the sequence form only. It will be better. What is this xn? Okay, if I write this in the sequence form, the first value is minus 1, then 0, then 1, then 2. This is the origin. The value at origin is 2. Then 1, 0, 1, then again 2, 1, 0, minus 1. Okay, this is the signal xn given to me. So what is the summation of the signal xn? I'll write down the xn. Okay, I'll just directly add up from there only. Okay, minus 1 plus 0 plus 1 plus 2 plus how much? Okay, minus 1, 0, 1, 2, 1, 0, 1, 1, 0, 1, then again a 2, just adding up all these values, then 1, 0, minus 1, okay, then plus 1 and 0 and again a minus 1. So here minus 1, 1 cancel, here minus 1, 1 cancel, 2 plus 1, 3, 2 plus 1, 3, net answer is 6, okay, net answer is 6, okay, so this value is 6, correct, so A is correct. Okay, then let me go to the simple one. Okay, x e power j omega d omega or x omega d omega. See, now what is the IDTFT formula? One more result actually I will add up here. Okay, and that I'll write it as property only, and that is area under x omega. X omega is still a continuous function. Xn is a discrete function. What is the area under x omega? What is the area under x omega? So see, what is the IDTFT formula? IDTFT formula is xn equal to 1 upon 2 pi integral x omega e power j omega and d omega, correct? Integral over 2 pi. Okay, so just you have to put n equal to 0. Okay, so if you put n equal to 0, you get integral of x omega d omega, because e power 0 will be 1. Okay, integral x omega d omega. This 2 pi I am shifting on the right side, 2 pi x of 0. That is the property. Okay, so C option, I'll start with the C option here, easy one only. Integral over 1 pi period means integral minus pi to pi. Okay, so C option, integral minus pi to pi means integral over 1 period, x omega d omega. Okay, and that is what? That is given by 2 pi x0. The value of the signal at origin, is how much? At origin the value is 2. So this answer is going to be 2 pi into 2, that is 4 pi. that is 4 pi, and here it is written as 4, so that is wrong. Okay. Whether it is typo error, I don't know. Okay, but let's take it as wrong. The correct answer has to be 4 pi. Okay, then see, B and D are same only. Integral minus pi to pi modulus xc power j omega whole square d omega. Okay, whether 28 or 28 pi, what is the correct answer, or whether both may be wrong? MSQ means one answer correct also possible. Okay, so now I'll talk about B or D. Okay, where integral for one period, okay, modulus of x omega square d omega is related with the Parseval's theorem. Just now I discussed the Parseval. If you apply the Parseval's has 1 by 2 pi here, so I will shift it on the right side, 2 pi into the energy of the signal, or 2 pi energy of the signal formula is summation x square n. Okay, summation x square n. So this is going to be 2 pi summation of the square. Now see, this is summation xn. All values of xn are written. You just have to take the square. So minus 1 square, then 0 square, then 1 square, then 2 square 4, then 1 square, then 0 square, then 1 square. Again 2 square is 4, then 1 square, then 0 square, then minus 1 square. How much it becomes? 6, 7, 8, 12, 13, 14. 2 pi into 14, 28 pi. Yes. So wherever 28 pi was there, I will tick mark. 28 pi is here. Okay, so this is wrong. So correct answer for this question, dear. Correct answer for the question A and D. Please tick mark. The correct answer for the question is A and D. The correct answer for the question is A and D. One important thing here. And before I forget, and that is the password for today's PDF. And just randomly it came to my mind. I randomly decide the password. The PDF will be shared in my Telegram group. I already shared you the link of the Telegram group. I will share you one more time. Okay, but the PDF as a rule will be password protected. Please do not ask for any passwords or do not share any passwords in the Telegram group. Okay, because see, you have been dedicatedly sitting from morning 10 at 6:30. Okay, so if you are watching the video, then only the PDF is helpful for you. Okay, if you help yourself, then I can help you. Simple logic. Okay, simple logic. Okay, but for your convenience, I will just share the link of the Telegram group once again. If you are not connected, this is where the PDF will be obtained. You can join this Telegram group. Okay, if you wanted to get the PDF, this is the Telegram where the PDF will be available to you. I have shared you the link now. I think I shared it earlier also. The PDF will have the password DTFT, everything in small. DTFT, everything in small. Okay. Okay. Yeah, look into this question. Let xn be a discrete time signal whose z transform is xz. Okay, which of the following statement is or are true? Tell me, which of the following is or are true? Gate 25, 1 mark MSQ question. Okay, let's do it. Okay. Okay, whose z transform is xz, which of the following statement is or are true? Okay, see, the DTFT of xn always exists? No. Okay, DTFT not always exist. Okay, the ROC of xz neither contain pole nor zeros. This is a wrong statement. Na? ROC does not contain poles. Zeros may be there, may not be there. Okay, there is no conclusion of ROCs with respect to zeros. Okay, the DTFT exists if the ROC contains unit circle. Correct statement. That is what I already taught you. The DTFT exists if the ROC contains unit circle. Next, if xn equal to alpha del n, where del n is the unit impulse and alpha is scalar. See, for impulse signal, alpha is just constant. Na? For unit impulse, already I told you. The ROC is entire z plane. For unit impulse, only for delta and ROC is entire z plane, already discussed. So C and D, two options correct for this MSQ question. Currently, just Gate 25 1 mark question. Okay. Next. The z transform of a discrete time signal is given to you, xz equal to 4z upon z minus 1 by 5, z minus 2 by 3, z minus 3. Okay, with ROC equal to R. Which of the following statement is true? The discrete time Fourier transform of xn converges if R is mod z greater than 3. R means ROC. DTFT converges if ROC includes the unit circle. Now see, if ROC is mod z greater than 3, that means mod z cannot be 1, and if mod z cannot be 1, that means no DTFT. DTFT cannot converge. A option is wrong. Okay, B option. DTFT of Xn converges if R is between 2 by 3 to 3, between these two poles. Okay, so yes, if it is between 2 by 3 to 3, the one is between these two, na, mod z is equal to 1 allowed. If mod z equal to 1 comes in between, if unit circle comes in between, DTFT is existing. Okay, DTFT is allowed. Okay, so B answer is correct. Okay, which of the following statement is true? Now, this was a MCQ question actually, this is not MSQ. Okay, so you can stop at one answer. As soon as you get one answer correct, you can stop. B is the correct answer. But let's see why not C and D. At least that concept should be clear. This DTFT of Xn converges if R is such that Xn is a left-sided sequence. Now, if Xn is a left-sided sequence, what is the ROC? For a left-sided signal, what is the ROC I told you? ROC is interior of a circle, inside innermost pole. Inside innermost pole. What are the poles, by the way? In the sequence, you can write down the poles as 1 by 5 and a 2 by 3 and a 3. So, innermost or the innermost means the smallest pole will be 1 by 5. Smallest magnitude pole. So, ROC will be mod z less than 1 by 5. Now, if mod z is less than 1 by 5, can mod z be equal to 1? No, not equal to 1 means no DTFT. If mod z equal to 1, not allowed, no DTFT. That is why C wrong. Anyways, only B is correct. Okay. Now, D. The DTFT of Xn converges if R is such that Xn is a right-sided sequence. So, for right-sided sequence, what is the ROC? Exterior ROC. But exterior means outside what? Outside outermost pole. So, 1 by 5, 2 by 3, 3. This is the outermost pole. Largest magnitude is 3. So, mod z greater than 3. Okay. This is almost same as option number A. Okay. Mod z greater than 3 means mod z cannot be 1. If mod z cannot be 1, so no DTFT. This is again a question on concept of ROC and connection with DTFT. Gate 23 1 mark. There was a similar question discussing about the ROC and DTFT, important one. So, multiple times I have only discussed this particular parameter. Okay, ROC and DTFT connection. Next one. Okay, gate 21 2 marks question. Please solve this. Please solve this. Okay, this is a slight better one. Okay, let us solve this. Consider the signal xn equal to 2 power n minus 1 u of minus n plus 2 and yn equal to 2 power minus n plus 2 u of n plus 1, where un is the unit step sequence. Let x e power j omega, y e power j omega be the DTFT of xn and yn respectively. What is the value of this given integral? 1 upon 2 pi integral 0 to 2 pi x e power j omega, y e power minus j omega d omega rounded off to 1 decimal place. Okay, rounded off to 1 decimal place. Now see, this one is a good question. Okay, these are the two signals given, xn and yn. Okay, x e power j omega, y e power j omega be the DTFT. Okay, what is the value of this integral? Okay, see, in this integral, there are two different functions multiplied, and let us say that the multiplication of them is z omega. Okay, z omega, which is equal to x e power j omega, I'll call it as x omega only for our simplicity, and the other one is y e power j omega, means y minus omega. Okay, that means two different Fourier transforms are multiplied. Okay, and multiplication in frequency domain happens when there is convolution in time. Okay, so what should be Zn in time domain? Convolution. X omega is the DTFT of xn. Convolution with y minus omega. Y minus omega is the DTFT of yn. So convolution with y minus n. Correct, na? Time shifting, time folding property. Okay, so Zn is xn convolution with y minus n. That is one thing. Xn convolution y minus n. Okay, now what is required? Okay, this question now looks like 1 upon 2 pi integral for one time period z omega d omega, and area under DTFT property I just used in the earlier question also. This is nothing but z0. What is the z0? Where Zn is xn convolution y minus n. Okay, we want z0. We want the z0. Okay. Okay. We want the z0. What is the Zn? I have written the Zn as xn convolution y minus n, or if I want to open this formula, convolution formula, summation of xk, okay, summation of xk, okay, y of minus of n minus k. In the y we replace n by n minus k, okay, summation xk h of n minus k. So you can write as y of minus n minus k. K is minus infinite to infinite. But important point is I only want the result for n equal to 0. I only want z0. So what is z0? That becomes actually simple. Summation k is minus infinite to infinite x of k, and as soon as you put n0, okay, you'll get minus of minus k, that is plus k. So summation xk yk. Summation of xk into yk only. Summation of xk into yk. Okay, if you have by chance any confusion, is this representation, suppose call it as hn. So what will you write? H of n minus k here, correct? Now what is h of n minus k? If you replace n by n minus k, you will get here na y of minus of n minus k. That is what I have done here. Okay, hope that sounds clear to you now. Okay, and as soon as I have put okay n equal to 0, I am only left with yk. Now let me put down the data. This becomes summation k minus infinite to infinite xk. What is the xk? The data is given to me. Xk will become 2 power k minus 1 u of minus k plus 2. 2 power k minus 1 u of minus k plus 2 multiplied by yk. What is going to be yk? Okay, 2 power minus k plus 2 u of k plus 1. 2 power of minus k plus 2 u of k plus 1. Okay, 2 of minus k plus 2 u of k plus 1. Let me tally it again. Correct. Okay. Now again, as soon as I told you, as soon as you get unit step inside the summation, okay, you have to modify the limits. Where is the unit step one? Minus k plus 2 has to be greater than equal to 0. And the other one, k plus 1 has to be greater than equal to 0. That means from here, k has to be less than equal to 2, and from here, k has to be greater than minus 1. Oh, so only few limits will come, na? K should be less than equal to 2, k should be greater than equal to minus 1. That means k starts from minus 1 and it goes up to 2. K is minus 1 to 2, and because it is discrete domain question, only minus 1, 0, 1, 2, only 4 points. The summation will be simple. Okay, so how will I write down the summation now? This summation, the z of 0 will become, see here, this z of 0 will become, I'm telling you now, the board has actually become tired, the system has become tired. Okay, so this is z0, I'll write in here only. What is going to be this z0? Okay, this becomes summation k equal to minus 1 to 2, okay, 2 raised to the power k minus 1, unit steps are anyways 1, into 2 raised to the power minus k plus 2, okay, and then this is summation k equal to minus 1 to 2. When you multiply this to 2 power k, 2 power minus k will get cancelled. 2 power minus 1 into 2 power 2 will be 2 power 1, only constant left. Okay, when you solve this product, okay, when you add the limits at the power, it will be only 2 power 1, clear? Okay, now that means, okay, 2 power 1 is 2 power 1, it does not depend on k. So for any value of k, this is 2 power 1, but how many values of k? Minus 1, 0, 1 and 2, only 4 fingers, only 4 values on the fingertip. Okay, 2 plus 2 plus 2 plus 2, answer for the question is 8. I wanted z0 and that I have calculated, answer for the question is equal to 8. But this is a good question. Mark, this is a good question from the DTFT. Good question. Yeah. Now, next model of question from here, which is important, MSQ question here is, a system whose input-output relation is given to you, whether it is a high-pass filter, FIR filter, band-pass filter, or HZ is causal or not. Okay. So, see, causality depends, see, whether the input-output relation, the output is required at n, okay, the input is also required at n, which is present, n minus 1 is past, n minus 2 is more past. So, output depends only on the present or past. Okay, the system is definitely causal. You don't have to actually calculate HZ. From the IO relation only you can say the system is causal, but it is MSQ. Okay, now whether it is a high pass filter or a band pass filter, and what is the FIR basic condition, FIR or IIR filter, see here. Okay, you can just check a very simple calculation here. Okay, we'll just check a very simple calculation. What is Yn? Okay, Yn is x of n minus twice of x of n minus 1 okay, plus of x of n minus 2, plus of x of n minus 2. Okay, what is the impulse response of a system? Okay, impulse response of the system is whenever this definition is earlier discussed only, whenever the input applied is a delta n signal, whenever the input applied is a delta n signal, the output of the system is known as impulse response. Okay, so replace xn by delta n. Okay, so impulse response of the system will be when input is delta n, so then minus 2 delta n minus 1 plus delta n minus 2. Plus delta n minus 2. Okay, so what is this? If you want to write down in the sequence, delta n, that is the impulse at origin. How much value? 1. Okay, origin, delta n minus 1, right shifted impulse. How much value? Minus 2. Delta n minus 2, impulse at n equal to 2. How much is the value of the signal? 1. So this is 1 minus 2 and 1. Now what is the length of this signal? What is the length of the signal? The length of the signal is 3, I mean finite. And whenever the length of the impulse response is finite, that is what is FIR. Okay, FIR, finite impulse response. That is what is FIR, finite impulse response. Okay. Yeah, we have to compute Z0, Guru Krishna. That's what I have done. Small z0, not capital Z. Small z0. That is what I have done, Guru Krishna, in the previous question. Okay, whenever the length of the impulse response is finite, that is FIR. If the length of the impulse response is infinite, then that is IIR, infinite impulse response. That is IIR. Okay, so it is FIR, B correct. B correct and D was correct. Now, how do you identify what type of filter it is, high pass or band pass? Okay, see here, I will also go to the frequency domain to solve this question because the filter information is based on the frequency information. Okay, see what is HN? The HN has been calculated as 1 minus 2 and 1 based on the given IO relation. Okay, 1 minus 2 and 1, correct? Okay, what is the frequency response or DTFT of this? The DTFT, okay, also known as the frequency response of this, okay, H of omega, and that is given by the formula summation of HN, DTFT basic formula I am using, summation HN e power minus j omega n, where summation required only for these 3 points. Okay, what is the first value of the signal? 1. Okay, but this is corresponding to origin, that is n0, so e power 0. The first term will be e power 0, not required. Then the second value of the signal is minus 2 and e power minus j omega n, n equal to 1. Okay, n equal to 1. The next value, next and the last value of the signal is 1 into e power minus j omega n, n will be 2, n0, n1, n2. Okay, so corresponding value of n and the corresponding value of signal has been substituted. So what is this h omega now? E power 0 is simply 1, so I'll write 1 here, then minus 2 e power minus j omega and plus e power minus j 2 omega. Okay, then write down the low frequency gain of the filter. Okay, what is the low frequency? Omega 0. Okay, low frequency means omega 0. So if you put omega 0, you get 1, e power 0 is 1, so minus 2 is left, and again e power 0 is 1. So 1 plus 1 minus 2, 0. Now, if it is not passing low frequency, it cannot be a low pass filter. It cannot be a low pass filter. Okay. Now, see, normally sometimes only low frequency and high frequency will be enough. High frequency gain. What is the high frequency in discrete time domain? I told you pi. Okay. High frequency means omega equal to pi. Okay. Okay. So, what is going to be the gain at high frequency? 1 minus 2 e power minus j pi plus e power minus j 2 pi. How do you calculate any e power j theta? Cos theta. Okay. Plus or minus j sin theta. Okay. So, e power minus j pi calculations you can do na. E power minus j pi will be minus 1. Cos pi minus j sin pi. Okay. E power minus j 2 pi will be 1. So, how much it is? 1 plus 2 plus 1. Okay. It is 4. So, it is passing high frequency. It has to be high pass. Okay. If it neither passes low nor high, only passes intermediate frequency, then that is band pass. Okay. But for confirmation, I will take a MF gain. MF means mid frequency. Okay, so just for your satisfaction, I will take mid frequency as pi by 2. Any frequency you can take, I have just taken the midpoint. What is h pi by 2? 1 minus 2 e power minus j omega pi by 2 plus e power minus j 2 omega will become pi. Now this is 1 minus 2 e power minus j pi by 2 will be minus j, and e power minus j pi again is minus 1. So this is net equal to plus 2j. Okay. Definitely the gain, if you consider the magnitude, it is 2, 0, 2 and 4. The gain is increasing towards high frequency. What type of filter? The gain is increasing towards high frequency. What type of filter? High pass filter. A, B, D. 3 answers are correct here. 3 answers are correct. If you want, I will just draw a approximate. I will just draw a approximate magnitude spectrum for this particular case. Magnitude spectrum, only the gain value which decides what frequencies will be amplified or blocked. Okay, now you see here, exactly at omega 0 I got the 0 gain, and then as I've shown you, the gain is increasing. Magnitude I'm plotting, the mod of 2j will be 2 and then up to 4. The magnitude is up to what? Up to the 4. Okay, so approximate curve I just want to place here. This is high frequency pi, this is the mid frequency pi by 2, where the gain was 2, here the gain was 4. Okay, so gain is increasing up to 4, and for any real signal, Hn is real, 1 minus 2 and 1, all real values. For any real signal, magnitude spectrum is always even symmetric, I already told you. Okay, so if you want to draw this for the left side as well, I'll just do that part also. So that complete spectrum for one period would be completed here. This will be minus pi by 2, this will be minus pi. Okay, just a even symmetric waveform can be replicated here. This is 4, this is 2. Okay, this is the approximate spectrum of the signal, magnitude spectrum for one period, minus pi to pi, and then rest is repetition. Okay, and that is what is clearly a high pass filter, not an ideal high pass filter. Okay, but yeah, it amplifies more of high frequency, and towards low frequency the gain is smaller. So it is a basic high pass filter only. Correct. So what are the answers correct here for this question? A, B, D. The answers correct for this question has been A, B and D. Got it, everybody? All right, guys. So I think it's time is 7, and now this is the time I would close the session. You carry on with the another marathons when the rest of the marathons finishes. If you want some other topics, I can take, but majorly all important areas are covered, and it's 9 hours of non-stop. I think hardly we have taken total half hour of break or so. Okay. Okay, and attendance is also significantly dropping only. Okay, I will do one thing for you by the time. Okay, especially if you are an EC aspirant, especially if you are an EC aspirant, dear, especially if you are an EC aspirant. Okay, unfortunately the time does not permit to go anymore. Okay. If you are an EC aspirant, go through this session. I have just taken last year only, DFT revision with important question. Enough for DFT. Okay, if you have not studied DFT, that can be enough for DFT. It's a 2-hour video alone on DFT. Okay, so that's why you can go through it. Last year, just before the exam I have taken, so you can go through it and you can practice more questions. Okay, FFT not in syllabus anymore in GATE. Okay, FFT not required for you now. You see the syllabus has been modified after GATE 2020. Okay, so there is a link I have shared. EE students can ignore that DFT at the end moment, but EC student definitely, if you have not studied DFT, go through that DFT part. Alright guys, thank you for your appreciation, and if you have really enjoyed and really learned, do not forget to like the session, put your attendance, share it to all your friends who you know are preparing for GATE. Yeah, definitely my next marathon will be first on aptitude, and then I will plan something for control, because many students are demanding for aptitude. It is most likely the coming Sunday, 1st February. Okay, as I told you, tomorrow already I told you, electrical machines marathon. Okay, tomorrow will be electrical machines marathon. Okay, already I updated you about that. I'll update you once again. I don't know where was that slide, but okay, I'll still try to find out. told you the password also for the PDF. Let it be, guys. It is, I've told you, board is itself tired and it is taking a huge amount of time. Okay, huge amount of time. So I'll update you manually only. Anyways, I told you already. Okay. Okay. A rough plan, at least I'll tell you what is there. Okay, rough plan I'll tell you. Tomorrow, that is 27th January, you will have the machines marathon. Now this is specifically, of course, to EE, and instrumentation students can also watch. 28th Jan, you are going to get the marathon on analog, and analog means again EE, EC. This is more of core to EC, but important for EE as well, and as well as instrumentation student. Anyone can watch. Okay, 29th of January. Okay, you will have power systems, again EE, power system for EE. 30th Jan, you will have two different marathons. Okay, power electronics, core for EE, and analog once again. Okay, because analog is a big subject, so sir will take a second part. Okay, after power electronics session. Okay, so both of them will be on 30th of January. Okay, 31st of January will be EMTL, that is electromagnetics and transmission line. Okay, this is again core to EC. And 1st February will be aptitude. Okay, and so on. Okay, EDC and all, EDC and controls, I will update. Okay, we'll update. Okay, this is there. FFT is not there for EC, EE both. I told you, FFT has been removed from syllabus. Okay, so if you wanted the tentative schedule, this is what is tentative. Okay, if there is any changes, see, the simple thing is be subscribed to the channel. If there are by chance any changes, you will be notified automatically. Okay, and any add-ons that we have to plan. Okay, because a lot many things, offline and online courses both are there, so we cannot do a very long planning, but yeah, at least for the week the plan has been made. Okay, and based on faculty bandwidth, then the next will be coming up. Okay, this is what is there. I'll update, guys, maths, control, whatever after the 1st February, based on the next set of schedule for us. We'll update for EDC also, we'll update for networks also. Don't worry, just don't worry. Okay, guys, so I'll sign off. I hope you remember I told you the password already, DTFT. Okay, the password for today's PDF I will repeat once again, DTFT, everything in small, right? Everything is going to be in small, DTFT. Okay, guys, chalo. See you. Okay, see you in the next marathon. Sunday, 1st February, aptitude. Okay, chalo. Bye bye. Thank you. Stay safe and take care of yourself.